Welcome you all to this international conference on desalination and water treatment, recent technological advancement, challenges and opportunities, along with the annual Congress of Indian Desalination Association InDA 2022. Before we move to our today's proceedings, I would like to invite our chief guest, our guest of honor, Professor K.L. Srivastav, our special guest, Engineer Ravindra Kumar sir, our presiding guest, Professor Ajay Kumar Sharma, our special guest, Professor S.P. Chaurasia, our Dean, Professor Sunil Sharma, and Professor Sushil Saraswat, organizing secretary of this conference, to come on stage and adorn the dais. Welcome, sir. As per our tradition, to offer our prayers to Ma Saraswati before starting any academic event, I would like to invite Garima and Kashish to sing the Saraswati Vandana, and I would like to request all our guests to offer garland and light the lamp before Ma Saraswati.
Om Saraswati.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणाभरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निशेषजाड्यापहा शुक्लां ब्रह्मविचारसार परमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणी मम यदा जाड्यान्धकारपहा हस्ते स्फाटिकमालिकां विदधति पद्मासने संस्थिता वन्दे त्वां परमेश्वरी भगवती बुद्धिप्रदां शारदां बुद्धिप्रदां शारदां.
Thank you.
Thank you. Moving ahead, I would take this opportunity to request Professor Sushil Saraswat, Organizing Secretary and Head, Department of Chemical Engineering, to welcome our today's guest of honor, Professor K.L. Srivastav, Vice Chancellor, Jana and Vyas University. Sir. ये जो भी उनका वेलकम वाला कहते हैं सीक्वेंस Next in line, I would like to invite Professor Ajay Sharma sir from Head Structural Engineering Department to welcome our special guest, Engineer Ravindra Kumar ji, Director, Defence Laboratory, Jodhpur. ठीक ज्ञान से Next, I would like to invite Professor N.C. Barwar sir, Head Department of Computer Science and Engineering, to welcome our presiding guest, Professor Ajay Sharma, Honorable Vice Chancellor, MBM University. हाँ, उनका वेलकम के लिए सिर्फ नहीं वेलकम करते, किसी से करवाना है? किन से बुलाऊं? उनको क्या बुलाऊं स्टेज पे तो वेलकम? हाँ, मतलब क्योंकि साफा का कुछ करना नहीं. At this moment, I would like to apprise all of you that our today's chief guest, Honorable Minister Shri Gajendra Singh Ji Shekhawat, has connected with us on this occasion through online. I would like to invite Professor Milind Sharma sir to please offer a few words of welcome to him.
Namaskar, a very good morning to all of you. It's a matter of immense pleasure to welcome today Honorable Minister, Cabinet Minister, Government of India, Shri Gajendra Singh Ji Shekhawat Saab in today's international conference on water. It is always pleasure to welcome our own Member of Parliament who represented the Jain Anvas University as President and who has offered always a helping hand whenever the university is in need of his help, guidance and any sort of cooperation. And we are today privileged to welcome you, sir, as we all proud of you, of your achievement, your ministry, your contribution in Government of India, the mission Ganga, Jal mission, to your commitment to access, to provide access to water at every doorstep, at every house, at every village, and your commitment towards the clean Ganga is commendable. We all read and witness your commitment through print media and electronic media and your dedication to clean the Ganga, which at one point of time was being considered as a mission impossible, and it is you being at the helm of affair. Now it looks possibility, and we all feel pride today, and we think that today's deliberation and your guidance in today's conference will also pave the way for the mission Ganga for all of us. Once again, welcome you, sir, and Abhinandan, Aabhar, and Swagat. Namaskar.
Thank you, sir.
सबको नमस्कार. ये जो फॉर्मल प्रोग्राम चल रहा था उसके बीच में मैं अपने इमोशंस और सम्मान और आदर के हमारे प्रतीक जो शेखावत साहब हमारे बीच में हैं, मैं एमबीएम विश्वविद्यालय की तरफ से सर का इस प्रांगण में जो है स्वागत और अभिनंदन करता हूँ. मैं बहुत खुश हुआ जब सर ने यहाँ इस प्रोग्राम के लिए हाँ भरी, और मैं उम्मीद भी था कि सर अगर यहाँ फिजिकली प्रेजेंट होते तो यहाँ का समा और माहौल कुछ और ही होता. पर सर हमारे साथ जुड़े। मैं सर आपका पुनः बहुत बहुत स्वागत और अभिनंदन विश्वविद्यालय की तरफ से और विश्वविद्यालय परिवार की तरफ से मैं जो है आपका इस मंच पर स्वागत करता हूं और उम्मीद करता हूं आप जब भी जोधपुर पधारें तो आप हमारे बीच में ज़रूर आएँ और हम आपका जो है एक वर्चुअल मोड में नहीं बल्कि एक रियल मोड में एक भव्य स्वागत करने की दिल में सबकी हमारे जो है विश्वविद्यालय परिवार की इच्छा है। तो जब भी आप पधारें सर आपका हम बहुत बहुत स्वागत करना चाहेंगे और आप इसको एक हमारी तरफ से ओपन निमंत्रण के तौर पे ले लें क्योंकि आपका प्रोग्राम डेफिनेटली बहुत बिजी शेड्यूल में रहता है, लेकिन जब भी आप जोधपुर पधारें हम उम्मीद करेंगे कि आप यहाँ पधारें और हम आपका स्वागत करें। थैंक यू सो मच सर।
Thank you, sir. Next in line, I would like to invite Professor Akhil Ranjan Garg, sir, to welcome our today's special guest, Professor S.P. Chaurasia, President, Indian Desalination Association. In the continuing sequence, I would like to invite Dr. Kailash Chaudhary sir to welcome our Dean, Professor Sunil Sharma ji, on this auspicious occasion. I extend my warm regards to all the guests for joining us today. Next in line, I would like to invite Professor Sushil Saraswat sir for offering a welcome address and briefing all of us about the today's international conference. Please sir, welcome.
Thank you, Abhishek. A great morning to all. Our chief guest of the day, Honorable Minister of Jal Shakti, Shri Gajendra Singh Shekhawat Sahab, Professor K.L. Srivastav, Vice Chancellor Jai Narayan Vyas University Jodhpur, Professor Ajay Kumar Sharma, Vice Chancellor MBM University Jodhpur, Professor S.P. Chaurasia ji, President Indian Desalination Association, Shri Ravindra Kumar, Outstanding Scientist and Director DRDO Jodhpur, Professor Sunil Kumar Sharma, Dean MBM University Jodhpur, faculty members, delegates, speakers, media persons and dear friends. I would like to welcome you with a great pride to the International Conference on Desalination Association and Water Treatment, Recent Technological Advancement, Challenge and Opportunities, an annual conference of InDA InDACON 2022, organized by the Department of Chemical Engineering, MBM University Jodhpur, in association with Indian Desalination Association and Defense Research and Development Organization DRDO Jodhpur. I am indeed grateful to Shri Gajendra Singh Shekhawat Sahab, Union Cabinet Minister, Minister of Jal Shakti, for sparing valuable time with us and showering blessing upon us. I would like to thank you, the Vice Chancellor of JNV University and Vice Chancellor of MBM University, for their constant support and guidance. I am grateful to the Chairman of InDA with a great leading association in the field of water desalination, and to the Director of Defense Research Lab DRDO Jodhpur, who has provided several technological for our armed forces. I thank him for their co-organizer for the international conference. Last but not the least, I would like to thank Dean MB University for his support in organizing this event. It's indeed a pleasure and honor to organize the first international conference after the establishment of MBA University. This conference is conducted in a hybrid mode on a digital platform in line with the social distancing norms due to COVID-19 pandemic. In the recent years, water scarcity has become the hot topic in the world. To focus the attention on this worldwide problems, MBM University, InDA and DRD Jodhpur, in association with leading professional association and industries from India and abroad, are organizing this international conference to deliberate and share new ideas and emerging advancement and to propose appropriate synergetic technologies towards the fulfillment. the need of water in the every word of the word. Today, I would like to convey an important message on water conservation and management in our life. Water is precious and priceless. Compound available on the earth crust, we are extremely thankful to the nature for blessing us with the most precious gift of the life. In today's world, there are talks of economic growth and development, but looking minutely, in the case of fact, it appears that without the availability of water, the human growth and development is not life. There are various ways available through which we can manage water. The major way of water management including recycling and water treatment. Water is a key strategic resource of our country, where India has only 4% of the water resource with large temporal and spatial variabilities. Minister of Jal Shakti, striving towards sustainable development and management of water resource, of which National Hydrology Project is one of the important schemes introduced. The Ministry of Jal Shakti is implementing National Rural Drinking Water Project and Jal Jeevan Mission to ensure that every rural person has enough safe drinking water for drinking, cooking and domestic projects. Government of India has restructured and resummed the ongoing national drinking water programs into Jan Jeevan missions to provide functional household tap connections to every household, that is Har Ghar Nal Se Jal, by 2024. All of us aware that Namami Ganga project initiated by Government of India to ensure effective reductions of pollution and regeneration of river Ganga with the aim of ensuring water quality and environmentally sustainable development. The full result of each efforts may not be visible now, but the endeavor has certainly created an awareness among couple on the need of maintain our water bodies clean and alive. Keeping this view in mind, this two-day international conference has varied of technical session including 3 online and 1 offline session and many more. I feel elated to announce that we have received more than 75 technical papers, out of which 28 from IITs and NITs, 8 from research organizations like DRDO and BARC, and 7 from industries and 20 from research scholars. There are 12 invited talks by the experienced faculty, scientists and the researchers. We have 4 lecture sessions from the professor from the USA, the UK, Singapore and Turkey. We are thankful that they have consented to share their experience at late night hours according to the time zone. I would not like to forget to highlight the organizing team members of the MBM University, DRDO and InDA have worked day and night, which has enabled to organize this event. I, as an organizing secretary, I would like to place on record that financial help from TechCube 3, MBM University, InDA and DRDO headquarters, this event would not have been possible. I would like to conclude by requesting that participant that you must have the best possible utilization of this opportunity to present, share, discuss and interact on various aspects of water desalination and purifications, and to bring out new concept and solution to make our country self-reliant in this area. Thank you. Jai Hind.
Thank you, sir, for your kind address. Moving ahead, I would like to take this opportunity to request our today's chief guest, Honorable Minister Shri Gajendra Singh Ji Shekhawat, to please address this gathering with your kind words. Please.
डॉक्टर सारस्वत साहब से और एमबीएम परिवार से कि मैं अपने वादे के अनुरूप आप सब लोगों के बीच में उपस्थित नहीं हो पाया। पिछले लगभग पूरे सप्ताह मैं वर्ल्ड वाटर फोरम की मीटिंग के लिए सेनेगल, जो पश्चिम अफ्रीका का देश है, वहां गया था। कल ही वहां से वापस लौटा और आज दिल्ली में किसी व्यस्तता के नाते मैं आप सब लोगों के बीच में नहीं आ पाया। आप लोगों ने मुझे वर्चुअली अपने से जुड़ने की, अपने से बात करने की अनुमति प्रदान की, उसके लिए मैं आप सबका आभारी हूँ। साथ ही मैं आभार ज्ञापित करना चाहता हूँ कि आपने मुझे एमबीएम विश्वविद्यालय में, और विश्वविद्यालय बनने के बाद में ये पहला शायद सार्वजनिक कार्यक्रम था जिसमें मुझे आप लोगों के बीच में आना था, लेकिन आप लोगों ने मुझे एक स्टैंडिंग इनविटेशन दिया है। जब आप स्टैंडिंग इनविटेशन मुझे दे रहे थे तब मुझे मन में एक विचार आ रहा था कि एमबीएम अब तक जब जो जयनारायण व्यास विश्वविद्यालय का हिस्सा था, मुझे लगता था कि हम सब एक परिवार के सदस्य थे। और अब जब एमबीएम विश्वविद्यालय अलग हुआ है और मुझे उसमें आने के लिए निमंत्रण दिया गया है, तो मुझे लगता है कि अब हम पराये हो गए हैं, हमको आप लोगों ने अपने आप से अलग मान लिया है। लेकिन ऐसा नहीं है, हम सब लोग एक हैं, हम सब लोग साथ ही हमेशा थे, साथ ही हमेशा ही रहने वाले। एमबीएम विश्वविद्यालय के केमिकल इंजीनियरिंग विभाग द्वारा आयोजित आज इस इंटरनेशनल कॉन्फ्रेंस में जो डिसैलिनेशन एंड वाटर ट्रीटमेंट recent technological advancement challenges and opportunities and annual congress of InDA के इस उद्घाटन सत्र में आप सब ने मुझे बात करने का अवसर प्रदान किया है। आज इस कार्यक्रम में मंच पे उपस्थित इंडियन डिसैलिनेशन एसोसिएशन के अध्यक्ष श्री एसपी चौरसिया जी, जयनारायण व्यास विश्वविद्यालय के वाइस चांसलर प्रोफेसर केएल श्रीवास्तव जी, एमबीएम विश्वविद्यालय के वाइस चांसलर प्रोफेसर अजय कुमार शर्मा जी, डिफेंस लैब के डायरेक्टर श्री रविंद्र कुमार जी, इंडाकॉन के ऑर्गेनाइजिंग सेक्रेटरी प्रोफेसर सुशील सारस्वत जी, एमबीएम यूनिवर्सिटी के डीन प्रोफेसर सुनील शर्मा जी, डॉक्टर वीके श्रीवास्तव जी, इस कॉन्फ्रेंस की आयोजक मंडल के सभी सम्मानित सदस्य, अधिकारीगण, लेडीज एंड जेंटलमैन, जल और जल शोधन जैसे अहम विषय पर इंटरनेशनल कॉन्फ्रेंस इंडाकॉन 2022 में मुझे आमंत्रित करने और इस प्रतिष्ठित मंच से अपने विचार साझा करने के अवसर प्रदान करने के लिए मैं सबको बहुत सारा धन्यवाद देना चाहता हूं। मुझे प्रसन्नता है कि इंडियन डिसैलिनेशन एसोसिएशन, भारत के प्रतिष्ठित संस्थान DRDO और मेरे अपने संसदीय क्षेत्र जोधपुर के एमबीएम इंजीनियरिंग कॉलेज के साथ संयुक्त रूप से इस कॉन्फ्रेंस का आयोजन कर रहा है। साथियों, इस सप्ताह की शुरुआत में ही जैसा मैंने कहा, मुझे सेनेगल की राजधानी डकार में चल रहे 9वें वर्ल्ड वाटर फोरम में भारत के प्रतिनिधित्व करने का अवसर मिला था। इस फोरम में इस वर्ष का थीम पीस फॉर डेवलपमेंट, पीस एंड डेवलपमेंट विद वाटर सिक्योरिटी ऐसा था। और भारत ही नहीं, दुनिया के लगभग सभी देश तेजी से बढ़ते हुए जल संकट से न केवल चिंतित है, बल्कि इससे उबरने का उपाय भी खोज रहे हैं। इस दिशा में सरकारें, वैज्ञानिक समुदाय, जल के क्षेत्र में काम करने वाले समाज में जुड़े हुए अनेक लोग और संस्थान, सभी लोग चिंतित भी हैं और अपनी अपनी तरह से प्रयासरत भी हैं। अगर हम संयुक्त राष्ट्र संघ की रिपोर्ट को देखें तो दुनिया में 200 करोड़ से ज्यादा की आबादी को आज भी घर में पीने का पानी उपलब्ध नहीं होता है। भारत के परिप्रेक्ष्य में यदि मैं बात करूं तो भारत की भी, जब माननीय प्रधानमंत्री जी ने जल जीवन मिशन प्रारंभ किया था तो भारत की लगभग 83% आबादी जो है वो लगभग 100 करोड़ लोग, दुनिया के 200 में से आधे लोग भारत में ऐसे थे जिनको पीने का पानी घर में उपलब्ध नहीं था। दुनिया भर में 77 करोड़ से ज्यादा लोग साफ पानी के लिए रोजाना कम से कम 30 मिनट का सफर करते हैं और 10 करोड़ लोग दुनिया में ऐसे हैं जो अनट्रीटेड या क्वालिटी कॉम्प्रोमाइज्ड पानी पीने के लिए विवश है। वर्ल्ड रिसोर्स इंस्टीट्यूट ने अपने अध्ययन में कहा कि निकट भविष्य में 17 ऐसे देश होंगे जिनमें गंभीर जल संकट का जिनको सामना करना पड़ सकता है, और उनकी उस रिपोर्ट के अनुसार भारत भी उनमें से एक है। ऐसा अनुमान करते हैं कि विश्व की आबादी जो 2017 में 7.6 बिलियन थी, 7.6 अरब थी, वो 2050 तक बढ़ के 9.54 से 10.2 समवेयर अराउंड बिलियन तक पहुंच जाएगी। और इनमें से 2/3 आबादी जो है वो शहरों में निवास करेगी। जिस तेज गति से पूरे विश्व भर में अर्बनाइजेशन बढ़ रहा है, इसलिए चुनौती जो है और भी ज्यादा मल्टीप्लाई होती जा रही है। संयुक्त राष्ट्र के अनुसार इस अनुमानित वृद्धि का आधा हिस्सा अफ्रीका और एशिया में होगा। इसके लिए जिन लोगों को पीने के पानी की अधिक जरूरत होगी वे या तो विकासशील या ऐसी उभरती हुई अर्थव्यवस्थाओं में से एक होंगे। और हमारे लिए भारत में ये चुनौती और भी बड़ी इसलिए है कि भारत में दुनिया के 18% आबादी और 18% ही कैटल पॉपुलेशन के अगेंस्ट में वी हैव ओनली 4% ऑफ पोटेबल वाटर इन आवर कंट्री। अंतर्राष्ट्रीय जल प्रबंधन संस्थान का अनुमान यह है कि पानी की कुल मांग जो है हमारी, जो आज 680 क्यूबिक मीटर है, वो बढ़ करके 883 बिलियन क्यूबिक मीटर तक पहुंचेगी और 2050 तक ये 900 बिलियन क्यूबिक मीटर तक पहुंच जाएगी। इसलिए जल संकट का सामना कर रहे देशों को 2050 तक जो सरफेस वाटर के सोर्सेज हैं उनकी जिस तरह से उपलब्धता कम हो रही है, इससे भी समस्या से दो चार होना पड़ सकता है। एक अनुमान ऐसा भी लगाया जाता है कि 3.6 अरब लोग अब दुनिया के उन क्षेत्रों में जो रहते हैं जहां साल में कम से कम 1 महीने तक पीने के पानी का कमी का सामना करना पड़ता है। और इस आबादी में 2050 में तक 5% से लेकर 5.7 अरब तक की वृद्धि हो सकती है। यदि मैं केवल भारत के परिप्रेक्ष्य में ही बात करूं तो 4000 बिलियन क्यूबिक मीटर का प्रेसिपिटेशन से और इंटरनेशनल जो रिवर्स है, हमारी बेसिन है, वहां से पानी हमको मिलता है। और इसका जो हार्वेस्टेबल कंपोनेंट है वो भी 2000 बिलियन क्यूबिक मीटर का है। जो पानी जो है इसके अगेंस्ट में हमारी आज की तारीख में सरफेस रिजर्वायर कैपेसिटी जो है वो 250 बिलियन क्यूबिक मीटर है। और इसमें जितने बड़े छोटे सारे बांध तालाब सबको यदि मैं कुल जोड़ दूं तो भी हमारी टोटल वाटर होल्डिंग कैपेसिटी ऑन सरफेस छोटे से छोटे गांव ढाणी के तालाब से लेकर के और जो है वेटलैंड से लेकर के देश के सबसे बड़े बांध तक हमारी टोटल सरफेस पर जो है वाटर होल्डिंग कैपेसिटी 400 बिलियन से ज्यादा नहीं है, 400 बिलियन क्यूबिक मीटर से। और इसके चलते हमारा भूगर्भ के जल पर निर्भरता बहुत बड़ी है। आज की तारीख में भी हम लगभग 750 बिलियन क्यूबिक मीटर जो है वो पानी जो जमीन में से हम निकालते हैं उसके अगेंस्ट में हमारा रिचार्ज जो है 450 बिलियन क्यूबिक मीटर है। इसलिए जो वर्षों से हजारों सालों से जो पानी जमीन में एक्विफर्स में रिचार्ज हुआ था, संचित हुआ था, हम उस अमानत में से लगातार ओवर विड्रॉल कर रहे हैं। उसके कारण से हमारे यहाँ पर ग्राउंड वाटर के रिसोर्सेज जो हैं वो कंटिन्यूअसली जो है वो डिप्लीट होते जा रहे। आज भी देश में 22% ऐसे ब्लॉक्स हैं जहां जितना रिचार्ज है उसके कंपैरिजन में कम और ज्यादा विड्रॉल हो रहा है, या विड्रॉल जितना हो रहा है उसके कंपैरिजन में कम रिचार्ज हो रहा है। और देश में नदियों की यदि बात करें तो 700 नदियों में से केवल 4% नदियां ही ऐसी हैं जो बर्फ के पानी से पिघलने से बनती और उससे पेरेनियल रिवर के रूप में चलती हैं। बाकी सारी नदियां जो है हमारी मॉनसून फेड रिवर्स है। और जिस तरह से जो है क्लाइमेट चेंज के इम्पैक्ट अभी दिखाई दे रहे हैं उसके कारण से जो हमारी नदियां जिस तरह से सूख रही हैं। और इसके साथ साथ में हम सब जानते हैं, आप पानी के विषय से जुड़े हुए लोग हैं, हम सब जानते हैं कि पानी के ऑल एस्पेक्ट्स ऑफ वाटर, चाहे वो नदी में है, चाहे वो वेटलैंड में है, चाहे छोटी रिवलेट्स में है, चाहे जमीन के ऊपर है और चाहे जमीन के भीतर है, ये सब आपस में इंटरकनेक्टेड है। और इंटरकनेक्टेड होने के कारण से इनमें से इस पूरी चेन में से एक भी जगह अगर कहीं ब्रेक आता है तो ये पूरा इकोसिस्टम ऑफ वाटर जो है वो गड़बड़ा जाता है। पानी अगर हमारी जिस तरह से हमारे कैचमेंट में डिफॉरेस्टेशन हुआ, कैचमेंट्स का प्रॉपर जो है अब्यूजमेंट हुआ, उसके कारण से हमारी रिवलेट्स जो है वो कॉम्प्रोमाइज हुई, हमारे स्प्रिंग्स कॉम्प्रोमाइज हुए, उसके कारण से हमारी नदियों में पानी कम पड़ा, ग्राउंड वाटर से ज्यादा पानी निकालने लगे तो वेटलैंड्स में पानी कम हो गया। जो वेटलैंड्स नदियों को नॉन मानसून सीजन में नदियों को ताकत देते थे, रीइंफोर्स करते थे, वो स्ट्रक्चर पूरा गड़बड़ा गया। तो अभी हमको जो है होलिस्टिक वाटर मैनेजमेंट के ऊपर काम करने की आवश्यकता है। और मैं मानता हूं कि हमारी चुनौती जो है वो पानी के प्रबंधन की चुनौती है। दुनिया में बहुत सारे ऐसे देश हैं जिन्होंने ठीक से अपने पानी के संसाधनों को मैनेज भी किया है, और ऐसा करके उन्होंने अपने आप को वाटर सिक्योर नेशन बनाया है। अगर मैं एग्जांपल दूं तो हमारी औसत बारिश जो है देश में लगभग 1068 मिलीमीटर होती है, जबकि इजराइल में 150 मिलीमीटर पानी बरसता है। और उसके बावजूद भी जो है इजराइल वाटर सरप्लस देश है और अपने पड़ोसी देशों को पीने के लिए पानी सप्लाई करता है, क्योंकि उन्होंने अपने वाटर सिस्टम को पूरी ठीक तरह से मैनेज किया है। उन्होंने सप्लाई साइड को मैनेज किया, साथ ही डिमांड साइड को भी मैनेज किया। और रिसाइकलिंग में जिस तरह से उन्होंने महारत हासिल की, 94% अपने पानी को रिसाइकल करके रीयूज करना शुरू किया। क्योंकि जैसा माननीय प्रधानमंत्री जी कहते हैं कि आप एक बूंद भी पानी को यदि रिसाइकल करते हो और उसको रीयूटिलाइज करते हो, तो वो वाटर सेक्टर पूरे क्वांटम में एक बूंद वाटर सिस्टम में एडिशनल जनरेशन ऑफ वाटर होता है। तो ये निश्चित रूप से हमारे लिए भी बड़ी जो है अब चुनौती है कि हमको भी रिसाइकलिंग और वाटर जो है के शुद्धिकरण के लिए हम सबको भी काम करने की आवश्यकता है। जहां इजराइल में 94% पानी रिसाइकल करके रीयूटिलाइज करते हैं, हमारे तो केवल रिसाइकलिंग कैपेसिटी, एस्टेब्लिश्ड कैपेसिटी के अगेंस्ट में यदि मैं टोटल यूटिलाइज्ड कैपेसिटी की बात करूं तो हम 20% से भी कम पानी को जो है रिसाइकल कर पाते हैं। और रीयूज की अगर मैं बात करूं तो हम मिनिस्ट्रियल लेवल पे ऑलमोस्ट 10% ही जो है हम रीयूज कर पाते हैं। और उसके कारण से हमारे जो वाटर रिसोर्सेज हैं वो और ज्यादा कंटेमिनेट हो रहे हैं, रिसीवर्स हमारी कंटेमिनेट हो रही हैं। आज दुनिया में जो है इन संकट और चुनौतियों के प्रबंधन के लिए बहुत सारी टेक्नोलॉजीज पर काम हो रहा है। भारत में भी हम बहुत सारी टेक्नोलॉजीज पर काम कर रहे हैं। और वाटर सेक्टर जो है टोटल वाटर अवेलेबल क्वांटम को बढ़ाने के लिए डिसैलिनेशन आज दुनिया में बहुत तेजी के साथ में आगे बढ़ रहा है। अगर पूरी दुनिया में मैं बात करूं तो इजराइल में की डिपेंडेंसी डिसैलिनेशन पर सबसे ज्यादा है, और वहां तो इसको खेती जैसे काम में भी इसको उपयोग में ले रहे हैं। 20,000 से ज्यादा डिसैलिनेशन प्लांट्स पूरी दुनिया में काम कर रहे हैं, जिसमें 250 बिलियन गैलन पानी रोज डिसैलिनेशन से हम काम में लेते हैं। मध्य पूर्व में, उत्तर अफ्रीका में, मोरक्को में, जॉर्डन में, इजराइल में बहुत तेजी से इन सब डिसैलिनेशन प्लांट्स पर, डिसैलिनेशन टेक्नोलॉजी पर काम हुआ है। जॉर्डन इजराइल को 600 मेगावाट सोलर पावर देने का उसने एक एग्रीमेंट किया है अगेंस्ट 200 एमसीएम जो है डिसैलिनेटेड पानी लेने के लिए। तो आज पावर और पानी के बीच में देशों में इंटरनेशनल बार्टर का भी एक नई व्यवस्था बनने लगी है। आने वाले टाइम में जैसा मैं सोचता हूं कि डिसैलिनेशन का जो ग्लोबल मार्केट है वो बढ़ करके 32 बिलियन तक पहुंच जाएगा। और उसमें हमारे हिंदुस्तान में भी टेक्नोलॉजी के डेवलपमेंट के साथ साथ में उस टेक्नोलॉजी को एक्सपोर्ट करते हुए केवल इंडियन मार्केट के लिए पूरी दुनिया में अगर हम लो टॉप कोस्ट टेक्नोलॉजीज को अपने यहाँ से डेवलप करके ले जाएं तो ये एक बहुत बड़ी अपॉर्चुनिटी हमारे सामने है। अभी कल ही दुबई में मुझे एक सज्जन मिले थे जो नासिक के रहने वाले हैं, और वो आईआईटी चेन्नई के साथ में, आईआईटी मद्रास के साथ में उन्होंने डिसैलिनेशन टेक्नोलॉजी पे काम किया है। और जैसा उन्होंने क्लेम किया, इट वाज ए बिग फोरम, और उसमें ब्रीफ मीटिंग में जो उन्होंने बताया था कि उन्होंने सोलर थर्मल टेक्नोलॉजी डेवलप करके उसके बेस पर डिसैलिनेशन पे काम किया है, जो कॉस्ट को, डिसैलिनेशन की कॉस्ट को बहुत घटाता भी है। और साथ में जो रिकवरी होती है, नॉर्मली मेम्ब्रेन बेस्ड डिसैलिनेशन में 40% to लेकर के 60% तक की मैक्सिमम आउटपुट आता है, यूजेबल आउटपुट आता है। लेकिन ये जो टेक्नोलॉजी जिसकी उन्होंने चर्चा की थी उसमें 98% तक रिकवरी होती है। अगर ऐसा होता है तो उसके कारण से कॉस्ट ऑफ डिसैलिनेशन कम होगी और ये एक गेम चेंजर के रूप में हो सकता है। और इस तरह की टेक्नोलॉजीज पे अगर हम काम करते हुए इसको आगे बढ़ा सकते हैं तो हम दुनिया में एक बहुत बड़ी प्रेजेंस अपनी इंडियन कंपनीज के माध्यम से इस सेक्टर में बढ़ा सकते हैं। प्रधानमंत्री जी की दूरदर्शी सोच है और उन्होंने ऐतिहासिक और साहसिक फैसलों से पूरी दुनिया में अपनी एक पहचान कायम की है। पानी के प्रबंधन के लिए पानी के महत्व को समझते हुए 2019 में उन्होंने इंटीग्रेटेड वाटर रिसोर्सेज मिनिस्ट्री बनाई, डिफरेंट डिपार्टमेंट्स को, डिफरेंट मिनिस्ट्रीज को जो है एक साथ इंटीग्रेट करके जल शक्ति मंत्रालय बनाया। आप सबकी शुभकामनाओं से मुझे उसके प्रबंधन की उन्होंने जिम्मेदारी दी है। और उसके साथ में हम बहुत सारी योजनाएं बना करके देश को वाटर सिक्योर बनाने के लिए काम कर रहे हैं। आज हम जानते हैं कि हमने सक्सेसफुली दुनिया का सबसे बड़ा बिहेवियर चेंज प्रोग्राम और दुनिया का सबसे बड़ा सैनिटेशन प्रोग्राम हमने सक्सेसफुली अचीव किया है। आज हम दुनिया के ग्लोबल प्लेटफॉर्म पर जाकर के जब खड़े होते हैं तो भारत की तरफ लोग सम्मान और श्रद्धा की तरफ देखते हैं। दुनिया के 50-100 देश जो है हमसे आकर के किस तरह से आपने किया उस सक्सेस स्टोरी से इंस्पायर होकर के सीखने की, टेक्नोलॉजीज को जानने की कोशिश करते हैं। और इसी क्रम में आज दुनिया का सबसे बड़ा जो है ड्रिंकिंग वाटर मिशन हम कर रहे हैं। देश में जैसा मैंने प्रारंभ में कहा कि केवल 18% घर, 17% घरों तक ही पीने का पानी पहुंचता था। डेस्पाइट कोविड, आज अंडर द लीडरशिप ऑफ ऑनरेबल प्राइम मिनिस्टर हमने जिस तरह से काम किया है, आज हम 48% से ज्यादा घरों तक पीने का पानी नल के माध्यम से पहुंचाने में कामयाब हुए। 6 करोड़ को नया कनेक्शन जो है पिछले 2 साल के कालखंड में दिया गया। और इसी के साथ साथ में जो है हमने दुनिया का सबसे बड़ा जो है रिवर रिजुविनेशन प्रोग्राम, रिवर जो है क्लीनिंग प्रोग्राम भी हमने नेशनल मिशन फॉर क्लीन गंगा के तहत किया है। दुनिया का सबसे तेज गति से किया है। दुनिया का सबसे बड़ा डैम रिहेबिलिटेशन प्रोग्राम पर हम जो है वर्ल्ड बैंक के असिस्टेंस से काम कर रहे हैं। पिछले 5-6 साल में हमने लगभग 230 डैम्स को रिहेबिलिटेट किया। अभी हम 700 से ज्यादा डैम्स के रिहेबिलिटेशन के लिए योजना पर हमने काम करना प्रारंभ कर दिया। और इसके साथ साथ में देश में पहली बार, जैसा मैंने कहा कि अब तक हमने केवल सप्लाई साइड को मैनेज करने के लिए बात की थी, लेकिन प्रधानमंत्री जी के मार्गदर्शन में अब हम जो है डिमांड साइड को मैनेज करने के लिए भी उसी गति से काम कर रहे हैं। और हमने देश के 7 प्रांतों में डिमांड साइड मैनेजमेंट को, पार्टिसिपेटरी वाटर मैनेजमेंट, जन सहभागिता को साथ में लेकर के उनको साथ जोड़ करके उसके ऊपर भी हम उसके माध्यम से हम पानी के विवेकपूर्ण उपयोग के लिए काम करें, इस दृष्टि से भी काम करना देश के 7 प्रदेशों में पायलट के रूप में प्रारंभ किया है। डिसैलिनेशन की अगर मैं वापस से चर्चा करूं तो वाटर ट्रीटमेंट की दिशा में देश में बहुत तेजी से काम हो रहा है। और हमारी भी लगभग 7,800 किलोमीटर लंबी कोस्टल लाइन है। और डिसैलिनेशन की आवश्यकता कोस्टल एरियाज में हमारे यहाँ भी पड़ रही है। अंडमान निकोबार में, तमिलनाडु में, गुजरात में, आंध्र प्रदेश में डिसैलिनेशन प्लांट लगाए गए हैं। और तमिलनाडु के दक्षिण पूर्वी एरिया में स्थित रामनाथपुरम जिले के नरियप्पयूर गांव है, उसमें रोज समुद्र के पानी से 20,000 लीटर डिसैलिनेशन करके उस गांव के पानी के पीने की व्यवस्था जो है वो अब सक्सेसफुली पिछले काफी समय से की जा रही है। तो इस तरह से बहुत सारी टेक्नोलॉजीज का स्कोप भी है, बहुत सारी टेक्नोलॉजीज का उपयोग भी हो रहा है, उनका फर्दर रिफाइनमेंट भी किया जा सकता है। और इन सब के माध्यम से हम जो है और पानी की अवेलेबिलिटी को, सस्टेनेबिलिटी को बढ़ा सकते हैं, स्पेशली अपने कोस्टल एरिया में। गुजरात में भी अगर मैं उदाहरण दूं तो डिसैलिनेशन प्लांट से लखपत और अबडासा के लाखों परिवारों को पीने का पानी देने के लिए, लगभग 8 लाख लोगों को पीने के पानी के लिए 10 करोड़ लीटर पानी को डिसैल करने की जो है मिशन पर काम हो रहा है। और वाटर सप्लाई के लिए सोलर एनर्जी और ओशन एनर्जी को कैसे हम उपयोग कर सकते हैं, इसके ऊपर भी बहुत तेज गति से देश में काम हो रहा है। तो वाटर सेक्टर के सारे जो है डोमेन्स, उस पे हमारी IITs, हमारी यूनिवर्सिटीज, DRDO, इसके अलावा सरकारी उपक्रम जो हैं और निजी क्षेत्र की कंपनियां, सभी लोग शोध कर रहे हैं। देश में जितने सूवेज ट्रीटमेंट प्लांट्स पर जो आज काम हो रहा है और जिस तेज गति से इसमें सूवेज ट्रीटमेंट प्लांट्स की टेक्नोलॉजीज, नई टेक्नोलॉजीज के साथ में सूवेज ट्रीटमेंट पर काम हो रहा है, ये भी आने वाले समय में एक बहुत बड़ा स्कोप जो है हमारे लिए, हमारी कंपनीज के लिए है। मैं अंत में इतना कहना चाहता हूं कि आज जो है निश्चित रूप से टेक्नोलॉजी के माध्यम से हम देश को वाटर सिक्योर बना सकते हैं, उस रास्ते पर जा सकते हैं। लेकिन उससे भी ज्यादा आवश्यकता जो है वो यदि किसी एक चीज की है, वो ये है कि हम देश में पानी के प्रति अवेयरनेस किस तरह से लोगों की बढ़े। जैसा मैंने प्रारंभ में कहा कि हमारा हार्वेस्टेबल कंपोनेंट जो है वो 50%, 4000 BCM के अगेंस्ट में 2000 BCM है। हम बरसात के एक एक बूंद पानी का संचय किस तरह से कर सकते हैं, संचित पानी को किस तरह से संरक्षित कर सकते हैं, संरक्षित पानी का किस तरह से विवेकपूर्ण उपयोग कर सकते हैं, और उपयोग किए हुए पानी को वापस रिसाइकल करके कैसे उपयोग कर सकते हैं, इसके लिए हमको अवेयरनेस पैदा करने की आवश्यकता भी है। अगर हम अवेयरनेस पैदा करेंगे, सामान्य मानवी इसके लिए अपनी सेंस जो है रिस्पॉन्सिबिलिटी इसको समझेगा, और ये सेंस ऑफ रिस्पॉन्सिबिलिटी यदि जनित हो जाएगी तो निश्चित रूप से आने वाले समय में अभी अनेक वर्षों तक हम देश को वाटर सिक्योर बनाए रख सकते हैं। आज एग्रीकल्चर हमारा सबसे ज्यादा पानी का उपयोग करने वाला क्षेत्र है। एग्रीकल्चर में अगर हम अपनी इरिगेशन सिस्टम को बदल करके वहां से पानी को अगर 10% भी बचाते हैं, क्योंकि टोटल 89% ऑफ द टोटल क्वांटम ऑफ वाटर बीइंग यूटिलाइज्ड इज बीइंग यूज्ड इनटू एग्रीकल्चर, अगर 10% भी बचा पाते हैं तो हम निश्चित रूप से जो है आने वाले 50 साल तक देश को पीने के पानी और इंडस्ट्री के लिए सिक्योर कर सकते हैं। तो बिना जो हमारा जो है फूड की ग्रोइंग कैपेसिटी को कॉम्प्रोमाइज किए हुए यदि हम इस पर काम कर सकते हैं तो हम बहुत जो है लंबे समय तक देश को जल समृद्ध बना पाएंगे। लेकिन अंततः मैं ये कहूंगा कि तकनीकी के माध्यम से, तकनीकी का उपयोग करके जिस तरह से हम काम करना चाहते हैं, आगे बढ़ रहे हैं, पूरी दुनिया में भारत के लिए, दुनिया के मार्केट में भारत के लिए इस तकनीकी के साथ में, बदली हुई तकनीकियों के साथ में काम करने की प्रबल संभावनाएं हैं। और मैं ये विश्वास से साथ में कह सकता हूं कि आज ये जो कॉन्फ्रेंस है, इस कॉन्फ्रेंस में जिस तरह के विचार आएंगे और इस विचार मंथन से जो नवनीत निकलेगा, उससे निश्चित रूप से कहीं ना कहीं इस क्षेत्र में, इस दिशा में आगे बढ़ने की, इस दिशा में और आगे प्रगति करने की संभावनाएं बढ़ेंगी। आप सबको एक बार फिर शुभकामनाएं। मुझे आमंत्रित करने के लिए आभार, और मुझे वर्चुअली आपसे जुड़ने की अनुमति लेने के लिए भी आप सबका अभिनंदन। मैं बहुत सारी शुभकामनाएं देता हूँ। जय हिंद।
Thank you, sir. Thank you for this insightful and inspirational address. Sir, your presence and contribution is invaluable and motivating for all the individuals present in this conference. On the behalf of whole organizing team, I would like to thank you for this address, sir. Moving ahead with the today's program, I would like to invite our Dean, Professor Sunil Sharma sir, to address this gathering.
हमारे आज के अंतर्राष्ट्रीय कॉन्फ्रेंस के मुख्य अतिथि हमारे अपने मारवाड़ के लाडले, जिस प्रकार से कृष्ण ने गोकुल में जन्म लिया, मथुरा में किशोरावस्था निकाली और द्वारका में द्वारकाधीश के रूप में विराजे, उसी प्रकार हमारे गजूबन्ना, हमारे गजेंद्र सिंह जी शेखावत, जो मेरे साथ में 1992 से जुड़े हुए हैं, एक छात्र संघ अध्यक्ष के रूप में मैं उनके साथ साक्षी रहा हूं, और उस वक्त मैं शिक्षक था। और उनको आज मां शेखावाटी की धरती में जिस प्रकार इन्होंने जन्म लिया और मारवाड़ की इस भूमि पर कर्म भूमि के रूप में इन्होंने बाड़मेर, जैसलमेर की सीमांत जन को जिस प्रकार से संबल दिया, उनको जीने की नई राह दिखाई और जन अभाव दूर किए, और आज दिल्ली को द्वारका कहूंगा, द्वारकाधीश के रूप में हमारे मारवाड़ के लाडले गजेंद्र सिंह जी शेखावत हमारा प्रतिनिधित्व कर रहे हैं, और जोधपुर का नाम पूरे देश में, पूरे विदेश में, पूरी दुनिया में जिस प्रकार से डंका बजा रहे हैं। और हमारे माननीय प्रधानमंत्री जी नरेंद्र जी मोदी साहब ने उन्हें लगातार दूसरी बार, पहले तो उन्होंने जिस प्रकार से विदेश जाकर के और किसान के रूप में स्वयं खेती करके और उन्नत फसल की उपयोगिताओं को जिस प्रकार से उन्होंने किया, तो प्रथम कार्यकाल में उनको कृषि मंत्री का जो माननीय प्रधानमंत्री जी ने जो उनको एक सम्मान दिया और उसको उन्होंने भली भांति निभाया और हमारा नाम रोशन किया। और उसके बाद जो कि जल जो कि जीवित भगवान है, उस जल के प्रबंधन को एक जल की शक्ति के मंत्रालय के रूप में गठित करके एक नवसृजित मंत्रालय का एक हमारे मारवाड़ के लाडले गजेंद्र बन्ना को जो उन्होंने जिम्मेदारी दी, और जिस प्रकार से वो उसको निभा रहे हैं उसके लिए मैं हमारा मारवाड़ का जन जन, जोधपुर की जनता, एमबीएम विश्वविद्यालय, जयनारायण व्यास विश्वविद्यालय और हम सभी प्रबुद्ध शिक्षक, हम सभी छात्रगण आपके लिए कोटि कोटि आभारी है। मैंने पहली बार किसी मंत्री से एक प्रोफेसर के रूप में भाषण सुना। आप सचमुच हम धन्य हैं कि आपके ने जिस प्रकार से जल के बारे में ज्ञान की गंगा बहाई। मैं एनवायरमेंटल इंजीनियरिंग का प्रोफेसर होने के नाते आपको कोटि कोटि आभार व्यक्त करता हूं। जिस प्रकार आपने सूर्य को ग्रहण लगता है, इसी प्रकार जल को भी ग्रहण लगता है। जल में जब प्रदूषण आता है तो जल प्रदूषित होता है तो जल ग्रहण कहलाता है। और डिसैलिनेशन एक जल ग्रहण को शुद्धता करने की एक प्रक्रिया है। और जिस प्रकार से आपने जल प्रबंधन के बारे में, डिमांड एंड सप्लाई के बारे में, जिस प्रकार आपने जो इसकी उपयोगिता के बारे में जो प्रकाश डाला, वो सचमुच अनुकरणीय है। और हम अपने आपको विश्वास दिलाते हैं कि हम अपने सभी सिविल इंजीनियरिंग और एनवायरमेंटल इंजीनियरिंग के विद्यार्थियों को इन सब आपके ज्ञान की गंगा को वहाँ तक पहुँचाएंगे और आपके जो भी विचार हैं मोटिवेशनल, उन सबको हम इस प्रकार से उन तक पहुँचाएंगे। मंच पर उपस्थित हमारे जयनारायण व्यास विश्वविद्यालय के माननीय कुलपति प्रोफेसर के श्रीवास्तव साहब, मंच पर उपस्थित हमारे एमबीएम विश्वविद्यालय के कुलपति प्रोफेसर डॉक्टर अजय कुमार शर्मा साहब, हमारे विज्ञान के वीर प्रोफेसर डॉक्टर रविंद्र कुमार, डायरेक्टर डिफेंस लैब, हमारे डिसैलिनेशन कॉन्फ्रेंस के अध्यक्ष, डिसैलिनेशन एसोसिएशन के डिसैलिनेशन एसोसिएशन के अध्यक्ष एसपी चौरसिया साहब, और हमारे आज के बींद राजा जिनको कि हम लाइफ टाइम अचीवमेंट अवार्ड देंगे, प्रोफेसर डॉक्टर वीके श्रीवास्तव साहब, और आप सभी सम्मानित गण, आप सब लोगों को, और मैं अपने छोटे भाई, अपने अनुज और हमारे यंग प्रोफेसर सुशील सारस्वत को तहे दिल से इस बात की शुभकामनाएं देता हूं कि उन्होंने जिस प्रकार का एक जीवंत जो एक विषय है, आज जो नीड ऑफ द डे है सोसाइटी के लिए, उस विषय को चुन करके, और जिस प्रकार से आज इंटरनेशनल इंडियन डिसैलिनेशन एसोसिएशन के साथ में मिलकर के जो कार्यक्रम आयोजित किया है, जो अंतर्राष्ट्रीय कॉन्फ्रेंस कर रहे हैं, एमबीएम विश्वविद्यालय की प्रथम अंतर्राष्ट्रीय कॉन्फ्रेंस हो रही है, और जो कि हमारे प्रोफेसर अजय कुमार शर्मा साहब के दिशा निर्देश में उनकी ये इच्छा है कि इस प्रकार से जब से वो पधारे हैं 2 अक्टूबर उन्होंने यहाँ पर ज्वाइन किया है, तब से वो दिन और रात एक ही चीज के लिए चिंतित रहते हैं, किस प्रकार से मैं इस एमबीएम विश्वविद्यालय को जगमग 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 कर दूं और ज्ञान की गंगा पहले तो यहाँ बरसाऊं, उसके बाद में समाज में। तो और उसी की जो कड़ी में आज का ये कार्यक्रम किया गया है। मुझे 10 मिनट का समय दिया गया था, शायद 11-12 मिनट बोल गया हूँ। आप सभी लोगों का आभार, अभिनंदन, स्वागत, और एक बार पुनः प्रोफेसर सुशील सारस्वत को हार्दिक बधाइयाँ। धन्यवाद।
Thank you, sir. Thank you for this address. Next in line, I would like to invite our special guest, Professor S.P. Chaurasia, sir, President, Indian Desalination Association, to address this gathering.
थैंक यू। इसके पहले कि मैं अपने फॉर्मल स्पीच पे आऊँ, मैं माननीय मंत्री महोदय का हृदय से आभार प्रकट करना चाहता हूँ कि वो हमारे इस प्रोग्राम के लिए इतना समय दिए, और उन्होंने, जैसा कि शर्मा जी ने पहले बताया, कि उन्होंने ज्ञान की गंगा बहाई, वाटर सेक्टर के सभी बिंदुओं के बारे में, भारत सरकार के प्रयास और उनके अपने स्वयं के प्रयास के बारे में उन्होंने बताया। और मंत्री महोदय सर, मैं आपको एक चीज़ इंडा के बिहाफ में एक्नॉलेज करना चाहता हूं कि प्रधानमंत्री मोदी जी ने ये बहुत सही निर्णय लिया था कि वाटर से रिलेटेड डिफरेंट मिनिस्ट्रीज को एक साथ करके, और बहुत ही उपयुक्त नाम दिया, जल शक्ति मंत्रालय। वो अपने आप में ही एक शक्ति प्रदान करता है और एक मोटिवेशन देता है कि वाटर रिलेटेड जितनी समस्याएं हैं हम उसको एक अम्ब्रेला के नीचे सॉल्व करने की कोशिश करें। और महोदय जी, मैं आपको ये भी कहना आश्वासन दिलाना चाहता हूँ कि इंडियन डिसलाइनेशन एसोसिएशन के तरफ से हमारे कार्यक्रमों की सूची में वाटर, पानी के बारे में, इसकी क्वालिटी के बारे में, उससे रिलेटेड इशू, उसको हम कैसे जो है प्योरीफाई करें, रिसाइकिल करें, रीयूज करें, वो सब हम अवेयरनेस भी देते हैं। और हम लोग टेक्नोलॉजी के बारे में भी उपलब्ध ज्ञान से सब लोगों को अवगत कराने का कोशिश करते हैं। सर, मैं आपको एक चीज़ और शायद आपने कवर किया होगा, मैं नोटिस नहीं कर पाया, और आपके लिए और यहाँ जो उपस्थित हैं उन लोगों के लिए ये बताना चाहता हूँ कि वाटर रिसाइकिल रीयूज के पहले हमको ये भी देखना बहुत ज़रूरी है कि हम वाटर का मल्टीपल यूज करें। इसके पहले कि हम रिसाइकिल के लिए उसको ट्रीटमेंट के लिए भेजें, मल्टीपल यूज जो है, हम जहाँ भी बिल्डिंग के डिज़ाइन है या इंडस्ट्री में डिज़ाइन है, जब हम वाटर का उपयोग करते हैं तो उसको मल्टीपल यूज करके फिर उसको ट्रीट करें और फिर रिसाइकिल करें, बिकॉज इट इन्वॉल्व्स लॉट ऑफ एनर्जी, and when energy is involved, then environment is also affected and the economy is also affected. So now, the chief guest of today's function, Manni Mantri Mahoday, dignitaries on the dais, the vice chancellors of MBM University and JNBU, and director of Defense Lab, the dean Professor Sharma and Professor Saraswat, organizing secretary, all the authorities of both the universities, I am very highly thankful and obliged to all of you that you accepted our invitation to organize this conference, and we are also thankful to the God, to provide this opportunity, keeping us away from pandemic situation, to be here together in physical mode today. So, on behalf of Indian Desalination Association, I would like to extend a very warm welcome to all of you on this occasion. Now, as I told you, Honorable Minister Sahab, he has already highlighted many of the things for our knowledge. So, I would skip those things and just I shall put a word of appreciation, the work which is being done under the Ministry of Jal Shakti for the different causes of water, and that we are taking it, with lots of appreciation. Sir, all your efforts, and from InDA side, we would like to join hands with you, and for any cause you can, trouble us, you can call us to help you. See, friends, you have seen many slogans like Jal Hi Jeevan hai, water for sustainable life, then water for sustainable world. And especially in Rajasthan, in last 10-15 years, I am getting, many news articles, like water for marriage. It's like, even for marriage alliance, people are looking, is there, water available, good water source available, and some articles I have seen where the marriage alliances have been declined because of not availability of the water. So you can imagine, the importance of water, how much it is there. So, along with, the management of water resources, its multiple use, recycle, reuse, we also have to think very seriously how to save, how to conserve the water. And for that, उसके लिए मैं बचपन से जो पढ़ता था वो शेयर करना चाहता हूँ। रहमन पानी राखिए, बिन पानी सब सून। तो वहाँ पे पानी का जो मतलब है वो इज्जत है। तो हमें पानी बचाने के लिए वैसे ही सोचना है जैसा कि हम अपनी इज्जत बचाने के लिए सोचते हैं। और जिस दिन हम उस चीज़ को अपने अंदर सोच लेंगे, जैसा मंत्री महोदय ने कहा कि एक एक ड्रॉप, एक एक बूंद पानी की बहुत ही बहुमूल्य है, बहुत उपयोगी है, तब हमारी प्रॉब्लम सॉल्व ही नहीं होगी, हम भी जो है दूसरे को सपोर्ट करने के योग्य हो जाएंगे इस मामले में। Now coming to Indian Desalination Association, it was established in the year 1991 in BRC with head office in Desalination Division, and there that time I was doing PhD in IIT Bombay, and I joined as a primary member of this association. And I used to visit BARC, Mumbai, for discussion, research related discussion, library related issues, where I first time met Srivastava ji. He was already working as a senior scientist there, and then I started learning about desalination from that time. And I feel very fortunate today that as a president of this association, I am we are going to felicitate him with the Lifetime Achievement Award here. Indian Desalination Association has about 600 life members, 52 corporate members, around 40 life fellow members, and which is across the whole India, and also few members from abroad we have. We are having we have established South Zone, we have established recently North Zone, where this Jodhpur is also under North Zone. We have to establish East Zone and West Zone. And in morning I was talking to the both Vice Chancellors, Professor Ajay Kumar and Professor Srivastava, and sir, I need both support from both of you, and I would be glad if we organize one event related to water issues in this Jodhpur, MBM or JNBU every year. We will be very glad and obliged to both of you. See, we are organizing many such events through Indian Desalination Association throughout the country, and as Mantri ji he was mentioning, the government of India has also set up National Desalination Mission now. And for all those who are in academics or research organization, DST had made first call for supporting research proposals under that, and you can look forward next year also very good funding support for research activity is available there. On behalf of InDA, I welcome and appeal, industry and academia, researchers and social workers to join hands with InDA and work together for the cause of water. In the end, I wish InDACON 22 a great success and hope that the deliberations in the conference will be fruitful to find cost-effective, energy efficient and least polluting sustainable solutions for desalination and water treatment. Once again, I thank the organizers for giving me this opportunity, and I have a special acknowledgement for the students, faculty, staff of this university and the chemical engineering department, and a special mention to Professor Saraswat, Professor Ajay Sharma and Professor K.L. Srivastava and Mr. Ravind Kumar ji, Director Defense Lab, being part of this. Jai Hind, Jai Bharat. Thank you.
Thank you for this insightful address, sir. Next, I would like to invite Shri Ravindra Kumar ji, Director Defense Laboratory, Jodhpur, to please address this gathering. Please.
सम्मान्य श्रीमान गजन सिंह जी शेखावत, ऑनरेबल मिनिस्टर ऑफ जल शक्ति, गवर्नमेंट ऑफ इंडिया, श्रीमान प्रोफेसर के.एल. श्रीवास्तव साहब, वाइस चांसलर जेएनवी यूनिवर्सिटी जोधपुर, प्रोफेसर अजय कुमार शर्मा साहब, वाइस चांसलर एमबीएम यूनिवर्सिटी, प्रोफेसर सुनील शर्मा, डीन एमबीएम यूनिवर्सिटी, श्री चौरसिया साहब, प्रेसिडेंट इंडियन डिसैलिनेशन एसोसिएशन, डॉक्टर सारस्वत, ऑर्गेनाइजर ऑफ दिस कॉन्फ्रेंस, डॉक्टर वी.के. श्रीवास्तव साहब, other office bearer of InDA, faculty members of MBM and JNVU University, students and delegates of this conference. सर्वप्रथम मैं आप सभी का आभार व्यक्त करना चाहता हूं कि आपने मुझे इस कॉन्फ्रेंस में आमंत्रित किया। आज का दिन मेरे लिए बड़ा अविस्मरणीय दिन है कि इंदा ने मुझे एक मंच पर माननीय मंत्री जी के साथ में मंच शेयर करने का अवसर प्रदान किया है। शेखावत जी से मेरा परिचय है। शेखावत जी को अगर मैं आधुनिक भागीरथ कहूं तो अतिशयोक्ति नहीं होगी। उनके नेतृत्व में जो घर घर नल से पानी पहुंचाने का मिशन चल रहा है, वो प्राचीन काल में जो भागीरथ गंगा लाए थे अपने 60,000 पुरखों की आत्मा को तृप्त करने के लिए, ये प्रयास उससे कहीं ज़्यादा है, उससे कहीं कठिन है। आप सभी लोग पश्चिमी राजस्थान को बिलोंग करते हैं। यहाँ के गांव में ढाणी में अगर आप जाएंगे तो वहाँ आप देखेंगे कि एक एक घड़ा पानी भरने के लिए लोगों को 2-2 मील, 3-3 मील, 4-4 मील चलना पड़ता है और पानी की क्वालिटी बहुत बेकार है, खारा है। ये मैं अपने एक्सपीरियंस से कह रहा हूँ। आज से 25 साल पूर्व जब हमने एक प्रोजेक्ट सुजलम चलाया था अब्दुल कलाम साहब के मार्गदर्शन में, डॉक्टर श्रीवास्तव साहब भी उसमें शामिल थे। माननीय मंत्री जी को मैं बताना चाहता हूं कि डॉक्टर श्रीवास्तव साहब, जिनको आज लाइफ टाइम अचीवमेंट अवार्ड इंदा दे रही है, उन्होंने यहाँ पश्चिमी राजस्थान में भी काम किया हुआ है। उन प्लांट्स को एस्टेब्लिश करने में हमने 30 डिसैलिनेशन प्लांट, जो 29 डीएलजे ने एक ईडी वाटर डिसैलिनेशन टेक्नोलॉजी डेवलप की थी, उस पर आधारित थे, और एक जो आरओ टेक्नोलॉजी उस समय बीआरसी ने डेवलप की थी, एक प्लांट उस पर आधारित लगा था। तो 30 प्लांट उस समय आज से 25 वर्ष पूर्व हम लोगों ने लगाए थे। विष्णु साहब भी बैठे हैं, ये भी उस समय एसोसिएटेड थे पीएचडी की तरफ से। तो वो एक हमारा प्रयास था कि लेबोरेटरी के अंदर जो टेक्नोलॉजी डेवलप होती है उसको कैसे हम गांव-गांव, ढाणी तक पहुंचाएं, और वो 30 प्लांट काफ़ी अच्छे समय तक काम करते रहे। और उस समय जो मेरा एक्सपीरियंस है, जो मैंने गांव वालों से वहाँ बात किया, क्योंकि मैं पर्सनली वहाँ उस समय मौजूद था, कई उस समय मैं उस परियोजना में क्वालिटी कंट्रोल और इंस्टॉलेशन में इन्वॉल्व था, तो मैंने वो 30 गांव विजिट किए हैं पर्सनली। और वहाँ के जो नागरिकों का, जो गांव वालों का जो अनुभव था वो ये था कि आप हमारे लिए गंगा लेके आए हैं, आप हमारे लिए भागीरथ हैं। तो मैं उसी अपने अनुभव से कहता हूँ कि शेखावत साहब भी देश के लिए भागीरथ से कम नहीं है। माननीय प्रधानमंत्री जी के नेतृत्व में जो उनके विजन के अंतर्गत ये मिशन चलाया जा रहा है, उससे भारत की समस्याएं, पीने की समस्याएं बहुत दूर होंगी। और अब हम वैज्ञानिकों का, टेक्नोलॉजिस्ट का ये दायित्व है कि उस घर घर पहुंचने वाले पानी की क्वालिटी को हम इम्प्रूव करें, उसकी अवेलेबिलिटी को बढ़ाएं। और अवेलेबिलिटी को बढ़ाने के लिए वाटर की स्कैर्सिटी नहीं है, हिंदुस्तान में तो बिल्कुल नहीं है और विश्व में भी नहीं है, क्योंकि 98% जो पानी है वो सी के वाटर के रूप में उपलब्ध है, और उसकी क्वालिटी लेकिन ड्रिंकेबल नहीं है। वाटर एवरीवेयर, नॉट ए ड्रॉप टू ड्रिंक, दिस इज द कंडीशन। और हियर द रोल ऑफ टेक्नोलॉजी, रोल ऑफ साइंस is important, very very important, and InDA provide that platform where technologists can share their ideas, can share their technologies, and now we have to make efforts to develop technologies which are cost effective, which can be utilized by common man or common soldier, and totally indigenous. Why indigenous? Because if we see the quantum of technology requirement, it's very very high. large number is required. If we are dependent on this important thing on foreign suppliers, a lot of Indian money will go waste. So हमें अपनी टेक्नोलॉजी डेवलप करनी है, अपनी इंडस्ट्री डेवलप करनी है और गांव-गांव ढाणी-ढाणी तक ये टेक्नोलॉजीज पहुंचानी है। मैं थोड़ा सा वक्त लेना चाहूँगा 5 मिनट और अपनी लेबोरेटरी, डिफेंस लेबोरेटरी जोधपुर के बारे में बताना चाहूँगा, क्योंकि हमारी लेबोरेटरी 1959 में स्थापित हुई और तभी से वाटर के फील्ड में काम कर रही है। हमने पूरे पश्चिमी राजस्थान के गांव-गांव का वाटर क्वालिटी सर्वे किया है और हमें मालूम है कि मेजॉरिटी ऑफ गाँव में, उस समय तो ये राजस्थान कैनाल नहीं थी, इंदिरा गांधी कैनाल नहीं थी, उस समय सभी अंडरग्राउंड वाटर पे डिपेंडेंट थे और वो पानी बहुत खारा था। तो उसके लिए टेक्नोलॉजीज़ की ज़रूरत थी। तो उस समय हम लोगों ने ये ईडी वाटर डिसलिनेशन टेक्नोलॉजी बनाया, वाटर क्वालिटी मॉनिटरिंग किट भी बनाया और उसके बाद में हम लोगों का जो डिफेंस लेबोरेटरी का प्रयास है, क्योंकि रक्षा के क्षेत्र में और ज़्यादा चुनौतियां हैं, वहाँ हम खाली प्राकृतिक कंटेमिनेशन की बात नहीं करते हैं, जो मैन मेड कंटेमिनेशन है, जो एनिमी से इंड्यूस्ड कंटेमिनेशन है, उनकी भी हमने टेक केयर करनी है। अगर आज CBRN न्यूक्लियर ब्लास्ट हो जाता है तो सारा हमारा जो पानी है, ओपन वाटर सोर्स हैं, लाइक कायलाना लेक है, वो सब कंटेमिनेट हो जाएगी रेडियोएक्टिव धूल से। तो उस धूल को दूर करके पानी को पीने योग्य बनाने के लिए हमारी लेबोरेटरी ने एक बहुत ही अच्छी टेक्नोलॉजी मोबाइल वाटर प्यूरिफिकेशन CBRN वाटर प्यूरिफिकेशन प्लांट डेवलप किया है, जिसकी कैपेसिटी करीबन 2500 लीटर पर आवर है और वो प्लांट सारे क्षेत्रों में काम कर सकता है, हाई एल्टीट्यूड में भी काम कर सकता है, डेजर्ट में भी काम कर सकता है, कोस्टल एरिया में काम कर सकता है। और उस प्लांट का सक्सेसफुल हमने डेवलपमेंट किया है और उसका इंडक्शन का प्रोसेस चालू है। उस परियोजना के निदेशक श्री पाटीदार जी इस कॉन्फ्रेंस से भी जुड़े हुए हैं, उनकी टीम यहाँ पूरी मौजूद है और उस प्लांट का बहुत ही लार्ज नंबर में, ये वर्ल्ड क्लास टेक्नोलॉजी है। आई कैन मंत्री महोदय से मैं प्रार्थना करना चाहता हूं कि एक बार लैब में पधारें और हमारी द्वारा डेवलप की गई टेक्नोलॉजीज को देखें। हमने CBRN वाटर कंटेमिनेशन प्योरिफिकेशन में देश को आत्मनिर्भर बनाया है और इस टेक्नोलॉजी के करीबन 200 प्लांट सर्विसेज में इंडक्ट होंगे और ये सिविलियंस को भी इन केस ऑफ ए डिसास्टर प्योरीफाइड वाटर प्रोवाइड करने का काम करेगा। साथ ही नेवी की जो रिक्वायरमेंट है वाटर डिसैलिनेशन की, उसके केस में भी हमने एक इमरजेंसी सर्वाइवल किट बनाई है जो नेवी में इंडक्ट हो गई है और इसरो के गगनयान मिशन में भी यूज होगी। ये 2 लीटर पानी को आपको कुछ नहीं करना है, पानी भरना है, थोड़ी देर हिलाना है और सीधा पीना है उसको। और नेवी ने इसको हर लाइफ सेविंग बोट जो उनकी शिप में होती है उसमें एक आवश्यक पार्ट बनाया है। इसी किट को हम कन्वर्ट करके जो डेजर्ट में, थार डेजर्ट में जो सलाइन वाटर है उसके लिए भी उपयोगी बना रहे हैं, जिससे कि वो सिविलियन उपयोग में भी लाया जा सके। साथ ही हम एक ऐसा हैंडपंप डेवलप कर रहे हैं इंडस्ट्री के माध्यम से सर, जो 10 से 15 लीटर पानी को बाय हैंड यू कैन पंप इट एंड इट कैन डिसैलिनेट आल्सो सर। एक हमने पंप बनाया है जो डिसैलिनेशन नहीं करता है, बाकी डिसकंटिन्यूस को जो भी इसकी खराबियां हैं उनको दूर करता है बायोलॉजिकल और उसको। लेकिन दूसरा पंप हम डेवलप कर रहे हैं जो इसी साल में डेवलप हो जाएगा, वो नेवी के लिए डेवलप कर रहे हैं, लेकिन उसका यहाँ वेस्टर्न राजस्थान में, मारवाड़ में, गांव-गांव में, धानी में उपयोग हो सकता है सर। और उसके लिए मैं आपसे अनुरोध करूंगा कि एक बार पधारें सर और हमें ये अवसर दें कि हम आपको अपने द्वारा डेवलप की हुई टेक्नोलॉजीज़ को दिखाएं और आपके द्वारा जो भी और लक्ष्य दिए जा सकते हैं, मैं DRDO की तरफ से आपको एश्योर करना चाहता हूं कि हम उन लक्ष्यों को उन टेक्नोलॉजीज़ को डेवलप करेंगे और देश को उपलब्ध कराएंगे। इसके साथ ही मैं उन्हें एक बार अपना धन्यवाद ज्ञापित करना चाहता हूं, माननीय मंत्री महोदय जी को भी और इस इंदा कॉन्फ्रेंस के आयोजकों को भी, जिन्होंने मुझे ये अवसर प्रदान किया और मुझे आपके समक्ष बात रखने का मौका दिया। धन्यवाद।
Thank you, sir. Thank you for this kind address. Moving ahead with the program, I would like to invite our today's guest of honor, Professor K.L. Srivastav, sir, Vice Chancellor Janand Vyas University, to address this gathering. Please, sir.
आभार उद्घोषक महोदय जी। गुड मॉर्निंग फ्रेंड्स। सर्वप्रथम मैं आभार व्यक्त करना चाहूँगा माननीय कैबिनेट मंत्री, जल शक्ति मंत्री गजेंद्र सिंह जी शेखावत साहब का, जिनसे हमेशा का हमारा एसोसिएशन है। इस ट्विन यूनिवर्सिटीज़, मैं इनको ट्विन यूनिवर्सिटीज़ कहूँगा, MBM यूनिवर्सिटी एंड जनरल व्यास यूनिवर्सिटी, जिसमें वो छात्र संघ के अध्यक्ष थे। मुझे याद है उन दिनों मैं टीचर्स एसोसिएशन का अध्यक्ष हुआ करता था और हम दोनों मिलकर विश्वविद्यालय के उत्थान के लिए कई ज्वाइंट मूवमेंट्स में साथ साथ थे। गज्जू बन्ना या गजेंद्र सिंह जी शेखावत हम सब के साथ हमेशा हैं। यहाँ उनकी उपस्थिति हम बिल्कुल उसी तरीके से महसूस कर रहे हैं जो सच में दिल से आज हमारे साथ है। वर्चुअली ज़रूर वो हमसे जुड़े हुए होंगे। मंच पर उपस्थित नो लेस देन प्रेसिडेंट हिमसेल्फ ऑफ सैलिनिटी एसोसिएशन, SP चौरसिया साहब, रविंदर कुमार जी इंजीनियर साहब, डायरेक्टर DRDO, मेरे अजीज़ मित्र और इस विश्वविद्यालय के गौरव, डायनेमिक, डेडिकेटेड न्यू वाइस चांसलर प्रोफेसर अजय शर्मा साहब, और की फिगर्स इस कॉन्फ्रेंस के सुशील सारस्वत साहब और डीन साहब सुनील शर्मा जी। मैं विषय पे आऊँ उसके पहले एक छोटी सी बात ज़रूर कहना चाहूँगा। हमारा डिसोसिएशन हुए 1 महीना हुआ है। ये डिसोसिएशन हमारा आपसे अलग होना, यानी MBM यूनिवर्सिटी से अलग होना, सिर्फ भौतिक है। दिल हमारे मिले हुए हैं। हमारे कुछ वायदे हैं एक दूसरे से। मैंने और अजय जी ने साथ बैठ के कुछ ऐसे वायदे किए हैं। वो वायदे इतने प्यारे थे, इतने अजीज थे कि एग्रीमेंट 1 दिन के अंदर हो गया। मैं चाहता हूं कि उन वादों को आप तक भी पहुंचाया जाए। अगर हमारे बीच कहीं कोई व्यवधान आ रहा है चीज़ों को समझने में, तो ये बात बिल्कुल स्पष्ट एक दूसरे को कर दी जाए कि हम स्टिल ओपन एंडेड हैं, सब कुछ एक दूसरे को देने के लिए तैयार हैं। अब मैं कॉन्फ्रेंस पे आता हूँ। कॉन्फ्रेंस बहुत महत्वपूर्ण है। हमने तो सबसे पहले एक पूरी कॉन्फ्रेंस के लिए एक बहुत बड़ा रिसर्च पेपर सुना गजेंद्र सिंह जी शेखावत के द्वारा। हम कितने सौभाग्यशाली कि हमारे देश में एक ऐसे जल शक्ति मंत्री हैं जो स्वयं इतने हाईली एजुकेटेड हैं, डेडिकेटेड हैं, नॉलेजेबल हैं कि हमें उसका पूरा फ़ायदा मिल रहा है। जिसके पास इतनी ज्ञान, इतनी प्लानिंग, इतना समर्पण हो, तो भविष्य तो जल शक्ति मंत्रालय का जो हमसे जुड़ा हुआ है निश्चित रूप से उज्ज्वल है। मेरा विशेष सम्मान प्रोफेसर साहब को, VK श्रीवास्तव साहब को जाता है, जिन्होंने ताउम्र इस फील्ड पे काम किया है और लाइफ टाइम अचीवमेंट आज लेने जा रहे हैं। डिसैलिनेशन की जो प्रॉब्लम है, हम सब बहुत अच्छे से जानते हैं कि इसका फंडामेंटल ओरिजिन मिडिल ईस्ट से हुआ। मिडिल ईस्ट यानी डेजर्टिक एनवायरमेंट्स, सीरियस डेजर्टिक एनवायरमेंट, क्रिटिकल डेजर्टिक एनवायरमेंट्स। मिडिल ईस्ट के कंट्रीज मीन्स इवन टचिंग पार्ट ऑफ नदर्न अफ्रीका एंड सम पार्ट ऑफ वेस्टर्न अफ्रीका। इनकी अपनी समस्या थी, पानी था ही नहीं। जब पानी नहीं है तो उन्हें उसके लिए कोई ना कोई इंतजाम करना पड़ेगा। उन्होंने तरीके अपनाए और डिसैलिनेशन की शुरुआत करी। ये डेजर्टिक कंडीशंस हमारे यहाँ भी वैसी ही प्रिवेल कर रही हैं, मे नॉट बी दैट क्रिटिकल। देखिए हमारे यहाँ जो सबसे पश्चिमी राजस्थान की सबसे प्रोमिनेंट नदी जो है उसका नाम क्या है? लूनी। A river which is filled up with the salt, लूण जिसमें भरा हुआ हो वो नदी लूनी नदी है। नदी तो कहाँ है, पानी तो इसमें कहाँ है और कितना है, लेकिन नमक हाँ ज़रूर बहुत ज़्यादा भरा है। हमारे यहाँ सेलाइन लेक्स की सीरीज़ है, हम सब सांभर को बहुत अच्छे से जानते हैं। Another salt lake prominent one is Didwana and yet another prominent salt lake is Pachbhadra. पचभद्रा अगेन मीन 5 वाटर्स। हम ऐसा मान के चलते हैं कि किसी समय 5 पानी इसमें आके मिला करते थे। इसमें से कई ट्राइब्यूटरीज थी उस समय की सरस्वती नदी की, जो एक पॉन्ड में आके मिला करती थी। पॉन्ड ग्रेजुअली इवेपोरेट हो गया और सैलाइन लेक में कन्वर्ट हो गया एंड नाउ वाटर इज पॉसिबली टोटली इवेपोरेटेड एंड रिजल्टेंटली there is only pan available, salt pan is available in Pachbhadra. इन सर्कमस्टांसेस में जब भी हमें किसी भी तरीके का पानी चाहिए हो, चाहे एग्रीकल्चर के लिए, चाहे पोर्टेबल, चाहे ड्रिंकेबल, चाहे फॉर एनी पर्पज़ ऑफ एनी काइंड, डिफेंस के पर्पज़ के लिए, वहाँ रहने वाले लोगों के पर्पज़ के लिए, किसी भी तरीके से उसको ट्रीट तो हमें करना ही पड़ेगा। ट्रीट करने में हमें कोई दिक्कत नहीं है, हमारी टेक्नोलॉजी उस जगह तक पहुंच गई है जहां हम इसको ट्रीट कर सकते हैं। बट द स्टिल फंडामेंटल क्वेश्चन रिमेन कमर्शियली वायबल। इट शुड रिमेन कमर्शियली वायबल। हम अगर सेना को कहीं आगे मार्च कर रहे हैं, सर ने अभी अभी कहा, हम उनको वो टैबलेट दे सकते हैं जो वाटर को ट्रीट कर सकती हैं, लेकिन हम हर किसी को शायद उतनी कीमती टैबलेट, जो अभी भी रिलेटिवली कीमती हैं, बहुत कीमती तो नहीं है। इनका एग्जीबिशन में अभी कुछ दिन पहले अपने MBM में जो एग्जीबिशन हुई थी, आप लोगों ने देखा होगा, ये चीज़ें वहाँ डिस्प्ले करी गई थी कि कैसे सलाइन वाटर को हम लोग वहाँ ट्रीट करते हैं। सलाइन वाटर के बहुत, मैंने कहा ना, एक शोध पत्र अभी गजेंद्र जी ने पढ़ा, उन्होंने कोस्टल लाइन की बात करी। सैलिनेशन का कोस्टल लाइन से बहुत सीधा संबंध उन्होंने दशमलव में बताया। मुझे तो मोटा मोटा याद है कि 8000 किलोमीटर के करीब कोस्ट लाइन भारत में है। ये जो कोस्ट लाइन है, इसके किनारे जब भी हम ग्राउंड वाटर का ड्राफ्ट करते हैं या ओवर ड्राफ्ट करते हैं, जब भी आप ओवर ड्राफ्ट करेंगे, जमीन के अंदर का ग्राउंड वाटर ऊपर निकलता जाएगा और नीचे वो सक करेगा सी वाटर को। सो रिजल्टेंटली इन द लैंड सी वाटर पेनिट्रेट डीप इनसाइड एंड क्रिएट्स अ परमानेंट प्रॉब्लम। कोस्टल एरिया की अपनी समस्याएं हैं। ये जो पेनिट्रेशन ग्राउंड वाटर का होता है, दिस इज इन द फॉर्म ऑफ वेज। ओवरड्राफ्ट ऑफ फ्रेश ग्राउंड वाटर रिजल्ट्स इनटू वेज शेप पेनिट्रेशन ऑफ द सलाइन वाटर इन कोस्टल एरियाज। आइसलैंड की समस्याएं इससे डिफरेंट नहीं हैं। ये तो हमें पता है कि कोस्ट लाइन हमारी बहुत लंबी है, भारत की 800 किलोमीटर की, लेकिन आइलैंड के बारे में हम लोग थोड़ा सा कंफ्यूज्ड हैं। कंफ्यूज्ड इसलिए हैं कि आपको जान के आश्चर्य होगा, कि सिर्फ बंबई के पास 200 आइलैंड हैं। एलिफेंटा हम जानते हैं, हम टूरिस्ट बन के घूम के एलिफेंटा आ जाते हैं, लेकिन वही 200 आइलैंड है। व्हाट टू टॉक अबाउट अंडमान निकोबार, तो इतने सारे आइलैंड जो हमारे अपने हैं, अगर हम दुनिया की बात करें तो पपुआ न्यू गिनिया एंड न्यूजीलैंड जो ऑस्ट्रेलिया के पास, और इधर कैरेबियन आइलैंड्स, इन सारे आइलैंड्स में भी जब ग्राउंड वाटर का हम ओवरड्राफ्ट करते हैं तो द सी वाटर पेनिट्रेट्स फ्रॉम ऑल द साइड्स और पूरा आइलैंड रहने लायक नहीं बचता है। बात सिर्फ इतनी नहीं है, मैं सिर्फ समस्याओं की बात कर रहा हूँ, बात सिर्फ इतनी नहीं है, बात इससे कई ज़्यादा सीरियस है। मैंने 1990 में पहला लेक्चर ग्लोबल वार्मिंग पे चाइना में दिया था। मैंने कहा था कि पता नहीं, समझ नहीं आ रहा है कि ग्लोबल वार्मिंग आ रही है कि नहीं आ रही है, द एविडेंसेस आर कन्फ्यूजिंग। उसके 5 साल बाद मैंने दूसरे कॉन्टिनेंट में लेक्चर दिया। मैंने कहा एविडेंसेस आर इन फेवर दैट वेल ग्लोबल वार्मिंग इज कमिंग, वी शुड बी अलर्ट अबाउट। उसके बाद मैंने फिर 5 साल बाद कहीं और, मैंने हर कॉन्टिनेंट में लेक्चर दिया है किसी और कॉन्टिनेंट में मैंने ग्लोबल वार्मिंग का लेक्चर दिया, वहाँ मैंने कहा नाउ दिस इज श्योर दैट ग्लोबल वार्मिंग इज अहेड ऑफ अस, और 20 साल के अंदर इसके क्रिटिकल परिणाम हमारे सामने आने वाले हैं। और आज मैं आपके सामने जब खड़ा हूँ तो 20 साल पूरे हो चुके हैं। हमें तो कुछ खास पता नहीं चल रहा, ऐसा है नहीं। द थिंग्स आर बैड टू वर्स्ट। इस ग्लोबल वार्मिंग से जो कुछ होने वाला है उसके दुष्परिणामों के लिए हमेशा से हमें सूचित किया जाता रहा है, और जो कुछ हमने पूरी दुनिया में, भारत सहित जो कुछ किया है वो बहुत ही कम है, बहुत ही कम है। फॉर एग्जाम्पल, पूरी दुनिया की ज्योग्राफी का नक्शा बदलने वाला है। आप 3 मीटर समुद्र के पानी को अगर घुसेड़ देंगे तो जो हमारा बांग्लादेश है वो सारा आधा कवर हो जाएगा, बम्बई के पास की बहुत सारी चीज़ें डूब जाएंगी, मालदीव देश ही खत्म हो जाएगा इस तरीके की सर्कमस्टांसेस ग्लोबल वार्मिंग में हमें विशेष रूप से क्या इससे नुकसान होने वाला है, अपार्ट फ्रॉम दिस मैनी डिजीजेज एंड अदर थिंग्स, स्किन डिजीजेज और डेंगू वगैरह वगैरह, बट हाउ दिस इज कनेक्टेड विद सैलिनिटी। देखिए, ग्लोबल वार्मिंग के समय मनुष्य पूरी तरीके से अब तैयार हो रहा है। मैं डे ड्रीमिंग नहीं कर रहा हूँ, मैं आपको बिल्कुल सच्ची बात बता रहा हूँ, एक फैक्ट बता रहा हूँ, टू शिफ्ट टू अनदर प्लैनेट। Human beings are now planning to shift to another planet, or if you want to live in this planet, you have to live in altogether in different circumstances, and such circumstances will be जैसे स्वामीनाथन साहब ने वार्न किया था ग्लोबल वार्मिंग आ रही और खेती के पैटर्न को आप बदल दीजिए तुरंत। क्यों? हमारा तो एग्रीकल्चर का देश ही है, हम तो रबी और खरीफ 2 फसलें लेते हैं। क्यों लेते हैं? क्योंकि हमारा मौसम वैसा है। और जब मौसम ही हमारा एडवर्स हो गया, जब हमारी खड़ी फसल है, ओले गिर रहे हैं, और एक बार नहीं बार बार ओले गिर रहे हैं, और टाफून आ रहे हैं, और साइक्लोन आ रहे हैं बिकॉज ऑफ ग्लोबल वार्मिंग, तो हमारी तो खेती तो बर्बाद हो जाएगी। देन व्हाट अल्टरनेटिव्स वी हैव? वी हैव अल्टरनेटिव्स। ह्यूमन बींग्स हैव नाउ स्टार्टेड शिफ्टिंग टूवर्ड्स ओशन। हमारी खेती अब समुद्र में होने वाली है, मजाक नहीं कर रहा हूँ। हम रहने जाने वाले हैं अब समुद्र के अंदर। आप फिर कहेंगे कि आई एम थिंकिंग टू लाउड, कपोल कल्पनाओं में मैं जी रहा हूं। ये सच है। और जापान में वो कॉलोनियां बन चुकी हैं जिसमें समुद्र के अंदर अब लोग रहने लगे हैं टू कूप अप विद द ग्लोबल वार्मिंग सर्कमस्टांसेस। अगर ये सच है जो मैं कह रहा हूं कि जापान में कॉलोनी बन गई है पानी के अंदर, खेती हमें करनी है तो हमें काई उगानी है और काई खानी है समुद्र के अंदर की, अगर ये बातें सच हैं, कितना इम्पॉर्टेंट चीज़ है डीसैलिनेशन। उन कॉलोनीज के लिए द ओनली वाटर विच इज अवेलेबल फॉर अस टू ड्रिंक इन एनी वे इज नन अदर देन ओशन वाटर इटसेल्फ। इस सैलिनिटी कॉन्फ्रेंस की सिग्निफिकेंस को मेरे ख्याल से आई एम वेरी वेल एम्फेसाइज्ड। बहुत बधाई के पात्र हैं वो लोग जिन्होंने इस कॉन्फ्रेंस के आइडिया को नर्चर किया, इसको इंटरनेशनल एरिना दिया। बहुत बधाई के पात्र हैं हमारी केमिस्ट्री डिपार्टमेंट के सारस्वत, उनकी टीम ऑफ रिसर्चर्स। बहुत बधाई के पात्र हैं इन्वायरमेंट के साइंटिस्ट जो इस इंस्टीट्यूशन से सीधे जुड़े हुए हैं, हमारे भाई केमिकल इंजीनियरिंग के व्यास जी और इन्वायरमेंटल साइंस के एस के सिंह साहब और उनकी वो सारी टीम जो डेडिकेशन से इस फील्ड में रिसर्च कर रही है। हम सौभाग्यशाली होंगे डिफेंस लैब के साथ और कोलैबोरेशन करने के लिए। वी डबली एश्योर यू सर, वी विल कीप डूइंग इट और फॉर द वेलफेयर ऑफ द सोसाइटी, for the welfare of the science, for the welfare of the salinity research, and at last for the welfare of the humanity, we all are fully dedicated. शेखावत साहब मेरे ख्याल से गए नहीं हैं वो तो। सर हमारी आदत कुछ कुछ मांगने की है हमेशा। वेस्टर्न राजस्थान आपसे एक इंस्टीट्यूट चाहता है जो फुल्ली डेडिकेटेड हो ग्राउंड वाटर रिसर्च के लिए। हम इसमें बिल्कुल नहीं जा रहे कि आप जय नारायण व्यास को ही वो इंस्टीट्यूशन दें, हम नहीं जा रहे हैं कि आप एमबीएम को इंस्टीट्यूशन दें, डिफेंस लैब को दें या काजरी को दें, लेकिन दिस शुड नॉट बी प्योरली अ साइंटिफिक इंस्टीट्यूशन बट ऑल्सो इंस्टीट्यूशन ऑफ सोशल साइंसेज एज वेल। एक बिग इंस्टीट्यूशन, नॉट to the less status than hydrological institute placed in रुड़की IIT। वेस्टर्न राजस्थान को एक जल शक्ति मंत्रालय का सिर्फ जल शोध के लिए, जल प्लानिंग के लिए, जल एडमिनिस्ट्रेशन के लिए हमें एक इंस्टीट्यूट की ज़रूरत है। हमसे ज़्यादा आप इस बात को जानते हैं एंड वी विल रियली बी ग्रेटफुल फॉर योर सच एन अनाउंसमेंट एवर। थैंक यू वेरी मच।
शर्मा, we should apologize because अब मुझे निकलना पड़ेगा। 12 बजे मेरी दूसरी मीटिंग है। मैं जस्ट छोटी सी बात एक बताना चाहता हूँ। प्रोफेसर श्रीवास्तव ने जो अभी बात कही है, he has spoken about an institute, as to establish an institute in Jodhpur about water। तो हमने IIT जोधपुर में एक ऑलरेडी ग्राउंड वाटर एंड वाटर रिलेटेड एक्टिविटीज़ के लिए एक प्रोफेसर चेयर एस्टेब्लिश करने का निर्णय कर दिया है और उसके ऊपर काम करना भी शुरू कर दिया है। अपार्ट फ्रॉम दैट, नेशनल इंस्टीट्यूट फॉर पब्लिक हेल्थ इंजीनियरिंग, जहाँ पानी से जुड़े हुए सारे विषय, ड्रिंकिंग वाटर के बाद में सीवेज वाटर ट्रीटमेंट, इन सब के ऊपर रिसर्च होने वाली है। उसका कलकत्ता में जो सेंटर बनना प्रपोज किया है, जो बन गया है, ऑलमोस्ट कंप्लीशन पर है। उस सेंटर का एक्सटेंशन 2 जगह में, एक जोधपुर में और एक चेन्नई में, 2 जगह उसका एक्सटेंशन जो है वो बनाने के लिए भी हमने काम करना शुरू कर दिया है। हमारे जो केन एनर्जी का ट्रेनिंग सेंटर है, केन एनर्जी से बात कर रहे हैं कि इनके साथ में एसोसिएट करके और ये ट्रेनिंग सेंटर के साथ में को हम जो है पीएचई के ट्रेनिंग सेंटर के लिए सेंटर ऑफ एक्सीलेंस फॉर पब्लिक हेल्थ इंजीनियरिंग, उसके साथ में डेवलप करके इवॉल्व कर रहे हैं। मैं एक छोटा सा विषय और रखना चाहता हूँ बीच में, आप सबसे माफी मांगते हुए। ठीक है, अभी जब ऑयल एक्सप्लोरेशन अपने वेस्टर्न पार्ट ऑफ राजस्थान में हो रहा है, केएनएन और ओएनजीसी दोनों ने इस बात को जो है सर्टिफाई किया है कि हमारे बाड़मेर और जैसलमेर दोनों के बीच में एक्वाफर्स में लगभग 250 BCM पानी अवेलेबल है। 250 BCM पानी की अगर मैं बात करता हूं तो इट इज क्वांटम ऑफ द टोटल रिजर्वायर कैपेसिटी ऑफ द कंट्री आज की तारीख में जो है। और उतना पानी है, वो पानी 3000 ppm से लेकर के 30,000 ppm तक का उसमें सैलिनिटी है। समुद्र के पानी को जब हम डिसलाइन करने की बात करते हैं वो 17 से 20,000 ppm के बीच का होता है नॉर्मली। अगर हम 3,000 से 17,000 के बीच के ब्रैकेट को भी आइडेंटिफाई करें और वो 50-60 BCM पानी भी अगर है तो ये हमारे लिए एक बहुत बड़ी अपॉर्चुनिटी हो सकती है। दूसरा, डिसैलिनेशन के लिए सबसे बड़ी रिक्वायरमेंट जो है वो एनर्जी की होती है। हमारे पास में सोलर एनर्जी इस एरिया में अबंडेंस में अवेलेबल है, इंस्टॉल की जा सकती है, कैप्टिव कंजम्पशन प्लांट बनाए जा सकते हैं। आज की तारीख में जो भारत सरकार की पॉलिसीज हैं, उस पॉलिसीज के हिसाब से अगर हम किसी ऐसे कैप्टिव पर्पस के लिए, मेदर इट इज मेकिंग ऑफ हाइड्रोजन और इट इज मेकिंग ऑफ अगर हम डिसैलिनेशन प्लांट के लिए कैप्टिव प्लांट बनाते हैं तो हमारी कॉस्ट ऑफ इलेक्ट्रिसिटी इट कम्स डाउन टू एज लो एज ₹1.99 और इवन लोअर देन दैट इट इज गोइंग टू कम डाउन। तो अगर 1.5 रुपए में बिजली अवेलेबल है और हमारे पास में जमीन में खारा पानी अवेलेबल है, हम एक परमानेंट सॉल्यूशन ड्रिंकिंग वाटर का इस बाड़मेर और जैसलमेर के लोगों को दे सकते हैं। आई वुड रिक्वेस्ट, आज इस कॉन्फ्रेंस में सारे स्टेक होल्डर्स अवेलेबल है। एमबीएम यूनिवर्सिटी भी इसमें लीड ले, डीआरडीओ इसमें साथ में सहयोग करे, और जो इंडियन डिसैलिनेशन ऑर्गेनाइजेशन है वो तीनों मिल करके इसका एक वर्केबल सॉल्यूशन बना करके मुझे दे दें कि हम किस तरह से ये जो पानी का एक अकूत भंडार हमारे पास में अवेलेबल है, इसको हम कैसे पीने के पानी के सोर्स के लिए यूटिलाइज कर सकते हैं। तो आई विल बी सो ग्रेटफुल, सो थैंकफुल, एंड दिस इज गोइंग टू बी अ सर्विस टू आवर एरिया एंड नेशन बोथ। थैंक यू, धन्यवाद आप सबका। मैं प्रोफेसर शर्मा साहब से अनुमति चाहता हूं कि मुझे बीच में जाने की अनुमति आपको देना पड़ेगा, क्योंकि 12 बजे मुझे एक इम्पोर्टेंट कॉन्फ्रेंस है जो ग्रुप ऑफ मिनिस्टर्स की मीटिंग है, उसमें इसके लिए जाना पड़ेगा। आप सबका बहुत सारा धन्यवाद।
सर मैं आपके 1 मिनट आपको और लेना चाहूँगा। एमबीएम विश्वविद्यालय, जयनारायण विश्वविद्यालय और हम सब की तरफ से आपका बहुत बहुत धन्यवाद। अब हमारे साथ इतने समय तक जुड़े रहे, और मुझे ये उम्मीद थी कि जैसे बताया गया था कि आप सिर्फ 45 मिनट के लिए हमारे साथ हैं, पर ये हमारा सौभाग्य है कि आप हमारे साथ इतने समय जुड़े रहे। और सर मैं जो है, आप हमारे लिए पराये नहीं है, आपके तो पीढ़ियों से सर एमबीएम से नाता है। आपके पिताजी जो है वो एमबीएम के हमारे एल्यूमिनी है, और हमारा सौभाग्य है कि वो भी आपके साथ यहाँ पर जब एमबीएम में आप पधारे तो वो भी हमारे साथ पधारे, तो ये हमारे लिए सौभाग्य रहेगा। आपका सर स्वागत तो हम नहीं कर पाए, लेकिन एक यादगार के तौर पे मैं श्रीवास्तव साहब का आपको एक हम वर्चुअली एक यहाँ से हमारा मोमेंट तो देना चाह रहे हैं, उसको स्वीकार करें सर। दिल्ली आके आपको ज़रूर देंगे वो हम, पर एक बार सर ये हमारी तरफ से आपको एक यादगार के तौर पे हम आपको भेंट करना चाह रहे हैं।
मेरा मीमेंटो तो मेरे लिए मोर इम्पोर्टेंट मीमेंटो वही होगा कि आप ये जो मैंने जो अभी एक काम बताया है, वो जो प्रोजेक्ट है, और इस पे अगर कोई फाइनेंशियल असिस्टेंस इसके स्टडी के लिए चाहिए तो मैं आई हैप्पीली ग्रांट दैट असिस्टेंस। अगर एमबीएम उसमें लीड ले या डीआरडीओ लीड ले, जो भी लीड लेगा, मैं आई विल बी हैप्पी टू एक्सटेंड द फाइनेंशियल।
सर मैं आपको विश्वास दिलाता हूं कि बहुत जल्दी हम सब मिलके एक इस पे कार्यक्रम एक आपको देंगे, और बहुत जल्दी एक इसका समाधान भी हम निकाल के एक टाइम बाउंड प्रोग्राम उसमें रखेंगे प्रोग्राम, और बहुत जल्दी इस पे एक समाधान निकाल के और आपके द्वारा ही इसका इनॉग्रेशन कराएंगे और देश को समर्पित करेंगे। थैंक यू सर, थैंक यू वेरी मच सर।
Thank you, sir. Thank you for your presence. Moving ahead with the today's program. Next in line, I would like to invite the editorial team to come with the proceedings, and I would like to request our guests to release the proceedings of InDACON 2022. Editorial team. Next, I would like to take this opportunity for presentation of Lifetime Achievement Award to Dr. V.K. Srivastav sir. Sir, please come on stage. And I would like to request President Indian Desalination Association to present the award to Dr. V.K. Srivastav.
First, I shall read the citation about this award. Lifetime Achievement Award 2022 to Professor Vinay Kumar Srivastav. Professor V.K. Srivastav, born on 15th April 1954, did his B.E. Chemical Engineering in 1974 and ME in Chemical Engineering in 1976 from HBTI Kanpur. He has 38 years experience in BARC in the Department of Atomic Energy and Scientific Officer. He also has 4 years and 4 months experience as Associate Professor at MGM College of Engineering and Technology, Kamote, Navi Mumbai. He has field of specialization in project management of plant projects for chemical processes and desalination plants, lithium enrichment for strategic and IPR requirements, thermal desalination technologies, solar distillation and solar desalination, nuclear desalination, membrane-based desalination, sea and effluent water desalination, electrochemical processes for production of elemental phosphorus using indigenous highly siliceous rock phosphates and field depolyments of desalination and lithium enrichment facilities. He has affiliation with professional institutions like IICHE. He has been president of IICHE in 2018 and life member of IICHE. He is, executive committee member of IICHE Mumbai Regional Center since 1989, and he is also, life member of Indian Desalination Association. He has received many awards like Indo-US Science and Technology PAL on invitations for cause of desalination. He has organized many national and international conferences in India, including ChemCon, InDACONs, on many occasions. He is, an indispensable organizing member for.
जिन्होंने निर्णय लिया कि आज मुझे ये सम्मान दें, मैं उनका सहृदय धन्यवाद देना चाहूँगा। और काम करने की तो एक प्रवृत्ति होती है, हमारी मोदी साहब कहा करते हैं आप इम्तिहान की तैयारी करते जाइए, रिजल्ट तो अपने आप अच्छा आएगा ही। आप रिजल्ट की सोच करके काम करना करेंगे तो शायद इसका रिजल्ट कुछ भी हो सकता है, बट आप वो मत सोचें, काम करते जाइए। आज की जहाँ भी आप देख रहे हैं कि मैंने जो पाया है, मैं ये कहूँगा वो ही अंतिम पड़ाव नहीं है, इसके आगे भी बहुत कुछ करने की इच्छा है। हमारे बीच में आज के मुख्य अतिथि के रूप में हमारे गजेंद्र साहब, जो यहाँ भी अभी नहीं है, अभी शायद चले भी गए हैं, उनकी उपस्थिति होती तो बहुत ही सुंदर होता, इसमें दो राय नहीं है। बहरहाल जो लोग भी यहाँ पर स्टेज पर उपस्थित हैं वो सभी, सभागृह में बैठे हुए जो लोग हैं वो सभी, ऑफलाइन ऑनलाइन जो जुड़े हुए हैं वो सभी लोगों का मैं धन्यवाद देता हूं कि वो आज के इस समारोह में इससे जुड़े और इस क्षण को देखने के लिए वो मौजूद रहे और उन्होंने तालियों के द्वारा इसका स्वागत किया। मैं उनका धन्यवाद करना चाहूँगा। और एक दो चीज़ जो मैं भविष्य के लिए मैं अभी भी मन में एक सपने की तरह सोचे हुआ हूँ, और वो ये कि इंडा किसी भी कॉलेज में, वो जेएनवी हो, एमबीएम हो, आईआईटी हो, जोधपुर हो, बम्बई में कहीं पर भी हो, आने वाले समय में एक आईडीए, इंटरनेशनल डिसैलिनेशन एसोसिएशन का कॉन्फ्रेंस, आईडीए कॉन्फ्रेंस भारत में करें, जिसकी अभी भी हम लोगों ने कल्पना ही की है लेकिन कर नहीं पाए कई कारणों से। और ये चूँकि इतना बृहद स्केल पर है, जब तक गवर्नमेंट का सहयोग नहीं होगा ये संभव नहीं है। दूसरा, इस इंटरनेशनल कॉन्फ्रेंस के द्वारा मैं भारत के बाहर विदेशों में जो बहुत सारे लोग इस पर काम कर रहे हैं उनको आमंत्रित भी करता हूं कि वो भारत में अपने संयंत्र लगाएं और यहाँ ही उसकी उपस्थिति, नौकरियां बढ़ाएं और साथ में भारत की ज़रूरतों को पूरा करते हुए भारत से एक्सपोर्ट करें, जिससे विश्व की ज़रूरतों को पूरा कर सकें। इंफ्रास्ट्रक्चर डेवलपमेंट जिसे हम कह सकते हैं, जिसमें आज गवर्नमेंट ऑफ इंडिया बहुत इस पर काम कर रही है और हमारे गजेंद्र साहब शेखावत जी का जो नेतृत्व है, मोदी साहब का नेतृत्व है, उसमें बहुत बड़ा सहयोग कर रहा है। इन सबके साथ में एक और भी बात है, फिलहाल जो इंडा का हमारा ऑफिस है वो ज़्यादातर किसी न किसी इंस्टीट्यूट एमएनआईटी या बीआरसी के अंदर है। मैं चाहता हूँ इसको एक परमानेंट स्थान मिल जाए शीघ्र, इसके लिए भी हम लोग प्रयास रहते हैं। बहरहाल ये तो रही भविष्य की बातें जो हम चाहते हैं अभी भी करना, क्योंकि हमने कहा ये पड़ाव हमारा नहीं है। आते हैं इस सम्मान के ऊपर। क्षितिजल पावक गगन समीरा, तासे बना ये मानव शरीरा, उसमें से एक जल तत्व है। 5 तत्व में बहुत मुख्य शायद हम सभी में मौजूद है, लेकिन हमने विज्ञान के द्वारा, तकनीकी के द्वारा या और सामान्य ज्ञान के द्वारा इसको अभी भी हम उस ज्ञान को प्राप्त करने की कोशिश कर रहे हैं। शायद 60 से 70% जो हमारे अंदर पानी है, ये तो अच्छा पानी होगा तो हम एक स्वस्थ व्यक्ति बनेंगे, स्वस्थ सोच रखेंगे और ना ही प्रकृति में जो जल संसाधन है उसको अच्छे से दोहन करके प्रकृति या ह्यूमैनिटेरियन के लिए अच्छे से अच्छी सेवा दे सकेंगे। इनकी समझ के लिए साइंस, विज्ञान, इंजीनियरिंग, अभियांत्रिकी, टेक्नोलॉजी, तकनीकी और सेमी कॉमर्शियल, कॉमर्शियल प्लांट्स और बाद में उसका डिस्ट्रीब्यूशन, इकोनॉमिक्स, वो सभी बहुत सारे पद्धति होती हैं जिसको करने के लिए एज ए स्टूडेंट जहाँ पर आप सभी यहाँ पर मौजूद हैं काफ़ी, मैं ये कहूँगा पठन, पाठन, मनन और चिंतन, ये 4 स्टेजेज होते हैं जिसमें पढ़ना, पढ़ाना, उसको समझना और साथ में एक चिंतन के द्वारा उसको आगे ले जाना, जो हमारे मनीषी लोग किया करते थे, हमें भी करने की आवश्यकता है। आज जिस स्थिति में मैं हूँ, मैं पढ़ाने का काम करता हूँ, पर निश्चित मैं आपको कह सकता हूँ कि जब मैंने पढ़ा था 74, 76 और उसके बाद में बीआरसी में काम किया था, शायद हमने इसमें टीचिंग या हमारे लिए कोई लर्निंग का प्रोसेस था। बट लर्निंग, अनलर्निंग एंड रीलर्निंग हैज़ टू बी ए कंटिन्यूअस प्रोसेस। आई कैन नॉट से हैव अंडरस्टूड एवरीथिंग, not that way. So that way we have to continue doing this thing. Now I think is a galaxy of the personalities are sitting on the dais. I must thank Sushil Saraswati and his team, and I would like please give a big hand so that this could be happen here in the land of Jodhpur in Rajasthan, where I have been associated, as Dr. Ravindra Kumar said, in 90s I was there. I have been coming regularly. I had eaten, don't believe it, where all around my thali used to be black insects going on, and I used to do and continue eating when I was doing the work at Sealgun village. But yes, if you have to do it, but in the return, when I produce the water, village people used to come and give me goat water and camel milk. In return, the water they were fetching from that tank. So that was a kind of, a different feeling which you could have had it, and I enjoyed that period in association with the DRDO, DLJ in doing that work. That was a great part of it. Now coming to the Indian Desalination Association and my journey little bit, I will take just 2 minutes on that. There are so many facets of any organization which is now 30 years plus, like membership drive, website design, bulletin, then accounts, making different conferences. One is here in front of you, InDACON, TSDWR, and series of conferences, national and international. Then making the things a kind of, what we call it, people to understand, like academics, sharing your knowledge, making people to awareness. Then outreach program, bringing the technology which you have developed in the lab, bringing it to the real field work, and then give the product of that. In addition to this, being a continuously on the EC, like executive committee members, doing R&D, D&D, many people may not be doing R&D, everybody knows what is that R&D. R&D is research and development, D&D is the design and development. We engineer cannot just remain with research and development. We have to go to the next stage, which is design and development, and make the things from pilot scale to semi-commercial to the commercial scale. This is where I have been very lucky to come visit at DRDO yesterday. I spent about 2.5 hours with them, and that was really a pleasure which I derived after many, many years. Wherever I have left, far they have gone ahead. So I am very happy. I must congratulate his team, Dr. Ravindra Kumar and team. They have done wonderful jobs. Now, in doing so all these things, I can say I had a privilege to work in every facet. I have been consistent in the EC members. I have designed the websites. I have made the members from, which was just 80 at that time when I became member. My membership number is only 29. And as on today, Dr. Chorisa said, now we are 600 plus live members, 50 plus corporate members, and 40 plus fellow members. This is one sample of our Indian. This is a single color design which I have been there as an editor of this. So I have been editor of this, and then later on, depending upon the money available, I made multicolor also, which has got so many things. Here I must tell you two things, one more, that government has been formulating on custom duty exemption on imports related with the desalination equipments. Many people may not be knowing, many of you may not be knowing the standards being followed for water that we drink. You are having bottles in front of you, but if I ask you what is the IS number of that bottle, 14543, you may not be knowing that. There is IS number, which is the packaged water supply, not IS, which is there 10500 for drinking water supply through the piped water system. Like that. This is the era in which we all are there. We have to make everything standard, whether it's for injectable grade, pharmaceutical grade, fruit grade, nuclear grade, electronic grade, food, and even that drinking water grades. So, very vast field of work related with water is there ahead of you. I must thank to the people who have been behind working this thing and honoring me today at this. I'm really thankful to them. I can only say this honor is just kind of a recognition for you, but doesn't stop you that you don't do any more work. You have reached to the top. So with that, I wish all of you please join. If you have not become member, please do become member so that you get the information what is going on around and around the world. I can say I still work till 1 o'clock night to learn more things about water, which is still a continuous process. Thank you very much.
Thank you, sir. In fact, I was going to appeal to you that please don't stop working for InDA after achieving this award. This is going to be a new phase of life, and you yourself has mentioned and appealed to the people. That is very good aspect, sir. And from InDA side, we are expecting you to do more work and continue working as you have been working for the InDA and for the cause of desalination and water sector. We need your services still. Thank you, sir. Please.
Something related with the Vishnu Puran, what our Dr. Srivastava said, with the global warming. And there is an instance says when the global warming happens, the rise of the sea level goes up and up. Then Lord Vishnu called, and there was a Matsya avatar was there. And in the Matsya avatar, he calls all the saints and says, people, please come and take the good seeds from the earth and go to the top in the mountain, so that even if there is a submergence is there, you could save something, and then whenever there is water recedes back or Jal Pralay is over, then you can restart the life on the earth planet. So I am sure most of you, Jal Pralay may happen, may not happen, we do not know. Whether we are there, we are not there. But it is happening the way we keep on doing this industrialization part of it. We are doing it ignorantly. But please let me tell you, whether whatever you are doing, understand the nature. If you do it with eco-friendly manner, you will do the best. You will never play with the nature. And whatever science of membrane or even thermal, nature is doing justively for you. Please understand the nature, you will understand everything.
Thank you, sir. Thank you for this educational address and sharing your knowledge with us. Next in line, I would like to invite our presiding guest, Professor Ajay Kumar Sharma, Honorable Vice Chancellor, MBM University, to address this gathering. Please.
बीच में मैं 2 बार अनइनवाइटेड आ गया था, बट नाउ दिस इज़ अ फॉर्मल एड्रेस टू स्टार्ट विद हमारे कार्यक्रम के जो मुख्य अतिथि परम आदरणीय गजेंद्र सिंह जी शेखावत साहब, माननीय मंत्री जल शक्ति गवर्नमेंट ऑफ इंडिया। हमारे बीच में हमारे गेस्ट ऑफ ऑनर प्रोफेसर के श्रीवास्तव जी, ऑनरेबल वाइस चांसलर JNV यूनिवर्सिटी, इंजीनियर रविंद्र कुमार जी, डायरेक्टर DRDO जोधपुर, प्रोफेसर SP सर सुधीर शर्मा जी, डीन फैकल्टी ऑफ इंजीनियरिंग MBM यूनिवर्सिटी। इस कार्यक्रम के जो हैं ऑर्गेनाइजिंग सेक्रेटरी प्रोफेसर सुशील जी सारस्वत जी, और मेरे MBM के साथी बाहर से पधारे हुए वैष्णव साहब और अन्य साथी, और डियर पार्टिसिपेंट्स राउंड द वर्ल्ड, बिकॉज पीपल आर in this conference throughout the world. So I will, on behalf of MBM University, I welcome you all on this platform and hope that this conference will lead to some useful contributions. जैसे कि हम पहले बार भी मैंने पहले भी कहा कि गजेंद्र सिंह जी जो हैं, गजेंद्र बन्ना के नाम से ज़्यादा फेमस हैं यहाँ जोधपुर में, और डेफिनेटली उनका अपना है और हमारे दिल से जुड़े हुए हैं। और वो जो है हम पराया जैसे उन्होंने कहा वो नहीं है, वो मैंने कहा भी सही, और ये वाकई सत्यता है। तो हम उनका स्वागत करने के लिए हमेशा तत्पर रहेंगे जब भी उनका जोधपुर आगमन होगा, या स्पेशली हम इसके लिए भी उनको आमंत्रित करेंगे। और ये एक कोइंसिडेंस कहें कि जिस दिन मैंने यहाँ ज्वाइन किया, मेरे पहले दिन, उस दिन भी जो है शाम को हमने इस केंद्रीय मंत्री जी अश्विनी जी कुमार हैं, रेलवे मिनिस्टर जो हैं हमारे सेंट्रल, और गर्व की बात यह है कि वो भी हमारे यहाँ के एलिमिनी हैं, उनका स्वागत किया था। और किसी भी इंटरनेशनल कॉन्फ्रेंस का एक विश्वविद्यालय में ऑर्गेनाइज होना भी एक बड़ी बात है। तो उसकी भी पहली कॉन्फ्रेंस में हमारे साथ जो है केंद्रीय मंत्री जी जुड़े हैं, तो ये एक बड़ी बात है। और उनका भी संबंध जो है MBM से है, जैसा कि मैंने बताया पूर्व में कि उनके पिताजी जो हैं उनसे भी मेरे को मिलने का सौभाग्य प्राप्त हुआ, और वो भी एलिमिनी हैं हमारे MBM के। तो ये एक हम कोइंसिडेंस कह सकते हैं, और ईश्वर करे कि इसी तरीके से अच्छी अच्छी और भी नई नई चीज़ें हों, और बड़े बड़े लोग जो हैं, सक्षम लोग हैं, वो हमसे जुड़ें। श्रीवास्तव साहब से तो मैं कोई मौका धन्यवाद का छोड़ना नहीं चाहता किसी भी मुकाम पे, चाहे अकेले मिलो चाहे सम्मिलित मिलो, क्योंकि ये उम्र से भी बड़े भाई हैं, और JN व्यास के रिलेशन देखें तो यूनिवर्सिटी भी हमारे बड़े भाई की तरह है। तो सर का हमेशा जो है एक छोटे भाई पर जैसे वृद्ध हस्त रहता है, एक आशीर्वाद रहता है, वो सर का बना हुआ है। और डेफिनेटली सर आपसे हमको बहुत उम्मीद है, और सर आश्चर्य की सबसे सरप्राइजिंग ये रहा कि सर ने ज्वाइन किया, और चौथे दिन जो है हमको एक अच्छी स्थिति में लाके, जैसे एक बड़े भाई का दायित्व होता है कि छोटे को अपने कदमों पे खड़े रहने का मौका प्रदान करें। तो मैं कोई भी मौका सर से इसमें नहीं छोड़ता। सर आपका बहुत बहुत धन्यवाद पुनः, और जब भी मिलूँगा जब आपको मैं धन्यवाद दूंगा। और आगे भी मतलब ये यहीं ख़त्म नहीं होता, जब तक मैं सर भी थोड़े समय के लिए है, 3 साल का टर्म है, मेरा भी टर्म है, हम सब चले जाएंगे। लेकिन MBM जैसे सर ने कहा, और मैं भी कहता हूँ कि MBM और JN व्यास यूनिवर्सिटी का रिश्ता जो है ये बहुत बॉन्डिंग बहुत लंबी है, मतलब जब तक दोनों का एग्जिस्टेंस है तब तक रहे, ये एक कोई व्यक्तियों से जुड़ी हुई चीज़ नहीं है। तो मैं उम्मीद करता हूँ कि दोनों विश्वविद्यालय मिलके डेफिनेटली और आगे बढ़ेंगे, और नई स्ट्रेंथ के साथ जो है एक जोधपुर में जो है एक नया इंटरनेशनल लेवल पर एक मुकाम हासिल करेंगे, ऐसी मैं उम्मीद करता हूँ। हमारे जो है रविंद्र जी से मैं सर से बात अभी कर ही रहा था, क्योंकि एक हमको एक टास्क मिल गया है, दैट इज़ MBM एंड DRDO, और उसमें JN व्यास भी पूर्ण रूप से जो है शामिल है। जो मंत्री महोदय ने जो एक टास्क दिया है, तो उस पर अभी मैं सर से बात भी कर रहा था। तो एक वी हैव डिसाइडेड टू मेक अ टीम डिफरेंट, क्योंकि इसमें हर सब पार्टिसिपेशन है। मे बी इट इंक्लूड्स माइनिंग, इट इंक्लूड्स कंप्यूटर, इट इंक्लूड्स इलेक्ट्रॉनिक्स, इट इंक्लूड्स केमिकल स्पेशली, और तो ये सब चीज़ों के समावेश है। और हमारे MBM में जो है ये इस विषय विशेषज्ञों की कोई कमी नहीं है, तो इन सब की एक टीम प्लस DRDO के जो विशेषज्ञ हैं, इनकी टीम मिला के सर ने और मैंने एक टारगेट फिक्स किया है कि बाय द एंड ऑफ अप्रैल डेफिनेटली हम एक अच्छा सा प्रपोजल इसके लिए बना के जो है भारत सरकार को जो सबमिट करेंगे, और बहुत जल्दी इससे एक फ्रूटफुल, जैसा मैंने सर से वादा भी किया था आप सब लोगों के विश्वास के ऊपर, कि हम बहुत जल्दी सर के ही हाथों से एक हम जो है देश को एक नई टेक्नोलॉजी समर्पित करेंगे, जो कि हम इस वेस्टर्न जोन के लिए, और हो सकता है ऐसी सिचुएशन दुनिया में बहुत जगह हो, तो वो एक इंटरनेशनल रिकग्निशन होगा हमारे जोधपुर का। मैं ना एमबीएम बोलता हूँ, ना जैन व्यास बोलता हूँ, ना मैं डीआरडीओ डिफेंस लैब बोलता हूँ। जोधपुर का एक जो है इंटरनेशनल स्तर पर अपने जो हेरिटेज को जो उन्होंने रखा है उस तरीके से एक गिफ्ट होगा, और बहुत जल्दी इसको एक फ्रूटफुल उसमें हम लोग इसका रिज़ल्ट ओरिएंटेड काम करेंगे, जैसा सरदे और हमने भी मिल के वादा भी करा है। तो एक बहुत जल्दी, मैं कल परसों में ही, आज तो सैटरडे हो गया, मंडे को ही एक टीम बना के और एक इंट्रैक्शन करके 30 अप्रैल से पहले एक टारगेट टाइम बाउंड काम करने का मैं विश्वास करता हूँ। तो उसमें एक हम ये प्रपोज़ल देंगे। और जैसा कि है डिसैलिनेशन और वाटर ट्रीटमेंट आज की तारीख में बहुत ही एक महत्वपूर्ण काम है, और मैं सोसाइटी को जो है हमारे चौरेसा साहब को जो प्रेसिडेंट हैं इसके, इनको भी धन्यवाद दूंगा, और सोसाइटी को पूर्ण रूप से धन्यवाद दूंगा कि उन्होंने एमबीएम को चुना ये इंटरनेशनल कॉन्फ्रेंस जॉइंटली करने के लिए। और सारस्वत साहब और इनकी टीम ने जो है बहुत मेहनत करके आज को इस मुकाम पे पहुंचाया। द डे इट वाज स्टार्टेड मैं भी यहीं था, तो सर मेरे पास आए थे, तो आई जस्ट सेड कि वी शुड गो अहेड फॉर दिस इंटरनेशनल कॉन्फ्रेंसेस लाइक दैट। और जैसे अभी श्रीवास्तव साहब ने एक इंटरनेशनल की बात करी, तो डेफिनेटली हम एक प्लान करते हैं, और क्यों नहीं हम इस प्रपोज़ल का जो हम बनाएंगे उसी का एक हिस्सा एक उसमें रखेंगे, सो दैट वी कैन गेट सपोर्ट फ्रॉम द गवर्नमेंट ऑल्सो। एक और एक वाटर रिसर्च सेंटर के तौर पे तो एक अच्छा सा प्रपोज़ल उसमें देंगे, और डेफिनेटली हम बहुत जल्द सर एक इंटरनेशनल कॉन्फ्रेंस जो आपने जिस सपना देखा है उसको पूर्ण रूप देने की पूरी कोशिश करेंगे। और डेफिनेटली उसमें मूल जो है सहयोग जो है हमारे सारस्वत साहब का ही रहेगा। तो सर ने वापस नए सिरे से इसको एकदम नए जोश के साथ, क्योंकि यह आगाज़ तो बहुत अच्छा हुआ है और कई दूसरे बहुत अच्छे आगाज़ भी करने हैं, और केमिकल इंजीनियरिंग डिपार्टमेंट डेफिनेटली इसमें लीड लेके आगे आएगा, ऐसा मैं विश्वास करता हूँ। तो बहुत अच्छा टॉपिक चुना इसके लिए जो है, और बहुत अच्छा ऑर्गेनाइजेशन किया है, तो इसके लिए मैं सारस्वत साहब और इनकी पूरी टीम को जो इसमें जुड़े हैं सबको बहुत बहुत बधाई देता हूँ। और उम्मीद करता हूँ कि जैसे मैंने अपनी उम्मीदें जागी रखी हैं वैसे बहुत जल्दी एक नया प्रपोज़ल जो है मेरे पास आए और हम उस पर आगे बढ़ना शुरू करें, ऐसी मैं उम्मीद करता हूँ। क्योंकि वो एक कहावत भी है कि चैरिटी बिगिंस एट होम, तो ये सब इसको हम माने कि ये सब कार्यक्रम हमारे यहाँ से हम शुरू करें तो एक एग्ज़ाम्पल होगा। और इस जो मैंने बताया एक चैरिटी बिगिंस एट होम, तो हम हमारे घर से ही ये चीज़ की शुरुआत करेंगे तभी हम इसको आगे ले जाएंगे। और मैं जो है ये सब बात यहाँ इसलिए बोल पा रहा हूँ क्योंकि मेरे पास एमबीएम टीम जो हम जिसको मैं बोलता हूँ शुरू से, उसका बहुत बड़ा सपोर्ट है, और हर आदमी जो है काम करने का बहुत बड़ा जज्बा रखता है, और डेफिनेटली इन सब के सहयोग से हम एमबीएम को भी एक नई ऊंचाइयों पर ले जाएंगे, और सबका सपोर्ट एक बहुत ज़रूरी है। और इसके साथ ही सब मिलके हम लोग जो है एमबीएम या हम जैन व्यास कहें या हम इनफैक्ट हम कहें जोधपुर, तो ज़्यादा रिलेवेंट होगा। और एक मैं इस अच्छे कार्यक्रम के लिए ऑर्गेनाइजर्स को और एसोसिएशन को बधाई देता हूं, और उम्मीद करता हूं कि डेफिनेटली इसकी जो रिकमेंडेशंस निकलेगी वो आगे हमारा आने वाला जो प्रपोज़ल हम तैयार कर रहे हैं उसके लिए भी फ्रूटफुल रहेंगी, और उसको मद्देनज़र रखते हुए भी कुछ डिस्कशंस अगर कर सकें, क्योंकि दिस इज़ अ न्यू आइडिया विच हैज़ बीन फ्लोटेड बाय आवर ऑनरेबल मिनिस्टर। तो मैं ऑर्गेनाइजर से एक निवेदन करूंगा कि कहीं बीच में टाइम निकाल के एक छोटा सा सेशन इसके लिए भी अगर रख लें, सो दैट विल बी अ वेरी ग्रेट हेल्प फॉर मेकिंग द प्रपोजल्स एंड कमिंग आउट विद डिफरेंट आइडियाज़। हालांकि पार्टिसिपेंट्स के लिए थोड़ी सी एक एक्सरसाइज बढ़ जाएगी, बट डेफिनेटली आज का दिन है, आज की रात बाकी है, तो थोड़ा सा उस पर स्टडी करके कल अगर रखें और उसमें होगा तो मेरे को अगर बीच में अगर मौका मिला तो डेफिनेटली आई वुड लाइक टू ज्वाइन दैट वन, सो दैट वी कैन हैव अ आइडिया ऑन दैट। तो पुनः एक बार सबको बहुत बहुत बधाई। आप सब लोग जो ऑडियंस हमारे सामने हैं और पार्टिसिपेंट जो इंटरनेशनली जुड़े हुए हैं, आई वुड लाइक टू वेलकम ऑन बिहाफ ऑफ एमबीएम यूनिवर्सिटी once again, and hopefully I wish to invite all people who are joining online. Maybe next time we may go for offline, and people around the world may come to Jodhpur and visit this beautiful place and upcoming university, we can say, and there is MBM University. Thank you very much.
Thank you, sir, for this insightful and motivating address. I believe with your able guidance and support, we'll be able to fulfill all your expectations. Moving ahead with today's program, like we are reaching towards the end of this inaugural session, and in that same sequence, I would like to first invite Professor Milind Sharma sir to present a memento to our guest of honor, Professor K.L. Srivastav, Vice Chancellor, Janaran Vyas University. Thank you, sir. Next, I would like to invite Dr. Anil Vyas, Professor, Associate Professor, Chemical Engineering Department, to present a memento to Shri Ravindra Kumar Ji, Director, Defence Laboratory, Jodhpur. Please, sir. Thank you, sir. Next, I would like to invite Dr. D.K. Tripathi, Scientist, Defence Lab, Jodhpur, to present a memento to Professor Ajay Kumar Sharma, Vice Chancellor, MBM University. Thank you, sir. Next, I would like to invite Mr. Ketan Jangid, Assistant Professor, Chemical Engineering Department, to present a memento to Professor S.P. Chaurasia, President, Indian Desalination Association. Next, I would like to invite Dr. Imarti Kumari to present a memento to our Dean, Professor Sunil Sharma, sir. Sir. Thank you, ma'am. At last, I would like to invite Mr. Dipesh Patidarji, Scientist, Defence Laboratory, Jodhpur, to please present a vote of thanks for this evening.
नमस्कार, मुझे ये जिम्मेदारी दी गई है वोट ऑफ थैंक्स देने की। सर्वप्रथम माननीय आदरणीय जल शक्ति मंत्री श्री गजेंद्र सिंह शेखावत साहब, प्रोफेसर के.एल. श्रीवास्तव साहब, वाइस चांसलर जैन एंड व्यास यूनिवर्सिटी, प्रोफेसर अजय कुमार शर्मा, वाइस चांसलर एमबीएम यूनिवर्सिटी, प्रोफेसर एस.पी. चौरसिया, प्रेसिडेंट इंडियन डिसैलिनेशन एसोसिएशन, श्री रविंद्र कुमार सर, आउटस्टैंडिंग साइंटिस्ट एंड डायरेक्टर डिफेंस लेबोरेटरी DRDO, प्रोफेसर सुनील शर्मा सर, डीन MBM इंजीनियरिंग कॉलेज, प्रोफेसर V.K. श्रीवास्तव सर, ऑनररी ट्रेजरर इंडियन डिसैलिनेशन एसोसिएशन, and Professor Sushil Saraswat, Organizing Secretary of InDACON, all participants, delegates, industry delegates, media, administration, all students, ladies and gentlemen, warm welcome to you all. It is my proud privilege to present vote of thanks on this inaugural ceremony on behalf of the organizing committee. This ceremony on the International Conference on Desalination and Water Treatment. At the outset, on behalf of the organizing committee, I would like to express my sincere gratitude to Honorable Jal Shakti Mantri, Government of India, Gajendra Singh Shekhawat sir, for sparing his valuable time and blessing this conference by his kind presence and motivating us and sharing the large information and the current status of problems that the world is facing, and particularly India, on water related issues. His motivating words will be a driving force for us, and his thoughts that every drop of water recycled is in fact a drop of water generated. And his new concept that I could learn from him was that the water can also be exported by the water rich countries, are really very encouraging. Thank you very much, sir. At this moment, I would also like to submit my gratitude to Professor K.L. Srivastav, sir, Vice Chancellor, Jain and Vyas University, for gracing this occasion and providing his support in organizing this event. And his concept of the Luni River, Sambar Lake, and how these names came into existence, the salt pan at Pachpadra, these were the new things we could learn from him. On behalf of the committee, I would also like to submit our sincere thanks to Professor Ajay Sharma sir, Vice Chancellor, MBM University, for providing his continuous support and motivation in organizing this conference. Thank you very much, sir. We are highly motivated by your energetic and initiatives for finding water solutions for the Western Rajasthan, sir. Professor S.P. Chaurasia, sir, President Indian InDA, has been the driving force behind this idea of organizing an international conference. We are highly thankful to you, sir. And your thoughts on Rahmat Pani Rakhiye, they were, I never thought the meaning of this golden words, that water should be treated like our self-respect. Shri Ravindra Kumar sir, outstanding scientist and director, Defence Laboratory, Jodhpur, has always been ready to provide all possible help and guidance. Sir, you have made all efforts to ensure support from the DRDO headquarters. We are highly obliged for the same. And your thoughts on water everywhere, not a drop to drink, and how you compared the Jal Shakti Mantralaya is like Bhagirathi to India, these were very golden words that we will be treasuring, sir. Professor Sunil Sharma, Dean MBM Engineering College, and Professor Vinay Srivastava, Honorary Treasurer InDA, have been guiding us at the ground level, execution work, and always motivating us. We express our sincere thanks to you, sir. And your thoughts on Jal Grahan, Jal Shuddhi were a new angle of viewing the water and its problems and its solutions. I would like to congratulate V.K. Srivastava sir for his lifetime work and the lifetime achievements. I would like to place on record that this event has been possible with the financial support from MBM University, TEQIP3, InDA and DRDO. We are grateful to the local organizing committee and advisory committee for their constant guidance and support. The support provided by Messrs. Crest Water, Messrs. Aarti Industries is thankfully acknowledged. On behalf of the organizing committee, I express sincere thanks to all the participants and delegates, without whose participation and support this event would not have been possible. I express sincere thanks to our keynote speakers, also some from abroad, who have taken out time and are participating at the late night hours of their local time. Thank you, sirs. We are very thankful to the media reps for giving such a wide publicity to this event, and to the local administration, police, for providing their excellent support. Professor Sushil Saraswat, Organizing Secretary of InDACON, and Dr. Dipaloy Datta, Honorary Secretary InDA, have been working day and night in ensuring that everything is on track and on time. I thankfully acknowledge their wholehearted support. I would like to express my sincere gratitude to all the organizing team members from MBM, InDA, JNVU and DLJ, all students and their teams for their all-out support and hard work. At last, I will conclude with this few words कि जल में कुंभ और कुंभ में जल है, बाहर भीतर पानी, फूटा कुंभ जल जल ही समाया, यह तत् कहाऊ ज्ञानी। जितना मैंने इसको समझा है कि जिस तरह से हम कहते हैं कि आत्मा और ईश्वर एक होते हैं, किसी तरह से जुड़े होते हैं, इसी तरह जल जो है हमारे शरीर के अंदर भी उतना ही जल है जितना जल इस पृथ्वी पर है। तो एक प्रकार से मटेरियलिस्टिक एंगल से हम देखें तो जल जो है, हम जल से पूरी तरह से जुड़े हुए हैं। अंत में मैं ये आशा करूँगा कि यह कॉन्फ्रेंस जो है ग्रैंड सक्सेस हो और इसमें सभी पार्टिसिपेंट्स, डेलीगेट्स का पार्टिसिपेशन रियली फ्रूटफुल हो। थैंक यू। जय हिंद, जय भारत।
Thank you, sir. Towards the closing of this inaugural session, I would like to invite a team of students to sing the national anthem. I would like to request all the audience members to please stand up in the respect of our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा। तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाए तव जय गाथा। जन गण मंगल दायक जय हे भारत भाग्य विधाता। जय हे, जय हे, जय हे, जय 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 हे।
I would like to request all the guests present on the dais to please take their seats. Thank you. All our guests are requested to please assemble in the hall outside for a high tea. And a good evening to Dr. Sanjay Tiwari, sir. Continuing with our today's program, next in line we have a keynote address from Dr. Sanjay Tiwari. I'll present a brief bio of Dr. Sanjay Tiwari and then we'll proceed with the lecture. Dr. Sanjay Tiwari is currently a faculty in the Civil Architecture and Environmental Engineering Department at Missouri University of Science and Technology, USA. He earned a BE in Civil Engineering from the National Institute of Technology, Surat, and MTech in Chemical Engineering from IIT Roorkee, India. He did his PhD in Environmental Engineering from Texas A&M University. Most of Dr. Tiwari's teaching and research efforts are focused on environmental engineering and water quality related challenges. Specifically, his focus is on drinking water quality and issues related to the treatment of wastewater. His recent efforts have been focused on a variety of separation processes such as physical, chemical, biological, and electrochemical. However, currently he is more focused on capacitive deionization, electrokinetic, and electrocoagulation for improving water quality and better treatment of wastewater from industrial as well as municipal sources. In addition, his research focuses on sustainability and resiliency of various systems around us. Recently funded projects have been in the area of pollution prevention and sustainability, application of geographic information systems to environment management, and resiliency of infrastructure. Dr. Tiwari is actively involved in multiple engineering societies such as ASCE, ASEE, AEESP, and ACS. In addition, Dr. Tiwari has a strong interest in engineering education related activities. He enjoys teaching various core classes and mentoring students and student engineering societies. With this, I would like to invite Dr. Sanjay Tiwari sir to please bless us with a knowledgeable address. Welcome, sir.
For such a wonderful introduction, can you guys hear me?
Yes, you are audible, sir.
Okay, thank you. First of all, I would like to take this moment and congratulate MBM Engineering College and Indian Desalination Association as well as DRDO for putting together such a wonderful conference. And I see there are some really great speakers listed over there. So thank you for putting together such a wonderful conference. Today, in my presentation, I will try to touch some aspects of desalination. Specifically, my focus would be on capacitive deionization and how it is being applied towards desalination and water purification. I am associated with Missouri State University as well as Missouri S&T. I have a dual appointment. In addition to that, I do some consultancy work which keeps me busy outside academia. So this is my contact information, just in case anybody would like to contact me for any kind of collaboration, please feel free to email me. I would be more than happy to respond. Here are some of the basic fundamental questions that I'm going to ask in my presentation. And I'm going to start with the very basic question. What is desalination and what is deionization? The distinction, we need to separate them one from another, but they are basically, one is subset of another. So desalination is subset of deionization, because in desalination, we are specifically talking about salt to be removed from the water. In deionization, we are trying to remove every ion or all kinds of ions. We are not favoring salt ions versus non-salt ions. So CDI, which is capacitive deionization technology, is for all. It's not going to focus only on salt. Any kind of ion which is in water will be removed in this specific process. Now, what is it, how we apply it, and what is carbon aerosol and how they are being used in this technology, we will explore them in next few slides. So first of all, the general desalination approaches, which pretty much every one of you know over there. So I'm not going to spend too much time on it, but you can classify this into three main categories. One is membrane-based category, which is the most popular at commercial level. So reverse osmosis is another example of this. It is being used pretty much at user's end, which is under the sink or reverse osmosis equipment which are sold to household, versus larger plants which are in Singapore, Australia, Middle East, and even in US. So just to give you an idea, I'm going to be very, very short here. We have a semi-permeable membrane over here, and that membrane will have a small enough hole for it to block the bigger ions. Water molecules are able to pass through, but for that to happen, we have to apply high pressure. And the picture on the right over here illustrates exactly the same thing. The villain in this role, in this movie, is the high consumption of electricity, high pressure requirement, and the production of brine, which is in some cases could be up to 10 to 20, 30, 40%, depending how RO is being done. So those are the bad actors over here. You will be able to get high quality water, and that's a big plus. These are the RO racks that are being used. Each big PVC pipe you would be able to see. And this is most of the time highly computerized, automated. Couple of people could operate this plant for 40 million gallons per day, 50 million gallons per day for the whole city. Because the moment the membrane is saturated or not able to filter the water as much, the sensors, actuators come online, and they start backwashing it, clean it, process it, and bring it online. So this is basically you can control the whole plant with following a touchpad. So this it's highly commercialized, so not going to talk about that. Again, each option has some bad actors. In heat-based desalination, most of the time you apply heat, whether it's solar heat or heat by burning the fuel, and then you can do the multi-stage flash or whatever the process you want to do. Basically, you are distilling the water, which will leave the salt behind. Again, and high energy requirement is a big issue, and efficiency is another issue. And those are some of the challenges. If you live in a country which doesn't produce enough fossil fuel, then this option may not be good for you. So it has other options. So in both options, these are the two main publicly adopted options. High cost, high energy requirement, source water quality dependence, and the product water relationship is critical. Membrane fouling issues are there, extensive setup, and all, specifically in case of RO, the concentrate disposal. In India, I'm not sure because I have not done the work in India at that time. In US and many European countries, you need to dispose the brine in a very specific way. You just cannot dump it in the river or in sewers. You could do it in sewers if you get a specific permit from municipality. So concentrate disposal is a big challenge at commercial level. Now, since these problems are there, people have explored third option, which is electrical or capacitive-based desalination. In capacitive deionization, and I'm just going to give you an idea. This is, just imagine a capacitor. Bring the capacitor electrodes very close to each other, a couple of millimeters apart, just to give you an idea how close they are, and let any water which has any kind of ions pass through it. For example, sodium chloride, and apply DC voltage across these electrodes. What would happen, these ions will go to on oppositely charged electrode. For example, over here, feed water is going left to right, and you can see the ions, positively charged ions, shown here in yellow colors are going to negative electrode, and negative ions are going to positive electrode. So water is coming towards the out on the right hand side, which is relatively ion free. So that's the basic, simple, basic concept of that. So sometimes even the basic concept applied in a right manner could give us really good results. So this is the same concept. DC voltage is being applied, and just to give you an idea, the DC voltage quantity is very, very low. Sometimes to the order of a volt or two. 1.5 is mostly used, 1.4 depending what is being removed from the water. And the current also is very low. So about 1 ampere, that kind of thing. Sometimes these metal electrodes are coated with some kind of additional electrode, which is going to be highly electrically conductive and going to be highly porous, so that it acts like a sponge, but it's just like activated carbon surface adsorption phenomena. It increases the capacity of the electrode. So why do we need it? A low energy requirement. We don't use chemicals for fouling on all that issue. That doesn't happen. And if we can recharge the saturated electrodes, it would give us a very, very economical option. So that's why no bad actors, all the good actors, good story. That's why people have started exploring this option. So since we are talking about electrodes, we need to understand what kind of electrodes have been used in the past. Carbon felt, activity charcoal, they use that also. And then they went with hybrid electrode. But my research and my work has been on carbon aerogel. Carbon aerogel is, just to give you an idea, I'll give you that. These are traditional carbon electrodes. These pictures are not to the scale, so don't think that this spring-like nanotube particle is same as big as this paper electrode, a carbon paper electrode. But just to give you an idea, the different kind of traditional electrodes that have been used in the past. Now, carbon aerogel is a man-made element, very, very light. It has high porosity and it has very high strength as well as electrical conductivity. Electrical conductivity and high surface area, those are the two qualities that make it perfect for capacitive deionization. Now, how do we make this thing? We take precursors, which could be formaldehyde, resorcinol solution. We do hydrolysis and condensation followed by gelling, and we get a wet gel which has a large interlinked carbon structure, and this wet gel is dried supercritically, and then carbonization is done. Basically, we burn it and we are left with big voids within that carbon structure. So that's how we get really high porosity for this thing. Now, if you do the experiment using this way, so what happens, this is the clear data that you will see. The water salt content is coming from the left to right. Electrodes are oppositely charged, and these ions will be removed. You can see the positive electrodes going to the negatively charged electrode. This is the conductivity. So if you have a conductivity meter and you are constantly checking the conductivity of the solution over a period of time, and in this case, the experiment was done with multi-pass, meaning the water was constantly coming out, we were taking back, and we were recirculating back as inlet, and once it comes out, we put it back again. So you can see that with time, the conductivity started going down and it became a flat line. That means the electrode was saturated. If in the old time, people just used to replace electrodes, and that was expensive at commercial level. Now, you can switch the polarity. And if you switch the polarity, this electrode was negative, but now we switch the polarity, now it's positive. It will repel all those ions back into the system, and you can flush it out. Now the challenge is, if high porosity electrodes are there, then these ions are not easy to push out, not easy to flush out, and therefore different studies are being done. So you can see that water with almost zero conductivity was used, and within a minute or two almost all the ions were flushed out. So the relative quantity of the water that was used to flush is small. This is a setup that was used in the lab. You can see that this is a single pass experiment, meaning water passes the cell only once. In our experiment, we had another pump over there which was carrying the water back to the cell, and it was rotating through the cell. Now, you could use this cell in a series mode, one after another. And depending 50 cells, 100 cells, you could get ultra pure water for medicinal research. We have done that. National lab over here in the US, National Livermore Lab, they have done it. Early research was done over there. So this is how it's done. This is actually a setup that was used by my PhD student. He put together the CDI cell over here. You can see the voltage and current over there, and this is conductivity meter. Very simple setup, doesn't require much, but you can get great things done over there. So some of the properties that we focused on was specific surface area, how the specific surface area is going to impact the performance, pore size distribution of the carbon aerogel, because we can manipulate the carbon aerogel during the hydrolysis, supercritical drying and carbonization process, and the conductivity properties, how stable the electrode is, how many times could you use it. Could you use it for 30 days non-stop? Could you use it for 100 cycles? Depending what was the study, and the cost. So everything pretty much has been done. These days, there are about 10, not 10, sorry, not bad, about 50 to 100 papers are coming out every month on capacitive deionization. So there is a lot of work that is being done. And most of that work is on modifying the carbon electrode properties. These are the SEM pictures of the material that we use at 10, 100 and 1,000 times, just to give you an idea. Lesson learned. We made a mistake. We were using copper. Copper was in contact with water and current and our carbon aerogel, and something went wrong and water started turning blue, brown. We didn't know what it was, and we didn't know why it was happening. But we had to do XRF, NMR to try to figure out what it was. We couldn't determine exactly what it was, but once we figured out that it was increasing the conductivity of our water, we fixed the issue. These are the coatings that we did. This is over here without coating. This is acid treatment. We did a nitric acid treatment of the carbon aerogel. And then we also used a very, very thin layer of gold to increase the conductivity of the electrode on the carbon aerogel to see how it's going to behave. Obviously, gold is highly electrical conductive, so it gave us better specific capacity in terms of the removal of salt. We did some cyclic voltammetry tests to figure out the specific capacitance, and you could see that over here the acid treatment reduced the salt removal capacity of the electrode, while the gold was able to gain better specific capacitance, which resulted in higher removal of salt. We also tried different combinations of this is the symmetrical combination without any treatment, and same we did the symmetrical combination, meaning the both electrode and cathode were same material. In this time it was acid treatment, and we did the same combination for the gold, and then we did asymmetric combination. One experiment or a series of experiments were done using cathode as gold plated, and then another series of experiments were done as anode gold plated. We wanted to explore what is going to happen, why it should happen. I'll share the results later on. We did some general studies. Applied voltage gave us the higher the voltage, the better the capacity was removed, salt removal capacity. But more than 1.4, our results started going crazy because oxidation potential and reduction potential of the ions was getting impacted. So we stopped. We didn't go beyond 1.2 in many cases. In terms of initial concentration that was used, higher concentration solutions gave us more capacity. Same thing was temperature. However, the flow rate didn't give us a meaningful data. There was not a certain trend that we could say confidently. Now, in terms of symmetric and asymmetric information, nitric acid reduced the capacity. It didn't give us good results. However, when we used the gold-plated symmetry versus asymmetrical, the results were totally different. Both electrodes being gold, we thought should give us the highest removal capacity. It didn't. We got the highest removal capacity in terms of asymmetrical combination. We are still investigating that. We are doing more research. But that was surprising to us. Just to give you an idea, there are different kind of polymers that are being used. There are different kind of nanoparticles embedded in the carbon aerogel that are being used right now. So this technology is being used right now in many of the battery recycling plants that are there in India as well as in US. So mostly it is going to work on metals. Mostly it's going to work for desalination, depending what you are trying to treat. However, it is more effective for saline water versus and less effective versus seawater. The salt removal capacity in case of seawater desalination was not great, but that was like 4 years ago when my first PhD student completed that research. So we are still trying to do more experiment. Let me see what else. So in the end, since I'm out of time, I would like to acknowledge my PhD advisor. He is retired now. He was at Texas A&M University, and my own PhD student, Ashik Ahmed. He did
studies. Before we proceed with the lecture, I would like a brief bio of Professor Pant. Professor Pant is currently the Petrotech VP Chair Professor and Dean Faculty at IIT Delhi. He also serves as adjunct faculty at University of Saskatchewan in Canada, joint faculty at CRDT IIT Delhi, and honorary faculty.
Good afternoon. Am I audible? I think there is some connectivity issue at the organizer.
Sir, you are audible to us, sir.
Oh, very good.
Your screen, please.
Yeah. So very good afternoon from India, and thank you for introducing me in an extensive way. First of all, I would like to thank. So I have taken the topic something on related to the removal of this phenol, right, which is one of the major challenge, not only from this industrial effluent, but also from the domestic personal care products. So you see the scenario, you see several red lights here, right, red area, the areas which are highlighted here. And most of the time we talk about the clean water, right, drinking water, but the data shows that, right, only 1% is readily available water for drinking purpose. Second side, right, the contaminations which are coming, right, the organic compound. There are several, right, other kinds of where we are talking about the personal care product. Each is the kind of emerging contaminants, right? And we need to look at the treatment, several microorganisms, inorganic chemicals. So when you look at the treatment approaches, there are a lot of challenges with each kind of water treatment. So the overall scene, when you see, right, the contaminants of engineering concerns, right, that is when we talk about the emerging concerns, right, in terms of pharmaceuticals and personal care products. How we are dealing with these kind of, right, domestic household, industrial water. So most of the time these are not, right, it is the economical approach, right. But the only thing when you see these kind of different adjorbents, right, whether these are conventional or non-conventional, right, they have the several issues. issues in terms of like high surface area, porosity, right, and then low cost and the sources of this kind of material. So what kind of functional groups should be added? So those things are very important when you look at the treatment of whether inorganic compounds as well as when you look at the compounds like phenolic compounds. When you look at the treatment for the organic compound, the challenges are much more severe, right? So several approaches have been made, right, in order to increase, whether it can be in the form of aerogels or it can be in the form of nanotubes, nanowires. The idea is that you have to look at in terms of the control of the, right, the fundamentals of the mass transfer resistance. You have to increase the surface area per unit volume. You have to generate the porosity within the system. And that's what we are thinking in terms of the kind of the mechanical and thermal stability also. So all these things are very important when we look at in terms of synthesis of these kind of adsorbents. Having said this, what we have done at our lab, we have selected some kind of agro-based residue, something like the materials which are available at a cheaper rate. The important thing when you see you have to find out the adsorption capacity. So there is a kind of a conjugate bonding. So these are the kind of phenolic compounds, how they interact, right, with respect to pi-pi bonding or right, a kind of hydrogen bonding. So that's also one needs to understand, and accordingly the functional groups should be introduced on the surface. So that kind of structures when you see, right, which Professor Tiwari was also discussing, that the functionalization of these kind of graphene material, whether you add a kind of metals like gold, silver, copper, right, or at the same time you look at the improvement in the properties of these kind of adsorbent, like reduced graphene oxides, right? So that those are also important. So what we did, right, we tried to work with these kind of different carbon materials, right, and looked at in terms of the crystallization, their physicochemical properties, their morphological properties, in order to understand their overall impact on the phenol and similar other kind of personal care product adsorption. So this work briefly just gives a kind of approach. What we did, we have taken a cow dung, we have taken agricultural residue and converted it into form of the carbon materials, right? That can be just one of the approaches, just by you give the heat treatment, pyrolyze it, or you can have some treatment with the concentrated acid. So those are the different approaches which can be used. The idea is to develop these kind of aerogel. So whether you can have a supercritical drying, when you convert it into this kind of gel structure, you can have a kind of full gel approach. And finally, you can have a freeze drying versus the supercritical drying. So both methods have some advantage versus disadvantage. But overall, what we are trying to look at that kind of the conjugate bondings, right? Where hydrogen bonding interactions of these kind of compounds versus pi-pi bonding. So that is where we were focusing on to understand the chemistry along with some kind of the simulation. So we are doing some kind of DFT simulations also for this kind of metal and the organic adsorbent interaction with each kind of different kind of organic compound. So we synthesize, we characterize it by different methods which are routine as well as the to understand the in-depth analysis. So we do the different kind of characterization depending upon the need, and finally study the adsorption and then optimize the parameter and kinetics. And then, of course, it's the final approach is the commercialization, the scale-up approach is still under consideration for these kind of adsorbents. So this is one of the approach, but I said that a cow dung, which is easily available, a low-cost material, and what is the hypothesis? So I'm not going in depth, but mainly it depends on the content of the cellulose, hemicellulose, and some other properties of the materials which are present in the cow dung, right? So we used a kind of this kind and converted into activated carbon by carbonization. We have dried it and used the raw material for the production of carbon using the carbonization method. And then we just give a treatment of this with the potassium hydroxide pellets, right, with the carbon with some ratio 2:1, and finally put it under freeze drying to make a kind of the hybrid hydrogel, and finally it was converted to aerogel. So these are a kind of different adsorbent materials which were treated and then finally characterized. So this is the kind of structure with respect to transmission electron micrograph, the XRD, and several other which are not shown to develop the functional groups like proton NMRs. These were used, and BTTPD, these are the couple of other studies, TG and thermal stability, and the surface area is around 840 meters per gram for this kind of adsorbent material. So at the same time, simultaneously, we were doing the design of experiments for optimization of the experimental conditions. So we took the wide range of pH. We just selected the time, the temperature, and adsorbent dose, and the concentration in total. By doing this response surface methodology analysis, we try to understand that what would be the optimum conditions at which this can be studied. So what we observed that the time, right, is one of the important parameters when you look at the pH and time, adsorbent dose versus time. So these are the contours which were observed, and the initial concentration and pH. And these are very important in order which can affect the performance of the sorbent. So that is what we observed, around 7 pH is good for the treatment of the phenol. Most of the time phenol is acidic in nature, and but at pH 7 the removal has been observed better. So these are a couple of studies for adsorption which are traditional studies. I'm not going in detail, but if you look at the comparative studies, we have reached to a level of 500 milligram per gram, that is the adsorption capacity, which is quite high compared to the literature, and the different kind of isotopes were tested experimentally, and effect of time on steam. So within 200 minutes, right, most of the phenol could be removed, and the concentration levels were much below than what the expected for the as per the WHO norms. So we also did the thermodynamic analysis in order to understand the kinetics and thermodynamic equilibrium. So this process is mainly the adsorption, mainly the exothermic process, and we tried to evaluate these parameters for the scale up, and these are the kind of adsorption parameters which says that it is favorable, right? And the negative value just indicate that thermodynamic study that these are the favorable adsorptions. The second approach which we did is a kind of another bio-based sorbent. So the same carbon can also be used. The carbon which have been developed from this bio-based sorbent, this was used. And over that with a concept of, because the phenolic compounds are of wide range, and here we are looking at kind of personal care products which have the lot of, right, these kind of parabens, those kind of compounds, and difficult to remove by the ordinary activated charcoal. So we tried to impregnate. So this is a part of the work with the University of Queensland, Australia, a joint PhD research work, because we have a joint degree proposal here in IIT Delhi. So we impregnated silver nanoparticles and then optimized and characterized. Again, the question is that how to develop these silver nanoparticles. So we used a different approaches for synthesizing the silver nanoparticles. And then the idea was that their treatment for the cosmetic pollutants degradation. So instead of adsorbent, it is a kind of conversion, chemical conversion under these kind of the silver nanoparticles on the carbon nano-based materials, and this was used for this treatment process. So this is the approach. So we have taken different kind of citrus fruits here, and then you see that this is the extract of the citrus fruit. That is you can take orange or all kind of peels of this, which is a waste agricultural residue, and treat it with silver nitrate, and you get the right kind of silver nanoparticles here. And this is the very unique process which is rapid, single step, environment friendly, and also cost effective. So this is a kind of biological extract along with metal and salt, and this is a kind of nanoparticle colloidal salt. And then we reduce it biologically, and you can see that this is a kind of a kind of hypothetical approach that how do we get the capped stable silver nanoparticles on this kind of it. But there are a lot of intermediate steps in order to control the process. Otherwise, this kind of method will not be successful. So you have to control the pH, you have to control the condition, and then only this kind of stable structure could be obtained. So again, with this, we did the experiments, and we observed that using some kind of the approaches like artificial neural network, responsive metrology. So different approaches we tried for the optimization for the parameters. So you see that we defined the input parameters, then we designed, we conducted the experiments, we diagnosed, and finally we observed the results which were effective, and these are reported here. But I'm not going in depth. I would like to show you just the outcome of this research, the effect of process variables when you see the time, temperature, and the concentration of silver nanoparticles which have been doped on the surface. Those are very important in terms of treatment of these kind of personal care products. That's a kind of chemical reaction which is not just an adsorbent but a chemical treatment. So you see that this is a kind of reaction with this kind of nitrophenolic compounds, right? They react under the certain conditions, and they convert in the presence of silver nanoparticles. They convert into a second type of this kind of product. You can see how the conversion is taking place. So this is where we are talking when you have the nitrophenols and sodium borohydrate in the presence of silver nanoparticles. So you can get it converted. So this is where the product which have been transferred from one form to another form. So this is a conversion. Similarly, the absorbance also, you can see the concentration of the product, which simply says that during this condition, this can be converted easily into a product which can be removed faster, right? So this over silver nanoparticle, this can be converted to 4 aminophenols. So that is where this nitrophenols can be converted to 4 aminophenols, where the absorption of this could be easier compared to the 4 nitrophenols. Then we did the kinetics also for this purpose. So this is the pseudo first order kinetics, and that we evaluated the model parameters for this removal of this nitrophenols, which is mainly a personal care product. So this is what a kind of photocatalytic degradation of these all these the personal care product, which are mainly again a phenolic compounds and parabens by using this silver nanoparticles. So that is where the finally when you see that in the presence of sunlight, there's all this AP what I was talking, it converts into different kind of the product. So that finally you have the this CO2 and water right under this presence of the sunlight. So we did the experiments under different conditions of the UV visible lights and visible UV, just to look at the photocatalytic effect. Not only we did that, but also we used the reduced graphene oxide along with different concentrations of the silver. So without silver versus silver, you can see here that under controlled condition, this concentration could be reduced to a much below, right? That is a kind of the concentration of this blue line. So the significant reduction in the concentration of this kind of phenolic products was obtained. So we did the study at different conditions for this removal of phenolic compounds, and these you see the last one under UV visible light, the results are much more better compared to the rest of these treatment processes, where almost the phenolic concentration could reach to the standard limits, which is permissible as per the standards. So we try to understand again the mechanism of the reduced graphene oxide with the silver nanoparticle, which are given, and we are calling it a green reduction approach. So that is where we see that how the silver nanoparticles, when treated with this graphene graphite is treated with under sulfuric acid, sodium nitrate, different kind of these oxidizing agents. So this is a structure of graphene oxide, and finally when we treat it under heat, we heat it, you get this brown graphene oxide. And now over this, then we give the treatment with the silver nanoparticle. So this is the doping of the silver nanoparticles over this graphene structure, which have been found effective for the treatment of this phenolic compound. You see the surface area change significantly when you see what we call the pristine graphene has a surface area of 2600 meters square per gram by this method compared to 890 meters square per gram, which is very high in terms of the treatment for this. Also, this structure has shown a hydrophilic behavior when compared to the reduced graphene oxide. So we observed that this a small concentration of silver nanoparticles, right, could be helpful for the treatment of this. That is the final structure of graphene oxide, which is converted to reduced graphene oxide and silver nanoparticles of black in color. So that's the final product with high surface area, which was tested. So just to summarize that the activated carbon derived cow dung is a low cost material. Right, but if you look at for treatment of this parachlorophenols or parabens type of complicated personal care product which contain these kind of phenolic compounds also, right? So then we need to look at the improved surface area and property of this. So we converted this carbon into a kind of hybrid aerogel by using the application of freeze drying, and then compared with the commercial activated carbon. So you see that these kind of materials have much higher activity compared to what are available in the commercial results. So that's a lab scale study, and we are just collaborating with several other wastewater treatment industries for this commercialization. So the overall summary of this work, when you see that, right, the optimized condition, we could work to a level of, right, the phenol treatment which is comparable with the standards of the WHO standards for the drinking water for this purpose. And phenol, which is a major component contaminant which is from the petrochemical industry as well as from the domestic wastewater, so from the due to the personal care products. So this could be used as a source of material for this. So the aerosols which are generally used have high surface area, and they acted like a super adsorbent and found effective for the treatment. So this is what the overall, you see the kind of aerosols, right, which has a density of 0.02 gram per centimeter cube and density around 90, porosity around 90%, could be successfully used for the treatment of these kind of compounds. after the doping of these kind of silver nanoparticles. And this aerogel can be made from the plastic waste also. We are working on this, the plastic based aerosols also, which can be used as an adsorbent for treatment of the wastewater. So just at the end, I conclude and just acknowledge my research group and Department of Science and Technology Wastewater Treatment Division for supporting this. I also acknowledge the University of Queensland for jointly supervising the PhD student. Thank you very much. If you have any question, then I'd be happy to answer.
Thank you, sir. Thank you for this knowledgeable lecture. Any questions from the audience? So I think there are no questions at the moment.
Okay, thank you. If there are any questions, please mail me at kkpanth@chemical.iitt.ac.in. I'd be happy to answer.
Thank you, sir. Thank you very much, sir.
Thank you very much.
Moving ahead with today's program, next we have a lecture from Dr. Suresh Patel and Mr. Anders Ui from Crest Water Private Limited. I'll give a brief bio introduction to our next speakers before we start the lecture. Dr. Suresh Patel is a surface and physical chemist by training and has more than 30 years of management experience in the water industry. Notably, he has also worked in desalination and cooling water for more than 25 years in positions in research and development, and is responsible for new chemistries for scale, corrosion, and microbiological control agents. Whereas Mr. Anders Ui is a chemical engineer by training and has more than 19 years of management, technical, and sales experience in the water treatment industry. He was responsible for the implementation, evaluation, and recommendation of treatment programs to some of the largest thermal desalination units in Asia, delivering value to our customers. He strongly believes that Crest Water will continue to provide intelligent solutions in today's challenging business environment by continuously listening to our customers' requirements and innovating to develop customized solutions even in certain niche applications. With this brief introduction, I would like to invite both our speakers to give their talk on innovative solutions in thermal and reverse osmosis desalination. Please welcome, sir.
Thank you, Professor Sarwat, for your kind introduction. I'd like to thank the earlier speakers for giving the introduction to thermal and reverse osmosis, so it saves me time in going through what these are. Today, what I'd like to sort of present is what is currently going on in industry and where water is becoming an essential resource, such that every drop of water is essential to maintain by industry, and also reduction in waste discharge due to environmental reasons, which has been indicated in Dr. Pan's presentation. So today, what I'd like to do is to present to you what is the latest development that's occurring in industry over the last few years. And with thermal desalination, people have gone to what is called zero liquid discharge, and I'd like to go through two case histories where zero liquid discharge systems have been put in place. One, the first case history is on a mechanical vapor recompression chamber system, and the second is an evaporation crystallization plant. I'll go through sort of briefly the water quality, the system parameters, and the problems associated. This is real problems that industry is facing, and some of the results that we can share with you that the company has provided. So, zero liquid discharge desalination, what is it? Basically, it's a process which tries to sort of plant discharges no or very little liquid effluent into the surface waters. These are rivers or seawater or into lakes. It's an engineering approach, and where all the waste contaminants are recovered and reduced to solid waste. And typically, a lot of these solid waste goes to either landfills or to incineration. The key benefits for this is that you have lower waste volumes and recycling of water on industrial sites, which reduces costs and minimizes hazards. And it also improves the environmental performance and regulatory risk performance at the site. However, by increasing the concentration of the wastewater or saline water, then you're increasing the solubility of ions that are present in there, and you're exceeding the solubility limits such that you get deposition of these insoluble salts. In addition to the inorganic, you've got the organics that are present, and these concentrate up and give rise to, in some cases, foaming, and in other cases, it gives rise to deposition and charring in the system. So what we're particularly interested in is, in order to control this scaling and foaming in systems such that the plant can operate efficiently. So before I go on, I'd just like to go on to show you the key features of the Crestapro T series. These are specialized polycarboxylic acids. In the marketplace, there's a number of polycarboxylic acids in place based on polyacrylic or polymaleic type of chemistries. However, these specialized polycarboxylic acids are modified in a way such that the chain structure has been modified such that additional monomers has been introduced into the polymer chain, either in the center or at the terminal ends. And this provides improved threshold effect, which is a phenomenon where you increase the solubility of your inorganic ions such that it exceeds the KSP. The additional properties it gives, it inhibits the growth of crystals as it's forming, so no further crystals are formed. And in addition, it has dispersancy properties, where you've got particles that are coming in the water, such as silt or iron, which can deposit on surfaces, and these specialized polycarboxylic acid disperses them. So the first case history is on the precious metal smelter plant, which uses a multi-vapor decompression system. This is based in China. Fortunately, I can't give you any photographs of the system, but you can see here a schematic diagram of the system where you have a preheater and the evaporation chamber and the loss of concentrate. However, the major problem that occurs in this mechanical vapor recompression system is in the actual chamber itself, where is the falling film system. And what we're trying to do here is to use the system to recoup as much as water as possible and concentrate the waste as much as possible. The water that's going into the system, before it goes in, it goes to a declarification system where it reduces the calcium to between 50 and 80 ppm. However, the water quality is still poor because it has high levels of sulfate ions and chloride ions and sodium ions. But the key thing here is the water analysis indicates that you've got a high loading or potential of calcium sulfate scale formation. The system parameters for this system is that the inlet flow is 60 tons per day. The water type is wastewater from this site. The steam temperature is between 115 to 130 degrees. The temperature of the water that's been treated is between 97 and 106, which is significantly higher than typical desalination systems, where it is between anywhere from the 60 to 70 degrees C. The steam flow is between 2 to 3.5 meters per hour, and the vacuum is around 0.8 to 0.95 megapascals. Before we started the work, we sort of analyzed the deposit that was found in the evaporator, and as you can see here, it had the major ions were calcium and sulfate, which is no surprise, and indicated that was calcium sulfate with a little bit of carbonate ions. In order for scale inhibitors to work, and there are many polycarboxylic acids in the marketplace, and they function differently, with polycarboxylates that are here where we've shown anti-scale at A, although it works to some extent, but it still produces heavy scale formation and also tight clusters of regular shaped crystals. Whereas another polycarboxylate, antiscalum B, tends to clump up the particles and give irregular shapes and can deposit as large crystals onto a metal surface. Whereas the specialized Crestopro T series, you can see here, controls the size of the crystals that are forming, and these are irregular, and reduces the amount of crystals that are actually forming. When we go to the actual results from this field study, the actual steam was generated by heating, and the key things that the customer was looking for is the reduction in power consumption. And as you can see here, prior to using our inhibitor, you can see from 2 runs that they carried out, they were using anywhere from 233 to 230 amps. After using Crestopro T, the ampage was reduced to 194 to 196. So considerable reduction, because the extra heating is required because of the scale formation. And the scale formation, when we looked at it during the trial we conducted, you can see here that the chloride concentration of the brine was anywhere from 1.43 to 1.74. However, the calcium concentration factors were higher than the concentration factor of the wastewater brine. And you can see that the calcium was a lot higher, and so was the sulfate levels, indicating that calcium sulfate was being controlled. But the key thing here is that any pre-deposit that was in the system, indicating that in fact you were producing more calcium and sulfate in the wastewater that's been treated, indicating that the Crestopro T actually removed some of the scale from the heat exchanger surface. The second case history that we'd like to present is from a coal chemical plant, which uses an evaporation crystallization in the northwest of China. And again here you can see a schematic of the zero liquid discharge desalination design. Is based on an evaporation crystallization system. You have a preheater, you have an evaporator, and a crystallizer. And you can go through the schematic at your leisure. But the key issue is to keep this preheater heat exchanger clean. And this was the objective at this site. The water quality that was entering the system had a pH of 7.6 with a sodium ion content of around 4,800 milligrams per litre and a calcium hardness of just under 400. And in this instance, it also had just under 900 ppm of magnesium and high loading of sulfate of around 11,000 ppm, suggesting that the scale would be a predominantly calcium sulfate or even a possibility of magnesium sulfate performed. The system parameters was 45 tons per day using concentrated brine. Again, the internal temperature was around 98 to 100 degrees C, which is higher than your typical desalination systems, which is around 68 to 72 degrees C. The salt content was around 2 to 6 ppm, and the major species that we wanted to control was calcium sulfate. When we looked at the deposition, again, at the scale prior to carrying out our trial, you can see here that the sulfate and the calcium were very high, indicating calcium sulfate, but all to some degree, some magnesium sulfate may have formed as well within this scale. When we look at the operational parameters, we look at the flow over the time, and the yellow line is the heat exchanger inlet flow, and the blue line, a effective zero liquid discharge is occurring, then you want both these lines to be on top of each other. Right? As you can see, prior to using Presto Pro T, that in the early stages there was a vast difference indicating that poor performance of the actual zero discharge systems. Once Presto Pro T was applied, you can see both the flow rates were very similar, indicating that you were removing maximum amount of distillate from the wastewater that was being introduced into the system. When we further look at the system parameters and look at the heat exchanger pressure throughout this trial, again, before the application of Presto Pro T, you can see vast fluctuations, and the pressure of the heat exchanger tubes are a lot higher. With the applications of Presto Pro T, in fact, the pressure is reduced and it's more consistent, indicating better performance of the system. So in summary, both these zero liquid discharge systems have excellent inhibition with the use of Presto Pro T. You get reproducible results, and it supports the operational applications in the efficient operation of these plants. The next system that I'd like to consider is membrane desalination, and Dr. Tiwari went through reverse osmosis in his presentation, so I shall not cover it here. But we'd like to introduce a new inhibitor where we've applied to the system, which is under the Presto Pro R series. This is a new innovation to reverse osmosis because most antiscalars that are used are liquid-based. Again, Dr. Tiwari has gone through the design and benefits of this, but the major issues is fouling on RO membranes. And there's a whole host of scales that can deposit onto RO membrane, reducing the efficiency of the plant and damaging of the membranes. And the predominant scales are usually calcium carbonate and calcium sulfate. These others are minors that you can find. Presto Pro R is a new product that's been introduced into the marketplace over the last 18 months, and it's a solid-based product. Again, it is a specialized solid composite polycarboxylic acid, and it is designed to control scale formation, in particular calcium carbonate, calcium sulfate, and silica in systems. It stops the deposition of suspended solids such as insoluble iron and silt, and thereby improving the operational safety of the system, because you're not using a liquid product, because some liquid products are hazardous because they're acidic in nature, and some plants are still using acid, and to move away from using hazardous materials, the use of this solid composite polycarboxylate will give a significant improvement in health and safety on the site. So this is a Christopher R case history in a plant in Shandong province. And to share some of the results with regards to the performance, it was compared against ATMP, which is a typical phosphonate that a lot of people are using at present. And you can see quite clearly here the delta pressure across the membrane is significantly reduced by using the Crestapro R594 compared to the ATMP, indicating that it's far more effective in controlling deposition on the membrane surface. But in particular, if you look at the percentage recovery over time, you can see quite clearly here that the Crestapro R594 is exceeding the actual design of the 75% recovery, whereas with the ATMP you're below that, again indicating that you're controlling deposition and improving the efficiency of the plant. So by using the Crestapro R series, this is a proven scale inhibitor which controls deposition on the membrane, and it's consistent and reproducible results over time. And the key thing is that because it's a solid, it reduces the hazards and safety issues in the workplace, and hence the introduction of the R series. So, are there any questions on this presentation?
I have a question.
Yes.
Am I audible to you?
Yes, you are.
You also, with your all these products, they are giving like polycarboxylic acid for this anti-scalent. So, do you have any solution for the RO membrane which can provide the solution for sub-temperature storage condition? Like below zero, like -20, -25, if you want to store the membranes for say for 1 year or for 6 months. So do you have any solution for that?
Can you just repeat the question, the final bit? I just didn't catch you. You want storage of
storage composition for reverse osmosis membrane. Like whatever your chemical is there, that is for anti-scaling, for anti-scalent purpose.
Yes.
Yeah. So like this is for removal or removal the scales which are already deposited on the membranes. But what about when the membranes are stored at sub-zero conditions, at say -25, -30 degrees Celsius? We are looking for some different kind of applications. So that's what I'm asking. So at what happens?
Okay. So
yeah. So
what you're looking at? Sorry. As I understand the question, you want to know the integrity of the membranes at low temperatures. Is that what you're asking?
Yeah, integrity of the membrane, and when we are storing the membrane in the wet condition, at the low temperature, then there is a formation of ice, and due to the formation of ice, the membrane actually damages. So like any
yes.
Yeah. So
It's a very good question. So when you do go at low temperatures, there are certain types of antifreezes that you could use to go to low temperatures without producing ice. Therefore, I think you may have to use these type of antifreezes, and we are not experts in antifreezes, unfortunately. And you need to talk to these people such that no ice is produced within the membranes.
Okay, thank you.
Thank you for your question.
I think there are no more questions from the audience, sir.
Okay, thank you.
So, on behalf of the whole organizing team, I would like to thank you for delivering such an insightful lecture. In line with this session, Mr. Enders, would you like to add something to this lecture on your end?
No, I have nothing to add. Thank you.
Okay. Thank you. Thank you. So from whole of the organizing committee, I would like to thank all the speakers who were present in this session. Next, we have a lunch break. So I would like to request all our speakers to please proceed for the lunch. Thank you. Good afternoon, everyone. Good afternoon, Dr. Muslim. Moving ahead with today's session, we have next a keynote talk from Dr. Muslim Demir. I would present a brief bio of our next speaker before we proceed with the lecture. So Dr. Muslim Demir is an assistant professor at Osmaniye Korkut University, Osmaniye, Turkey. He received his PhD in Professor Ram Gupta's lab at Virginia Commonwealth University, USA in 2017. He received his MS in chemistry from Rutgers University, USA in 2013 and his BS from Çukurova University, Turkey in 2008. His research focused on the development of biomass-derived carbon materials for energy storage, conversion, water purification applications. He has published more than 17 peer-reviewed papers and attended prestigious conferences such as ACS, AICHE and ECS meetings. I would like to invite Dr. Muslim to present his talk on applications of MXene-based nanomaterials in water desalination. Please, sir, please grace us with your lecture.
Morning there.
Good morning, sir.
Hello.
Yes, sir. You're audible, sir.
You hearing my voice, right?
Yes, yes, we can hear you.
Okay. Thank you so much for warm introduction about me, introducing me. Again, my name is Muslim Demir. You can contact with me. Also, I am in Turkey. Just hi from Turkey. Thank you so much for inviting me to this great organization and presentation. I'm giving the chance for present my work. Honestly, I am also new in this field. You know, I am working in the MXene-based 2D material-based material, but especially for supercapacitor or lithium-ion batteries. You know, this kind. But also, this kind of material is very promising for the water desalination. That's the reason, you know, I just put this my talk. I will talk about first of all, I will just introduce the MXene 2D materials. As you know, 2D materials is 2D materials actually they are very ultra thin materials, building blocks of the for the future technology, and they have some properties. They have the high theoretical surface area. Of course, they have the more active size, especially for some transition metal carbides or nitrates, and they have the strong electrolyte conductivity, also excellent photocatalytic properties. Of course, when we call the 2D materials, the first come to our mind is the graphene. But recently, of course, some other materials like the hydrogen-borne nitrogen nitrates and transition metal decoration, and of course, MXene is also famous. Of course, MXene is just discovered around 10 years ago in the Drexel University by the Dr. Yuri Gogotsi and Barsu. And they are my also friends, and we expecting that they will get the Nobel Prize soon, especially for the discovering of the titanium-based carbons. These materials actually, when I call the MXenes, that means the transition metals such as the titanium, vanadium, zirconium, and X means also carbon or nitrogen, and X means in the X that's going means that's some X ending groups like chlorine or fluorine or oxygen, something like that. Maxen actually that goes from the board bottom to top bottom, and actually what we do, we after producing the max phases, we just etching some aluminum phases from the max phases. You know, in the max phases, I mean like the metal, transition metal, and in the middle there is a like aluminum or gallium fixed materials. And of course, these actually kind of the porcelain discovered maybe 50 years ago. But just 10 years ago, when we etch aluminum or gallium from the max phases, we just making the 3 block from the 3 block section, we ending with the 2D materials. And there is just a little interlayer distances between these materials. And of course, after the etching, still some the interlayer distance can be very low. That's the reason we make it sometimes the elimination step to introduce the interlayer distances. And sometimes even we can produce the single layer maxines. Synthesis is also like it started with the direct etching with the hydrofluoric acid. Of course, that's mostly well-known techniques for producing the maxines. But later on, of course, molten salt etching, alkali treatment, and even so far, just after the last 2 years, electrochemical etching is also famous in this field. You know, to make the produce the Maxen-based materials. Again, termination groups also based on the synthesis technology, we just getting the different kind of the materials. Up to now, around 30 type of the Maxen is produced, mostly titanium carbides, most of them. And of course, there are lots of opportunity to discover this kind of materials. You know, that's kind of the puzzle. You know, as long as also based on in the graphene, as you know, that's showing only single graphene is just a single property, showing single feature. But in Maxen-based materials, based on the transition metal, even the carbide or nitrogen, and even based on the termination group, we showing the very different characterization. So how we characterize the Maxens? Actually, first things, if you look at the ACM picture, and if you see the interlayer, you know, like the open layer structure, then that's showing the mostly you produce Maxen. Of course, based on the Raman spectroscopy, XRD, and FTIR, you can see how pure Maxen you produce. Of course, from the XPS data, sometimes you cannot produce the 100% of the Maxen because you cannot etch the all aluminum from the max phases. So you can see how much max phases left in the Maxens after making doing the XPS analysis. So of course, like if you compare Maxen with the graphene, hydrophilic and water soluble, like graphene oxide, and also more conductive, stiffer than graphene oxide, and also more transparent than graphene oxide, and also most importantly, this is the hydrophilic materials, and it is you can work with the aqueous solution. And also key properties, they have the high electrochemical conductivity, hydrophilic, and strong and stiff, and of course they showing the very electrochromic properties also. Of course, Maxens after discovering 2011, lots of application of Maxen already applied, especially for the energy storage technology and supercapacitor lithium-ion battery, lithium-sulfur batteries, and they showing great opportunity because I actually also I work in the porous carbon. This kind of material doesn't show any pseudocapacitor properties, but when you use the Maxen, they showing the pseudocapacitor properties and they enhance the capacity a lot. Also, of course, in the catalytical, electrochromic application, electronics, structural, they also they use as a catalyst and sensor, biosensor, environment application, of course, I will just today. So, what is, the application of the Maxine in the water desalination? Actually, this part goes to the three part. Why we using the Maxine in why the Maxine is the promising material for the water desalination? They showing the low contact angle, large interlayer distances, excellent stability in water, high capability, large ion selectivity, and proper morphology, of course. So, Maxine for ion sieving, as you know, based on the size of the ions in the water, especially from the seawater, we can remove these ions from the water based on the size. And you see here I just try to summarize what is achieved in this ion sieving. As you see here, especially for making the composite with the other, such as the aluminum oxide, as you see here, up to 75% of the sodium sulfate can be rejected in the membrane. And of course, different Maxine composite and even different type of the Maxine show different rejection and permeability performances. And also, as Dr. Sanju Tevari talked just 2 hours ago about the capacitive deionization, based on actually that's kind of the capacitor behavior. When you apply the voltage with the anode and cathode, different ions, like opposite ions, move to the anode and cathode. Of course, Dr. Tevari talked about the carbon-based materials, but Maxen also showing very promising result in this section. Let me show here. Based on the voltage, also usually carbon-based material use more than 1 volt, but here even some studies showing 0.8 volt for the even lower current also. That's also important. And as you see here, when you increase the surface area of the Maxens, that's also possible now, but with the freeze drying techniques. And as you see here, up to 45% milligram of the salt can be removed from this section. And of course, when you make with the composite with the nitrogen of Maxine sheets, also we increase the uptake capacity for the ions. And also for the solar desalination, also Maxine showing the good performances. Here, what we do, we making the membrane and evaporating the water from the seawater, and that's showing based on the composite membrane, that's showing also vaporization desalination, also combination of the solar desalination with the ion movement. Ion differentiating, and also this showing the good performances for the Maxine. Actually, lots of study already done in this, Maxine-based material for the removing of the lots of new kind of promising materials Maxen can be produced, and of course we can look at and investigate the application for these things. Thank you so much for listening up.
Any questions from the audience? I think there are no questions at the moment, sir.
Thank you so much.
Sir, thank you for this insightful lecture, sir. Moving ahead with the program, next speaker of the next keynote session is Professor Vimal Chandra Srivastava. So before we proceed with the lecture, I would like to provide a brief introduction to Professor V.C. Srivastava. Professor Srivastava is currently serving as a G.B. Pant Chair Professor and Head of the Department of Chemical Engineering Department, IIT Roorkee, India. His major research interests are in chemical and environmental engineering, wastewater treatment, alternative fuels, desulfurization, solid waste management, etc. He has authored 11 book chapters, more than 215 papers in peer-reviewed journals, and more than 125 papers in conferences and seminars. He has received more than 11,200 citations as per Scopus in June 2020, with H index of 50. He has guided 18 PhD theses, 10 more are in progress. In addition, he has guided 50 MTech dissertations. He has handled several sponsored and consultancy projects with a total overlay of more than rupees 60 million, INR 6 crore. He was awarded the prestigious international award Prosper.net Scopus Young Researcher Award 2010 First Runner Prize for whole Asia Pacific region in an award function held at Tongji University, Shanghai, China. I would like to invite Professor V.C. Srivastava sir to provide us with a lecture on persistent organic pollutant removal via hybrid wastewater treatment techniques. Please, sir.
Thank you for your kind words. I hope I am audible.
Yes, sir, you are audible.
Okay. And I am thankful to all the committee members, especially Professor Saraswat, for inviting me to share my thoughts with respect to the persistent organic pollutant removal for using various hybrid wastewater treatment techniques. So it is my pleasure to be part of the this whole conference, and now I am sharing my slides. I hope this is visible. So, is it okay? Okay, so persistent organic pollutants are nowadays buzzwords with respect to wastewater treatment. And these are persistent chemical substances that remain in the environment for longer duration because of their chemical structures or otherwise they cannot be biodegraded by the common microorganisms present in the biota. And because of their refractory nature, they cannot be degraded as such or as quickly. So what they do is that they remain in the environment for longer duration, and because of which they bioaccumulate through the food web and they pose a lot of risk with respect to human health as well as towards the environment. So it is very important that we should be able to remove these persistent organic pollutants. And because of their nature, if they are emitted via any of the sources including like stacks, so they get transferred in the longer duration, and during rainy season or otherwise they ultimately reach any of the aquatic bodies, and in the aquatic bodies they biomagnify and bioaccumulate. And if any of the consumption of that aquatic body things with respect to water or for with respect to aquatic animals is there, then that reaches our human health also. So that it causes lot of problems with respect to chronic diseases in the human body. So it is very essential that we should be able to remove these persistent organic pollutants. Now, in 2004, the United Nations Environmental Program, actually under that there was umbrella, this treaty came into force, and before that there was a convention held in the Stockholm for discussing the persistent organic pollutants. And after this convention in 2001, the treaty came into force in 2004. Until 2014, more than 180 countries have also already adopted this convention. Now, since India is also part of the convention, so we have to see that we should be able to do work related to removal of these persistent organic pollutants from the environment. Now, what are these persistent organic pollutants? Which are the chemicals which are identified? Generally, these chemicals will be aromatic in nature, and they can be of different types, including most of the most of the pesticides, insecticides, herbicides, many of the other chemicals which are used in the daily life, they fall into the category of persistent organic pollution. Now, there are many POPs which are produced intentionally, which are listed here, and similarly there are many other POPs which get produced when we do secondary things like burning of plastics. So these are the POPs which get generated in the secondary processes that we do for various maybe chemical degradation or waste degradation or other chemical production routes. So, and there are new POPs are also getting introduced. Now this treaty, under this treaty, the member countries have a committee which always looks after the new chemicals and tries to add new chemicals if they find that sufficient literature is available which tells that okay, these are persistent organic pollutants and they must be treated. So we have to be careful with respect to these POPs. Now going further, POPs are recognized in 4 different classes: A, B and C, and some chemicals are under investigation. So you can see here all these chemicals are listed here, and many of the chemicals we know from long, and in particular the chemical engineers are the persons who are generally knowing all these chemicals very well because they are produced in the chemical process and allied industries only. Now going further, the most commonly encountered POPs are like organochlorine pesticides. So these pesticides are used for various purposes, and similarly there are many things which get produced when any organic material is burned, that include dioxin, furans, etc. So these are the classical examples of POPs. Now we as a normal environmentalist or a wastewater treatment persons, we should not only restrict ourselves to POPs. There are many other types of chemicals are also coming into picture, and slowly, and they may also fall into the categories of POPs. All these chemicals are like refractory chemicals which cannot be biodegraded as such. So these different types of other important industrial pollutants, though they are right now may not be listed in the POP, but they may soon get listed into the POP category, and otherwise also they are highly dangerous. So among these are like industrial additives and agents, many of the surfactants that we use in our daily life. Similarly, gasoline additives, also many of the gasoline additives are highly persistent. And similarly, pharmaceutical and personal care products, because we are using them a lot. During COVID also the usage of pharmaceuticals has increased, and also the personal care products usage in the daily life is increasing. And these chemicals contain some of the key elements, maybe halogen, maybe some other element which makes them highly pollutant and undesirable. Now, among the pharmaceutical and personal care products, there are ciprofloxacin, amoxicillin, afloxacin. So many chemicals are there. Similarly, in cosmetic, we use lot of all these chemicals, in particular like benzophenone is one of the base chemicals. So it will be present in many of the cosmetics, and these are like they don't degrade in the environment as such. So they will remain in the environment for longer duration, and as such they cause lot of problem. Now we are using all these pollutants in industries, in hospitals, in households, and ultimately they are reaching our rivers. And the presence of these pollutants in the river is difficult to identify as such because their concentrations right now may be small, and we don't have the facilities also because they require a lot of very high and sophisticated instruments to get them identified at the concentration levels at which they are present in the environment. But since their concentration is continuously increasing, so we should also try to see and identify, carry out studies for presence of these things in the wastewater treatment plant, in the rivers, in the lakes and reservoirs, etc. And also try to adopt techniques so that we can treat all these POPs. Now, pharmaceutical pollution has been, some surveys have been conducted, and they have been identified already in various rivers, etc., and in higher concentration. So there are some studies which have been reported, in particular like Balakrishna 2017 have published with respect to some of the rivers. So we have all such studies which tell that only some studies are there, but they tell already that we have very high concentration of this pollutant in our aquatic environment. Now, recently the Ministry of Environment, Forest and Climate Change of India introduced a reform bill under which the presence of antibiotic residues in the treated effluent has been restricted. And this bill was passed in 2021, I am made to write, and many of the antibiotics have been listed in all these, in this bill. So that means the pharmaceutical industries and others which are operating, they have to now establish techniques so that they need to remove all these pharmaceutical pollutants. Similarly, for cosmetic industry, the bill may come very soon, and similarly bulk drug industry also the things are coming. Now the commercial treatment techniques are listed here. Now most of these techniques, like these are some of these techniques are biological treatment, which is common in India. But since these are POPs, they cannot be treated as such. Now we can use some other conventional techniques like adsorption, coagulation, flocculation, but these techniques do not mineralize the pollutant. They only change the phase of the pollutant from maybe liquid to solid phase. Similarly, the membrane separation, there is only separation going on. So all these processes only change the phase of the pollutant, do not mineralize them and convert them into CO2, N2, H2O, etc. Now, among the various treatment techniques, only advanced oxidation processes can work, and they can mineralize these pollutants when they are present in the water. There are different AOPs which are available in the which are practiced for treatment of water. Many of these are only in the research stage, and they have lot of disadvantages also, and some advantages certainly. So these include like photocatalysis, penton based methods, electrochemical, ozone based, sonolysis. There are many other AOPs, wet oxidation, supercritical. Now all these AOPs have very common mechanism under which they work. So what they do is that AOPs, they generally generate some oxidizing agent when they are used. And these oxidizing agents may be any of these, depending upon the pH at which we are working and other operational parameters and the AOPs that we are using. So what they do is that if any of the recalcitrant pollutant is there, which is not degradable, so these oxidizing agents oxidize them into biodegradable compounds, and then these biodegradable compounds can further be oxidized into CO2, H2O, etc. So this is what is desirable. Now there are many challenges with respect to using AOPs along with their advantages certainly. So the advantages include they have very high reaction rates, they have potential to reduce the toxicity because they mineralize the organic pollutants. So they convert them into H2O and O2. But along with the advantages, there are certainly some disadvantages also along with the AOPs. As such, because many of the techniques individually cannot totally degrade the pollutant. So it is possible we need to use hybrid techniques so that we can treat the wastewater containing POPs and other refractory compounds, and they have been, these hybrid AOPs etc. have been used for treatment of various compounds which are non-degradable, and these compounds include like petroleum hydrocarbons, aromatic hydrocarbons, phenols, chlorinated hydrocarbons including TC, PC, dyes, pesticides, etc. So all these are available in the literature. Now, if we have to use these AOPs in the larger scale, sometimes we need to make them or club them together. So, like one of the techniques is using sono-hybrid AOPs. So what we do is that we add the sono-chemical treatment along with any of the AOPs. So this is possible. There could be other combination of AOPs also, like using phenton with electrochemical or phenton with photolysis. So there are lots of possibilities of hybrid AOPs, and using hybrid AOPs we actually try to done away with the disadvantages that may be there with respect to using individual AOP. So that helps really in the treatment process. So some of the hybrid AOPs which are related to sono have been used by our group also, and some of the like sono electrochemical treatment. So in the electrochemical treatment generally what we do already, Dr. Sanjay Tiwari already had discussed a little bit about this. We use anode and cathode for this degrading the pollutant. But when we are using only electrochemical treatment, one of the disadvantages of the electrochemical treatment is that we have a isolation of electrode that takes place with treatment. Now, if we combine the sono electrochemical treatment, what happens is that the in situ cleaning of the electrode surface happens. So this reduces the electrode passivation problem. This also increases the life of the electrode, and the rate of degradation of the pollutants becomes very high, and that never degrades. So the rate of degradation is always fast. So combining sono and electrode together, we can convert the method into continuous treatment method, and we can use in a larger scale. So this is the good thing with respect to sono electrochemical treatment. Similarly, sono hybrid treatment techniques also have been used, because using the sono with the photo, what happens is that sono and photo combining together, the chances of formation of electron and hole pair increases, and also we can manipulate our photo catalyst in such a way that we can degrade different types of pollutant depending upon their HOMO and photo level, so HOMO and LUMO level. So this is possible to degrade all these pollutants. So there are lots and lots of opportunities for using hybrid techniques for removal of these POPs. We have already performed some studies with respect to treatment of different pharmaceutical pollutants as well as that. Some of the, you can always go into the literature and find out many of the studies. Also, if you want to learn more detail of any of the AOPs, there are many lectures of my own already uploaded on the YouTube, and you can go So with respect to physico-chemical processes for wastewater treatment, and each of the AOPs have been described very well in detail. So you can go and search on the YouTube and you can easily find, and all these are under this category. So this is available. And our research group in the Department of Chemical Engineering works on various processes including wastewater treatment, catalysis, desulfurization, etc. So if any of you have any interest, you can always contact us and we can work together, or any other query is there with respect to treatment of wastewater or any other area where I am working, you are welcome to contact my research group and myself. And our research group is called as Sustainable Energy and Environment and Energy Research Group in the Department of Chemical Engineering. And we do publish a number of papers per year, and we have a lot of facilities also. Please take care of the COVID. You cannot lower down the guard still. So, thank you very much.
Thank you, sir. Thank you for this marvelous lecture. Any questions from the audience? I guess there are no questions at the moment, sir. Thank you again for this insightful lecture.
Thank you, thank you, thank you.
Moving ahead with the today's program, next we'll start our technical paper presentations. The session chair for the next session is Dr. Deepak Kumar Tripathi, who is the scientist at Defense Laboratory, Jodhpur. I would like to hand over this podium now to Mr. Ketan Jangid, Assistant Professor, Chemical Engineering Department, to proceed with the paper presentations. Please, sir.
Thank you, Abhishek, sir. Good afternoon, everyone. The next session is technical paper presentation, and in this direction, the first presenter is M. Shahnur. So I request you, M. Shahnur, please present the presentation.
Sir, am I audible, sir?
Yes, sir, you are audible. Please start.
So my screen is visible, I suppose. So my screen is visible, sir?
Yes, sir.
Okay. Good afternoon, everyone. The first paper, the conference that I'll be presenting here is the topic of the presentation is optimization of solar cells by using artificial neural networking. The work has been done under the guidance and supervision of Dr. Anirban sir. I am a master's student with Pilani Goa campus. So, starting with the presentation. So just a second, my laptop hanged actually. Yes. So, going by the content, I'll be introducing solar cells, the concept of data mining, the machine learning, the process of optimization and tuning, the results that we have obtained, that is BR model as well as LM model, the optimization results, the verification of the results, and further we'll be going to optimization using console as well as the AutoCAD diagram, the finalized AutoCAD diagram that we have proposed in the research paper. Following conclusions and references. So the solar cell is a green technology device which utilizes the solar radiation coming from the sun to heat up the system. And this region, the heat inside the cell can go around 80 to 90 degrees, which makes the bacteria, fungi, and all the microbial growth inside that. So it utilizes the natural light. The pH level stays balanced because of evaporation and condensation principle. The process leaves behind salts, heavy metals, and elements that consist of microbial organisms, fungi, and all other viruses and all. So a lot of research papers has been collected, around 200, 300, and the data were collected, the common data were collected from all the research papers. So as you can see the location, the desert location, the coastal location, the drought-prone regions, and the domestic wastewater regions were involved in all these literature surveys. Basically what we emphasized is we have to reduce the cost of desalination by using some conventional and non-conventional as well as sustainable source of energy. So hence we came up with this concept of data mining. We generated the data from all the research papers that we have encountered. We collected the data in raw form in MS Excel sheets to tabulate it in form of a matrix. After that, we collected these many data. That is the unique idea, the parabolic. The idea consists of the unique design, the materials of construction, the insulation, the paintings used, that is the black paint inside the still to heat up the system, the design type, including the area, breadth, diameter and height of the solar cell, the duration, the span of the day over which the still is being operated, the time, the solar average intensity that the area has, the temperature of probe, basic, absorber, glass cover, as well as the ambient temperature were also needed. These data were collected from the research paper. The cumulative yield and the productivity were the output. That is, in liter per hour, how much water you are getting, how much distilled water you are getting. So, as you can see the arrow legend, these represent the following schematic representation of our solar cell. The process of tuning as like we have done is as follows. Firstly, we tabulated all the data in form of a matrix. Then we fed that to the program file in MATLAB. Then we generated the codes for tuning, which is based on two parameter models, that is LM model, that is Lebeauov-Marquardt method, and the Bayesian regularization, that is DR model. After that, we did some improvisation or we did some modifications in the program file. Then we distributed the data to test for the study, that is for testing, training and validation, because ultimately we are doing the simulation to get the optimized results, and hence we need to understand, we need to first train the algorithm so as it can give us the desirable outcome. After that, we fix the hidden layers. That is, hidden layers are the logical nodes or logical gates that we use to minimize the error, minimize the mean square error value. Then we modified the code and data that considered as an improvisation. Then we ran the optimization to find out the optimum parameters that suited our environment. The basic thing was to minimize the economy of the water purification as well as minimize the installation cost as well as fabrication cost. So the BN model were used. So a number of trials was done. Firstly, the data is 100%. Then we distributed the data in weight ratio, that is 60% weightage was given for training, 40% was given for testing. And then these data were similarly distributed. The first simulation was done in 60-40 pattern, second was 70-30 pattern, third was 80-20 pattern, and the most prominent result that we got was in 90-10 pattern. 90% were used for training and 10% was used for testing, which yielded the R value to almost 0.997. That is, the regression value is near most 1, and hence this distribution was considered as valid for DR model. DR model works on back propagation algorithm. As you can see in the graph, the testing as well as the training set, the graphical representation coincides with the best possible value. Moving on, the DR model, the tuning results are as follows. Here we have varied the hidden nodes. Hidden nodes are basically the artificial neurons, which are the combination of logical gates, which reduces the error and minimizes them. So as you can see, the graphical representation, the RMSE value decreases, as well as the R-square value increases till 1. And it has to be maintained at that particular level. And when we are getting the RMSE value lesser, that number of hidden nodes are considered as the ideal hidden nodes that we have to use in further optimization for running the optimization. So we are feeding the data for training, testing and validation. But here we are using it for training and testing. So here RMSE stands for root mean square error value. After that, we did the LM model. LM stands for Lebeauov-Marquardt method, which is based on the gradient descent method. The similar observation was done, but here there is an additional validation term. The validation helps the program to validate the input parameters to that of the output parameters. So it helps us to authenticate the data. So in this case also we distributed the data in 3 sets, 3 weight ratios, that is 60:20:20, 60% for training, 20% for validation and 20% for testing. So in the second simulation, the similar pattern was observed, 70:15:15, but in the third simulation result, as the value of R was around 0.98 for 80:10:10, we have finalized this as the proper distribution for LM model. LM stands for Lieberberg Marquardt model. So as you can see in the graphical representation, the red and the blue line goes below the best possible line and the green line touches that. That is the data is valid and it is best suitable for giving us the optimum results. Now we had to understand how the hidden layers had to be well. So the hidden layers were also varied to understand the significance of RMC and R-square values. So the training was done basically, the validation was done and testing was done. So the RMC value, as you can see here, these are the percentage error values. So it goes below till 16 hidden nodes. We got the most optimum R-square value, that is 1, and RMC value as like around 75 or 60, and hence the total value decreases, and hence we optimized this result, and further calculations yielded the best hidden nodes were 28. After that, we analyzed the BR versus LM model. Here we tabulated certain parameters, that is we varied the hidden nodes, RMC value, R value, R square value. AAD stands for average absolute deviation, MAP. So here in this case, 28 hidden layer yielded the best optimum results, because in that case we find the AAD value as 5.5, the R square value as 1, and the RMC value as very lowest as compared to all the parameters, that is 46.09. And in the both comparison of BR and LM model, we find the BR model is very best in this case, because the RMC value for the BR model is less at 28 hidden nodes. So the number of epochs means the repetition of the simulation. For BR model were 1000 and for LM model were 90. So after that we did some histogram plotting, where we understood the errors. Errors are the target minus output. So so here what we had done is, we had to minimize the errors. So when we plotted this error versus the instances, these errors, the highest possible error coincides with the zero error value. And this validates the BR model is working and the algorithm is perfectly fine. Then we understood the gradient. Gradient is nothing but the square of some error function, which is the target minus the variable output, which comes out stagnant after certain epochs. The mu stands for control parameter, which should be less than 1 in our case, and it is validated. The Gmax value, that is the maximum gain value, reaches a steady state. The SSX, that is sum of square error, comes out as constant after certain fluctuations. So hence we optimize these results, and when we feed the hidden layers and all the parameters to the optimization algorithm that we have prepared, the optimization results are as follows. The BR model, for the BR model we got these much optimized results, that the productivity stands at 4.4 liters per hour. That is the highest productivity. And for the LM model it was 4.4 ml, that is liters per hour. So in the graphical representation we can see there is a fluctuation or the variation in the yield versus the ml of water collected per day. So hence we can understand that BR as well as LM model are very beneficial, but we need to understand by using the thermodynamics of which parameter, which model suits our system. So we did the first law verification of the BR model, and we came to the conclusion that delta U from the calculation coincides with the delta U with the data that we got. The delta U calculation was done based on the Stephen-Boltzmann law, the radiation losses as well as the convection that is being carried out in our system. So with this information, we got the temperature distribution, then the radiation loss we calculated, the percentage radiation loss we calculated, and hence we got the validating data, that is the del U after calculation is around 21,000 joules, and before calculation, that is with the experimental point of view, we got the similar, that is 21,000 joules. So, with this information we generated the AutoCAD diagram. So these are the optimized results, wherein we can see the fabrication, we can see that there is the geometry, the optimized fabrication geometry. So in this case we had, there are certain aluminum rolls inside that. There is a certain kind of length, breadth, thickness, the width, as well as the internal angle of inclination 30 degrees. So here we with the data, optimized data, we are using here the freeze shrinking material. It may be petroleum wax, wax, or any kind of wax. but which has the maximum highest heat capacity. The cheaper material for material construction was used here so as to minimize the fabrication cost, which is readily available in the market area. The acrylic sheets were used to minimize the breakage during the operation, that is to minimize the cracks and all. Single slope was used here because we can install it at any corner of our house so as to maximize the yield and interaction of heat radiation. The further compound simulation was done using 3 aluminum rolls inside that contains that phase changing material. In the optimized design, we have introduced some kind of improvements, improvisation inside the solar cell. This is just the outer layout of what we have proposed. The inside layout, in the second item, we can see the convection heat distribution inside the solar cell. As the temperature raises, how the heat difference or the evaporation rate increases and changes. The third figure shows the temperature distribution along the machine. So you can see at the slope, acrylic sheet slope, there is the highest temperature because the sun radiations are coming inside, and the aluminum, there are the aluminum tubes which has the highest temperature capacity are shown in the black color. So these aluminum sheets with different grades as well as different thickness were studied, and hence we have to understand which kind of which kind of material is best suited for our system. Most studies will be carried out and has been carried out till now for understanding the heat dissipation and the insulation that we have to understand, and we have to implement in our system for better heat interaction as well as better to increase the rate of evaporation. So the conclusions, in the conclusion, what I wanted to propose here is the cost of fabrication for our improvised optimized system is around 5,000 to 8,000 rupees. The installation cost is around 2,000 to 3,000 rupees. So the total accumulated cost is around 10 to 11,000 per unit of solar cell, including all the utilities, which contains the pump, the thermocouple arrangement, and all of the small utilities that we want. There is no cost of maintenance because we just need water for flushing out the system. That is, the salt deposition is there. We have to just flush it out once in 3 hours. It utilizes a sustainable source of energy, and hence this is very crucial in it. This is a very boosting thing for us to work upon. The maintenance cost is very less because only the electricity is being used to flush the system once in 3 hours or 4 hours after continuous operation. So the total amount of water is being collected is 20 liters of water. That is being, the yield is around 20 liters. And the basin temperature reaches around 100 degrees Celsius approximately when we are running it on a continuous basis, which treats the bacteria and virus wastewater as well, if there are any microbial organisms inside the water. It doesn't allow the organisms to mutate inside. So for the further modifications are being applied to increase the yield as well as heat storage capacity for 24 into 7.
सर वो दिनेश सर बोल रहे हैं जो लिंक गया है उससे वो ज्वाइन नहीं कर
Hello sir.
Yeah, thank you sir. On the behalf of the organizing committee, I thank you for your insightful presentation.
Yes sir. Thank you sir.
Thank you sir. Now in this direction, our next presenter is Nipu Kumar Das. Sir, can you hear me? Am I audible, sir?
Yes sir. Am I audible?
Yes, sir. You are also audible. The title of the presentation is Investigation on Thermal Performance of Carbon-Based Nanoparticles with Cerulean as Nanofluid, a green heat transfer media for solar desalination system. Sir, kindly start the presentation. Yeah, sir, I want to notify here that the time limit is 10 minutes, sir. Kindly complete the presentation in 10 minutes. Thank you. Yes, sir, you are audible, sir. Please continue.
Is my screen visible?
Hello everyone, my name is Nikumar Das. My presentation topic is investigation on thermal performance of silent-based nanomaterial with silent-based nanofluid, a green heat transfer media for solar desalination. These are the outlines that I am going to cover. First of all, introduction, characterization of nanoparticles, experimental method for nanofluids, after the post-convection experiment, result discussion, conclusion, and after the reference. First of all, introduction. Saline we use acid as a base fluid. First of all, saline is generally derived from biomass, which has higher toxicity and so has high boiling point, around 220 degrees Celsius. It has a wide application in the organic chemistry, including amide coupling or urea synthesis and also graphene dispersion also. The solvent should have also advantages at all stages of research and development section. Now, if we come to nanofluid, generally nanofluid is defined as a mix of nanoparticles and solvent. There are two types of nanofluid we have studied. There are mono nanofluids, one is hybrid nanofluid. In mono nanofluid, there are one nanoparticle which is what we have base fluid, where in hybrid nanofluid, more than one nanoparticle this particular batch fluid. How much amount of nanoparticles that this particular batch fluid that is calculated with this empirical equation, where m is the density of what nanoparticle and batch fluid, and the mass of the nanoparticle. These are the characterization methods that I use to characterize the nanoparticle. Electron scanning electron microscope, where surface structure of the nanoparticle is observed, and we have investigated the identity of the nanoparticle through epithet images. Through powder, we can confirm the crystallinity of the nanoparticle, and if there are any functional group presence or not, we can determine through Fourier transform spectroscopy. Further crystallinity structure of nanoparticle we can confirm through Raman spectroscopy. These are properties of nanofluid that is investigated: thermal conductivity, density, specific stability, and viscosity, etc. These are the characterization method of nanoparticle. These are the first two images are epithet images, and second, third and fourth one efficient images. Here we can determine through epithet images we can determine the diameter of the nanoparticle. Here we can see the diameter varies from 20 to 40 nanometer. And from through efficient images, we analyze the surface structure of the nanoparticle. Here we can see several nanometer length of the material covered in the tube. From X-ray experiment, we can see that a short intensity has been observed at degrees Celsius, which indicates crystalline structure of the carbon nanotube. If we compare with the other material carbon nanotube that is functionalized group present, that observe that peak is shifted towards left. This is a PR experiment where we can see there is a functional group presence of NWC in a tube. If we compare with the other functional carbon nanotube, then several peaks were observed. In single material carbon nanotube, there is no peaks appear. So we can confirm that there is no functional group presence. Through Raman experiment, we can confirm that there is no crystalline structure. There is no impurity present in the ocean. These are the experimental method where a nanofluid has been prepared. There are generally two methods: one-step method and other is two-step method. In one-step method, the nanoparticle synthesis and nanofluid preparations are both parallel going on. Where another advantage of using this one-step method is that last thermal stability is very good in one-step method. Right? Disadvantage is that there is no you cannot produce large scale nanofluid. However, in two-step method we can large scale. However, in this method, first nanoparticle is synthesized in a dry powder, and this particular base fluid. And if after mixing, conjugation for 3 to 2 hours, we will apply and then get nanofluid. However, there are several disadvantages case of nanofluid, first of all, stability in nanofluid is very important because in two-step method, stability is very low. So therefore, we have applied several methods to enhance stability of the nanofluid. In stability analysis, there are some methods where we have investigated stability of the nanofluid. First of all, beta potential method, electron microscopic method, sedimentation and centrifugation method, dynamic lens scattering method, and stability enhancement method including gravity addition method, pH value control method, ultrasonic vibration method, magnetic styling method, and ball milling method. These are the experimental setup in Excel. Setup consists generally a testing tube of 1 meter length and a pump where nanofluid is pumped in flow to a tube, and there is 5 thermocouple that on the surface of the tube. These conditions have been recorded, and after that we calculate the heat transfer coefficient through this formula. These are the thermodynamic properties result. Density and viscosity water decreases. Density of viscosity of both nanofluids and styrene decreases with temperature rises. Here we can see the variation of both density phase fluid is very less. However, if we compare with the common state heat transfer fluid, such as quantum heat transfer fluid, the density is very high. In case of viscosity, the viscosity is very less. Similarly, in specific heat and thermal conductivity, here you can see that a higher column spectrum nanofluid less with high value of specific heat. However, after some temperature, it specific heat decreases due to the agglomeration of nanoparticles at higher temperature. In case of thermal conductivity, a remarkable enhancement was observed after addition of nanoparticles in less fluid. However, higher column spectrum nanoparticles with higher thermal conductivity, and it thermal conductivity increases up to temperature rises up to 60 degrees Celsius, and it almost slightly increases. These are stability results where two methods have been adopted. Just visual observation method, another is data potential method. In visual observation method, you have keep the sample. We see the settlement occur after 72 hours, and we measure data potential after 24 hours. We get the result in nanofluid. That is, it can data potential below minus 91 millivolt, and log volume maximum nanofluid is like minus 36.71 millivolt. This high data potential implies high repulsive force, that is increasing the possibility of the agglomeration of particles. That is according to data chart, this is Schweinsberger. Nanofluids are nearly solvent particles having data near about plus minus 30 millivolt. If the data potential is close to 45 millivolt, the stability of nanofluid is ensured. Nanofluid gives extra stability values like about plus minus 16 millivolt. Here we can see that minus 36.71 millivolt is like between plus minus 30 to 16. That we can say that nanofluid one gives a better stability. This is the flow properties result. Here you can see that the transfer coefficient is highest at the entrance of the tube, where higher enough number is higher the transfer coefficient, and it decreases along with the exchange of the tube. And it can be after addition of different volume fraction nanoparticle, a remarkable enhancement was observed. Higher volume fraction gives higher Reynolds number, higher heat transfer coefficient. As you can, Reynolds number 1881 gives higher heat transfer coefficient, and it decreases along with the extension of the tube. It can be concluded due to the nanoparticle size and primary motion of the nanoparticle, heat transfer coefficient increases. The boundary layer thickness really decreases. That's why heat transfer coefficient increases. Along with the as the fluid moves, right, increases, and due to the increase of the thickness, heat transfer coefficient decreases. Similarly, we can see the heat transfer coefficient such as Reynolds number, where you can see that higher volume fraction, that is nanofluid 1, gives better results compared to other fluids. That is nanofluid 2 and base fluid. Similarly, these are the heat transfer coefficient of relative axial distance. At Reynolds number estimate is 1, where nanofluid 1 gives better higher heat heat transfer coefficient compared to the nanofluid 2 and gas fluid. Similarly, this is the water temperature and fluid temperature. Obviously, low nanofluid gives high wall temperatures, and in fluid temperature, low nanofluid gives high fluid temperature along with the axial distance. Now coming to the conclusion point, the characterization of answers MWC nanoparticles using efficient and efficient extract and FTR method. Nanoparticle properties of prepare silent and nanopressure measure temperature range 85 degrees Celsius at commercial heat transfer fluid. The thermal performance of styrene and MWCNT dispersed styrene nanofluids evaluated by first convection experiment and the laminar energy difference heat transfer coefficient and natural number of nanofluids increases along with the axial distance of the tube compared with the base bridge. And heat transfer coefficient and natural number increases the concentration of the nanoparticles, qualification of the nanoparticles. Similarly, wall temperature and fluid nanofluids increases as compared with the base bridge styrene. From this result, we can conclude that styrene is good for heat transfer media, but dispersion behavior of styrene is further study.
Thank you, sir. The presentation was very interesting and informative. And in this direction, now I request Professor Dinesh Kumar sir, our next presenter. The title of the presentation is City Green Waste as Renewable Resources for Electricity Production through Open Air Cathode Microbial Fuel Cell. Dinesh sir.
Thank you, sir. Yes, am I audible?
Yes, sir, you are audible. Please continue, sir.
Am I required to start my video also?
Yes, sir.
Very good afternoon to everyone who are watching my video. Actually, I was trying to open this link since last half an hour, but there were some issues. So I have joined a little bit late. Today, I'm going to present my work on the title City Green Waste as Renewable Source for Electricity Production through Open Air Cathode Microbial Fuel Cell. For this, I am very thankful to the conference organizers of this InDACON 2022, which is going to be held, I think, with the DRDO and MBM University. The work is here done by my MTech student Anupam Pathak. Now I'll start with general introduction to what is there. We all know that we are generating a lot of industrial wastewater, whatever we are using in our life, whether they are clothes, papers, drinks, or whatever, or even the food. We are generating a lot of wastewater which is required to be retreated because water is the most important essential thing after oxygen, which helps us in living. So you can see on the left hand side there is a picture which is showing the wastewater which is being sent to the river, and what we are looking for is the fresh water which is going to be useful for the drinking purpose. So if we look at the processes to treat wastewater, there are basically three types of wastewater techniques. Okay, so there is a primary technique which is basically about screening, sedimentation, skimming, which are used to remove the solids in which no chemicals are used. Then there is biological wastewater treatment technique, which is which uses some organic microorganism which helps in breaking the bonds of the components which are there in the water. This could be aerobic, anaerobic, and composting. And then there is chemical wastewater technique, wherein we use chlorine or ozone in some way so as to treat the wastewater, so make it useful for the drinking purpose. Now we come at the microbial fuel cell. It is basically a kind of bioreactor in which microorganism convert the something which is called fuel to the lower hydrocarbons as well as the energy. So in general we can say that microbial fuel cell is a electrochemical system that derives electric current using bacteria and a high energy oxidant such as oxygen. A typical MFC consists of anode, a cathode and a chamber that separates via cationic exchange membrane. So we can see on the diagram that there are two sides. There is a central side which is a membrane, which is electrolyte or PEM, and then there are on the left side there is anode and on the right side is a cathode. And if we try to understand microbial fuel cell in general, these are basically, as I said, they are basically two compartments. One is called anode, one is called cathode, and anode is colonized by bacteria which oxidize the fuel, that is organic matter, in a final product which can be electrons, protons, carbon dioxide, etc. Electrons flow from the anode to the cathode via an external circuit, and protons diffuses through the membrane from the anodic compartment to the cathodic compartment. So this is just the simple understanding of what is an MFC. So basically a transfer of electrons and protons from one side to the other side. If we go through the literature of MFC, there have been basically two chambered MFC. One is on the cathode side, one is on the anode side, but these days we are also using open air cathode single chamber microbial fuel cell on which the cathode is open to air, wherein oxygen can be uptake from the environment, and the anode is basically there on which the bacteria is going to convert the raw material to the feed material to the less material which is carbon dioxide or other things. So air cathode MFCs are relatively easy to scale up and also cheaper in operation compared to dual chambered MFCs. The operation is simplified with no recycle or chemical regeneration of catholyte, and higher volumetric power densities due to smaller cell volumes can be achieved in a single chambered microbial fuel cell. There is a reaction which is given at the bottom, wherein bacterial fuel which is converted to carbon dioxide and the electrons by the use of bacteria under anaerobic environment, and there is cathode reaction where hydrogen and electrons are converted to H2O with the help of oxygen which is available. Now there are lots of designing problems when it comes to designing of such type of single chambered microbial fuel cell, and as we can see that this would be microbial inoculation, electrode material, ionic concentration, catalyst, internal resistance, and electron spacing. In this case we are basically talking about the catalyst and its modification. So far this is the system that we have used. So our system is basically 8-inch tank by 6-inch diameter cylindrical vessel made up of plexiglass. We have used synthetic kitchen waste, which is primarily glucose. On the anode, the reaction that has occurred for glucose is the production of hydrogen ion and the 24 electrons, and then there is at the cathode there is the reaction which is given in the slide. We have used Sonella putrefaciens as a microorganism which we have purchased from InTech Chandigarh. The work that we have done here is the use of carbon cloth, which is on the one side of which is used as a cathode in this system, and which we have modified by the use of metallic oxide, particularly cobalt oxide in this work. So for the electrode rotation, the cobalt nitrate solution was dissolved in water, which is distilled water, until the cobalt completely dissolved in the water, and similarly 0.05 mole of NaOH was dissolved in 100 ml of double distilled water. Both the solutions were mixed together, and the carbon cloth was dipped like 25 cycles in 40 seconds interval, and like it was dipped and then taken out, dried, and then again dipped. So it is a kind of cycle wherein the cobalt solution was the carbon cloth was dipped in the cobalt solution, and after the 25 cycles of coating the carbon cloth, color to brown color, and the weight, after drying the weight was measured. It was found out that the coating of cobalt oxide is 156 milligram per centimeter square using the weight scale method. These are the mathematical formulas that we have used for the calculation of the current and the power. These are like the formulas which are the basics of any electrochemical estimation. So we have used I is equal to V by R external and P is equal to V square by R external, where R external has been the external resistance and is being varied from 50 ohm to 2 kilo ohm and the output voltage values were recorded utilized to draw the polarization curve. So this is the comparative study for a plain carbon cloth and modified carbon cloth on which open circuit potential were plotted versus time, and we can see that the maximum current generation was observed at the lower value of resistance because of the regularity of more electrons. So both the curves are having the same trends. However, the cloth which is modified with cobalt is found to be having a very high, almost double the UCP value of what we have got. Then we have also plotted voltage versus resistance, and you can see that both the voltage and current are kind of inversely proportional. However, if we look at the voltage for the carbon for the cobalt coated carbon cloth is much higher. As you can see, it is around 560, 570 as compared to what we obtained with the non-coated electron. And you can see that the voltage starts increasing as the resistance increases and attains a value of 560 milliohm. Then we have also done the cyclic voltammetry characteristics of plain carbon cloth and coated carbon cloth. It can be seen that the current that is electron transfer to the electrode is 60 milliampere, which is on the right hand side for the coated carbon cloth as compared to one which was the plain carbon cloth. Also, we can see that the oxidation peak at a potential of 0.5 volt and a reduction peak at 0.125 was obtained, which you can see in case of coated carbon cloth. So normal carbon cloths were different. So we can see that we have obtained a better efficient microgel fuel cells by using this type of by using modification on the carbon cloth. So these are my conclusions that open air cathode chemistry with metal oxide modified electrodes in kitchen waste water was investigated. The study showed that some non-negligible amount of energy could in fact be recovered. In addition to the generation recovery of electric energy, MFC have some additional advantage over traditional biological treatment, as they do not need any energy. In most of the treatment processes, we need energy, whereas in this case we don't need energy. Rather, we are generating energy. And the use of non-noble material catalyst as electrode for energy harvesting device can prove to be beneficial for increasing the efficiency. So this is all from my side. Thank you for listening me with the patient. I am open to questions. Thank you.
Thank you, sir. Is there any question from the participants? Any question? Okay. On the behalf of the organizing committee, I thank you, sir, and thank you, Dinesh, sir, for your insightful presentation. The presentation was very interesting and informative. And in this direction, our next presenter is Sanjeev Yadav, sir. The title of the paper is Ultrasonic Irradiation Coupled Electrochemical Oxidation of Real Wastewater from Paper Mill.
Hello everyone, this is Dr. Sanjeev. Can you hear me?
Yes, sir. You are audible, sir. Please continue, sir.
Share my PPT. Are you able to see that?
Yes, sir. It is visible now.
Okay. Here, this giving the presentation on a work done by one of our ORU students. ORU basically is a scheme in our university where we give the chance to give chance to UG students some research on sponsored projects. So this was a sponsored project from Council of Science and Technology of Uttar Pradesh. So this presentation is basically on the work done from that. So basically in this project, what we did. So let me start little introduction about the wastewater that we use. So we use wastewater from a paper mill, nearby paper mill. So it's a recycled paper mill. So as you know, the paper mill generates wastewater in very large quantity from different sections like paper machine. Paper machine requires water for binding the cellulose fiber together to the hydrogen bond. So they involve a lot of water. When it goes through the different section like the drying and pressing, it releases a lot of water with a lot of chemicals and the fiber in it. Okay, so it has water. So wastewater has content from the paper making, and then this wastewater goes for the wastewater treatment. Okay, so it has a lot of organic compounds coming from the different parts of the paper making process. So as you all are aware that there are different steps of wastewater treatment, including primary, secondary. So generally you will find primary and secondary stage treatment everywhere in most of the wastewater treatment processes. There are few mills where people or the mills uses the tertiary treatment. And you know the tertiary treatment is basically used for remove the compounds which are not removed during secondary treatment, which are generally the complex recalcitrant chemicals such as phenols and the lignin compounds. There are various ways of doing the tertiary treatment such as adsorption or the oxidation, electrochemical oxidation and all. In this particular work, we try to come up with a novel method by doing the coupling of ultrasonic irradiation and the electrochemical oxidation. The motive behind using the UI of the ultrasonic irradiation is to provide the turbulence to the water during the wastewater treatment. You know, if you are is a little bit about electrochemical oxidation, you need to provide some kind of agitation or turbulence inside the water, right? That is created through a agitator placed inside the container, and for which you need an energy, right? So to just get away with this energy requirement needed for providing turbulence, we thought of using this UI. Another major motivation, let me just directly come to, I'll skip the 2-3 slide and then come back to this slide again. This is the slide number 5. The main motivation comes from this also. So why is not only giving the agitation or the turbulence required for the treatment, but it also decomposes the organic chemicals. So if you see, okay, this is the COD and the color reduction by the separate UI treatment. So if you see, we were able to achieve 40 to 50% of the COD and color reduction by the UI treatment. So that was a basically big motivation for coupling these different processes. So this is the experimental setup that we used. If you see, this is a container placed in a space of a ultrasonic irradiator. Okay, you can see different panels placed here, where you can basically we can play with the intensity of the radiation, and you can see the electrodes, cathode and anode, both connected to the electric supply, and we basically change this current bit from here. Accordingly, see the effect of the current density and other parameters on the wastewater. The other important aspect of this work was the selection of the anode material. People have been using lead or lead oxide much, but the problem with the lead or lead oxide is that though it is a cheap, people are using lead because it is a cheap, are not very stable. On one hand, you are treating the wastewater, on the other hand, you are basically again contaminating your wastewater with the lead because of the instability of the lead anodes. So people come up with this, people in paper people say the palladium is a very stable anode, but it is quite expensive. So what we did, in place of just using the platinum only, we basically used a support for the platinum where we needed platinum in very small quantity. So that is why we used Ti/Pt, which means the platinum supported on the titanium. So this is the anode we used, and we used the cathode of SS, I mean the stainless steel. So this is the details about the experimental setup, and this is the wastewater treatment that, wastewater sample that we took from the nearby paper mill. These are the physicochemical parameters of that. It is a kind of having pH around 9, COD quite high, COD 1084 mg per liter. TDS is also high with high salinity. So these are some initial parameters of the wastewater sample. So as I showed initially, we started it with the treatment by separate by treatment, and then after finding that yeah, it is giving not only agitation but also a lot of COD reduction. So before we couple the electrochemical oxidation with this EY, we try to optimize the different parameters for electrochemical oxidation process. And here I am showing you different parameters that we changed and try to determine the optimal value of those. First, we varied the current density, and you can see the COD and color reduction at different current densities. So, starting from 2 MA per centimeter square, we varied it to 8 MA per centimeter square, and you can see from these figures, if you look at the COD reduction figure, there is almost very minimal COD reduction after we increase the current density beyond 6 MA per centimeter square. Similarly, there is not much color reduction after we increase the current density beyond 6 MA per centimeter square. So we can say here that the optimal current density is around 6 milliampere per centimeter square for this particular one. And the next parameter, we varied the electrolyte concentration, which is basically NaCl used in different concentrations. So again, if you look at this, the NaCl concentration varied from, and one more important thing, these are the other parameters that was used. For this case, we used stirring speed around 200 RPM with NaCl concentration 1 gram per liter and the pH 9. Okay, so all other parameters were kept constant, only the current density was varied. Then here only the electrolyte concentration was varied and other things were kept constant. Other things like stirrer speed was kept constant at 200 RPM and pH around 9. Right? So here it also shows that COD is there is not much increase in COD reduction on increasing the electrolyte concentration beyond 1.5 gram per liter. Similarly, you can see in the color removal figure, there is not much increase in color removal beyond 1.5 gram per liter. So again, we can say that 1.5 gram per liter is the optimal quantity of the electrolyte concentration. Then there was another important parameter, that was the RPM, the rotation speed of the vibrator. So we varied it from 100 RPM to 1000 RPM. Okay? And if you see again, this is quite near the COD reduction at 800 RPM and 1000 RPM is quite close to each other. So same for the color removal. We also used other parameters, but because of the time given is quite less here, I am only showing these 3 different parameters. Other parameters is like pH. We also varied the pH. And we determined the optimal So after looking at these three, the variation of these three parameters, current density, electrolyte concentration, and the RPM, we come to the conclusion that the optimal parameters are 6 milliampere per centimeter square is the current density. The 1.5 kg per liter is the electrolyte concentration, and 800 is the RPM, and the pH found around 6. So after this, we combine. This is the work on combining this electrochemical oxidation and the ultrasonic radiation, and you will see that we were able to achieve the complete COD and color reduction within 1 hour of the process. You can see. It was basically a good trial of coupling these two different wastewater treatments. The conclusion from this work is that the coupling of these two process, ultrasonic radiation and electrochemical oxidation, resulted in a very good wastewater treatment. And platinum coated titanium can be a good anode material for this process. The optimal conditions for this process is given like 6 milliampere per centimeter square, and density is this. Initial concentration pH is 6 and 400 RPM. Sorry, this is incorrectly written. This is 800. 100% reduction in COD and color. So the another advantage of this coupled treatment is it not only destruct the organic compound but requires very less energy. Even if when we compared the energy requirement, it was 7 times less than the energy required in case of the agitator required. If we had used agitator in place of the UI, the energy requirement had been quite high. In case it is quite low. So the last conclusion is, or the future work that can be done here is, it can be extended to various other types of real wastewater, such as from textile industry, that so this work is done on the real wastewater from the paper mill, so it proved to be effective for this kind of wastewater. It may not be effective or may be effective for other kind of wastewater. This is what I had to present. Thank you very much for your attention. Thank you.
Yeah. Thank you, Sanjeev sir. Is there any question from the participant? Any question?
I hope I finished on time.
Yes, sir. Almost you have finished on the time, sir. Okay, sir. Thank you. On the behalf of the organizing committee, I thank you for your insightful and excellent presentation. Thank you, sir. Now the next presenter is Dr. Sangeeta Madam. The title of the paper is Effect of Substrate Material on the Overall Efficiency and Photo Efficiency of SRTI-O3 Photoelectrodes. Sangeeta Madam, please start the presentation. Thank you.
A very good day to all of you. Am I audible?
Yes, madam, you are audible. Please continue, madam.
Okay, thank you, thank you. The topic of today's presentation is effect of substrate material on the overall efficiency and photo efficiency of sodium titrate photoelectrode. Now, energy is the first rank among top 10 problems to the humanity. When come to its solution, there are only three solutions we can see, either reducing the population or changing people's lifestyle. But electrolyte present at the outer electron. Now, the main component of photoelectrochemical cells are photocathode, photoanode, electrolyte, and bias potential. Because the potential applied by solar energy is not sufficient to electrolyze water. There can be three types of assemblies: a photoanode and a cathode, which is pure metal. Either a photocathode
Thank you, madam. Is there any question from the participant? Any question? Okay. On the behalf of the organizing committee, I thank you, madam, for your insightful presentation. And the presentation was outstanding, madam. Thank you. Now, the next presenter is Rudra Rath, madam. The title of the paper is Design of High Power Density Pressure Retarded Osmosis Membranes using Artificial Intelligence, Machine Learning Based Modeling and Optimization. Yes, yes, madam, you are audible and screen also visible.
pertaining to the membrane characteristics or type of membrane, polymer, solvent, membrane area, thickness, water permeability, salt permeability, structural parameter, salt rejection. Also, we have taken into account the operating parameters such as draw used, feed used, the molarities, the flow rates, as well as operating pressure. Our final target output was the water flux and power densities for best performing membrane. The water permeability should be maximum, fault and structural parameters should be minimum to yield the maximum water flux and power densities. So this is the diagram of the artificial neural network. Here we have the input. This is the input layer and output layer also. We have one hidden layer. So two artificial neural network models were explored, the Ravenberg marketer and Bayesian regularization, along with the combination of three activation functions, that is the hyperbolic tangent sigmoid function and logarithmic sigmoid function in the input and output layers. The formulas for the respective functions are given towards the right. The hyperparameters and the number of neurons in the hidden layer were optimized for each of these, resulting in 6 models with optimal ANN networks. The models are compared with statistical criteria such as R, R square, RMSE, that is the mean square error, and AAD. And the best performing models are used for inverse design by solving multi-objective optimization. These are results. The graphs represent the input contributions, that is the contribution of the input parameters towards the output, that is water flux and power density. The tan sigmoid activation function in both layers with ANN and VR model was found to be the best performing, as the R-square value of this was 0.97 for water flux and 0.98 for power density. Membrane properties like the type of membrane, thickness and water permeability coefficient were found to be the major contributing factor for the prediction of water flux, while in case of power density, pressure was found to be the major contributing factor. This table represents the final optimized data given out by the board. The maximum water flux was found to be 147 LMH and the power density was given as 87 watts per meter square. This current work throws insight into the best membrane and operating parameter combinations for the optimal PR performance. Future work will include more research on the synthesis of membranes and validation of the optimization results in pilot scale experiments. With due thanks to the co-authors, I'd like to end my discussion here. Thank you.
Thank you, madam. Is there any question from the audience? Any question? Okay, thank you, madam. On the behalf of the organized committee, I thank you for your insightful presentation. Now, the next presenter is Rituja Bhose, and the title of the paper is Graphene Oxide Based High Performance Thin Film Composite Reverse Osmosis Membranes for Seawater Desalination. Rituja, ma'am.
Am I audible to you?
Yes,
sir?
yes, madam, you are audible. Please continue.
Hello everyone, my name is Rituja Bhose and I am presenting my presentation on graphene oxide and functionalized graphene oxide as a functional material embedded in polyamide based thin film composite reverse osmosis membrane for desalination. So, with the human population growing each day, there is an increased need for the fresh water. Desalination can solve a number of problems and produces water that will help support the different population. Here we are discussing about the thin film composite membrane which we have used for our project. So thin film composite membrane uses the reverse osmosis techniques. Reverse polyamide membrane which decides its performance. And the polyamide membrane formed by using two monomers, that is MPD, that is metaphenyldiamine, and the TMC, that is trimethyl chloride. These two monomers helps to form the polyamide membrane. Here we are using graphene oxide and functionalized graphene oxide into the TFC membrane to enhance its performance. What exactly it does to the membrane? It increases the high water permeability, separation efficiency, thermal stability, high mechanical strength, and which act as an antibacterial agent for the membrane. Here, my aim of the project is to study the effect of higher concentration of MPD while synthesizing the TFC membrane. Many of the literature reported that is 2% of with the 2% of MPD, they have prepared the RO membrane and tested at 2000 ppm of NaCl solution. But our aim is to check the SWRO membrane, that is with the 3.4% of MPD solution into while TFC membrane synthesis, and check the effect of GO into the desalination application at higher fluid concentration, that is 32,000 ppm of NaCl solution and 55 bar of operating pressure. And we are using here, that is sulfonated graphene oxide and graphene oxide nanoparticles to check the difference between the performance study of these two nanoparticles into the TFC membrane. Here is the procedure I have given for the sulfonated graphene oxide synthesis. The diazotation method is used to functionalize the graphene oxide, which involves HCl, sodium nitrate, and sulfanilic acid. And this procedure is carried out at 0.0 to 5 degrees Celsius. Here are some characterization I have given, which confirms the nanoparticle synthesis, that is XRD, Raman, and TM. The major steps to synthesize the TFC membrane. The first step is the preparation of polysulfone support. That is, polysulfone and DMF solutions solutions together makes the polymer dope solution. The non-woven support is attached to the glass plate. This dope solution was placed onto the glass plate, and the casting knife is used to cast the membrane onto that non-woven support. And final, the PSF membrane we have got from the phase inversion process. Second step is synthesis of polyamide based TFC membrane. The similar PSF membrane was dipped into the MPD solution, where we are using GO and SGO nanoparticle. In the MPD solution, we dip the PSF membrane for a particular time. Then we remove and squeeze the membrane with the rubber roller to remove the excess of MPD solution. After that, hot water treatment and post-treatment was given to the membrane at 90 degrees Celsius, and post-treatment given to the membrane by using NaCO3 solution. The final TFM membrane was schematically shown into the PPD, that is GO and SGO present into the polyamide layer, and below that it is polysulfone membrane. This is the performance of the GO-based TFM membrane, where operating conditions, that is SWR operating conditions, 32,000 fluid solution, that is NaCl solution, and pressure is 55 bar. The optimum result, we can see that we have changed the GO concentration from 0 to 0.1% with respect to the MPD solution. And at 0.025, we got an optimum result, that is 36.80 LMH, and the salt reduction is 99%. We can see that after the 0.025, the salt rejection is continuously decreases as the flux is increased, but salt rejection is decreases. So we confirm the optimum results we can get at 0.02. The comparison of the performance of GO and SGO based TFM membrane is given in the table. Similarly, as similar performance study has been carried out for the SGO based TFM membrane, where we can see the water flux and the salt rejection for GO and SGO
Okay. Is there any question from the participant? Any question? Okay. On the behalf of the organizing committee, I thank you for your insightful presentation. Uh, our next presenter is Preeti Kumari. The title of the paper is Effect of Multifunctionalized Multi-Walled Carbon Nanotubes on the Anti-Fouling and Antibacterial Property of Polyethersulfone Hollow Fiber Membranes. Preeti Kumari, madam. Yes, madam, you are audible. Please continue. Madam, it is requested, please switch on the camera also. The presentation time is 10 minutes. So I request you please complete the presentation in 10 minutes. Presentation is not visible, madam. Slides are not visible. No, madam, still it is not visible. Yeah, I think, yeah, it's visible, madam.
Thank you. Good evening, everybody. I'm Preeti Kumari from IIT Bombay. And today I will be talking about effect of multifunctionalized multi-walled carbon nanotubes and antibacterial properties on polyethersulfone hollow fiber membranes. So, membranes have been widely used in different
Excuse me, madam. Sorry to interrupt you. Actually, the time is over. So, can you conclude quickly, madam?
Yes, sir, yes, sir.
Yeah, okay.
So then we have evaluated antibacterial property by taking E. coli as a model bacteria, and we found that M3, in which highest amount of CNT was introduced, showed increased CFU, which is colony forming unit, is a unit of measurement of live bacteria. So it could be due to the antibacterial nature of MWCNTs, multiple carbon nanotubes. So in this study, we have used polyacetone CNTs and PPJs and prepared these membranes, and the cross-sectional view showed the incorporation of these CNTs, and it resulted in increased hydrophilicity and reduced surface roughness, and shows better flux recirculation and protein adsorption, and reduced colony forming unit count. So based on these findings, we can say that these are suitable for wastewater treatment applications. And finally, I would like to thank my guide, Professor Jayesh Pillare, my RTC members, Professor A.K. Suresh, Professor Vivendra Sethi, my lab mates, IIT Bombay, Victory, WRCB for funding, and the organizers of InDACON 2022. Thank you.
Okay, thank you, madam. Is there any question from the audience, from the participant? Madam, I want to ask one question. In your study, what kind of isotherm adsorption you found?
Isotherm absorption. Sir, in this, I am just I have just measured the protein absorption using protein analysis PCA kit. Not any absorption isotherm.
So I think, did you found the type of isotherm in your study? Means
No, sir,
isotherm adsorption. Okay, okay, madam. Thank you. Okay, madam. On the behalf of the organizing committee, I thank you for your insightful presentation. The presentation was outstanding. And our next presenter is Deepa K. Madam. The title of the paper is Separation of Lignin from Sawdust with Support of Alumina Nanoparticle Integrated Polysulfone Nanofiltration Membranes. Yeah, Deepa Madam, slide is visible. I request you please on the camera also.
With the support of aluminum nanoparticle integrated polysulfone nanofiltration membrane. I'm doing project under the guidance of Dr. G. Arunarishnan, National Institute of Technology. Lignocellulose is a low-cost biomass that abundantly available. The main constituent of the biomass are cellulose, hemicellulose, and the lignin. In more than the plant-based biomass, approximately 30% of lignins are present. This lignin is used as a value-added product. It is always combined. Lignin is basically combined with carbohydrate lignin complexes. In order to get high purity of lignin, it is necessary to unlock the lignin carbohydrate complexes. Membrane filtration is found to be a promising technique for recovering the high purity of lignin. The major limitation by using membrane technology is fouling. These fouling may clog the membrane pores, which leads to dependent separation efficiency. So, in order to overcome these fouling issues, nanocomposite membranes have been used. So, for aluminum nanoparticles, a significant number of hydroxyl group which provide a better hydrophilicity to minimizing the membrane closure. There are different shapes of aluminum nanoparticles such as spindle, cubic, and spherical shapes are there, which can be obtained by the calcination process. So, based on our knowledge, the different shapes of alumina have not been used as additive for the membrane fabrication, and these also expected to attain improved flux rate and good separation efficiency of transition and functional group of alumina nanoparticle and to characterize microalgae morphological and surface property of alumina reinforced membrane and to extract the lignin from hot water rehydrolysis of teak wood sawdust. The alumina nanoparticle was synthesized by chemical purification method. 20 gram of alumina nitrate was mixed in 30 ml of DRDO water. The NaOH was used as a persistent reagent. After precipitating, this was treated under ultrasonication treatment and it was subjected to oxidants to remove any foreign substances. Then it was rehydrated. Then it was pre-dried at 110 degrees Celsius for 10 hours. After that, it was undergone the calcination treatment. 4 different calcination temperatures was maintained, that is 250, 500, 700, 900 at 4 different calcination temperatures, 4 different types of.
Ms. Deepa, please check your mic whether it is unmute.
In FTR analysis,
Yes, you are audible.
found for fabrication of membrane, polysulfone was used as a base polymer and 4 different types of alumina nanoparticle has been used. In casting solution are made using 4 different types of alumina nanoparticle and then polysulfone was used as a base polymer. Then 99% weight percentage of polysulfone has been used and 1 weight percentage of alumina has been used. The polymer miscibility occurs at 60 degrees Celsius. After it is completely dissolved, then it was poured on the clear glass plate and cast the membrane using casting rod. Then it was immediately immersed in the coagulation bath at 10 degrees Celsius to get the phase emission process was occurred and then membrane formation was done. And then the functional group and the crystalline nature of alumina present in the membrane was confirmed in the FTR analysis and then XRD analysis. In FTR analysis, the wave number occurred at 2920, which confirmed the CH stretching of PSF, and the wave number occurred at 1153, which confirms the CC bond, and the wave number occurred at 490, which confirmed the AL vibration mode. And then the resultant displacing in XRD analysis, the resultant displacing value occurred 2 theta at 47 degree was identical to peaks that confirm the incorporation of alumina nanoparticle which present in the membrane. In morphological study, the nanoparticle was evenly blended and dispersed in the alumina incorporated membrane. And then it was noticed that membrane enlarged pores has been occurred in the cubic shape of alumina when compared to the other polymer membrane. This is because of the addition of high pore volume of alumina nanoparticles. The surface wettability nature and surface roughness of the membrane was studied in contact angle analysis and AFM analysis. The contact angle value of pristine membrane was very high when compared to the alumina nanoparticle incorporated membrane. This is because the hydroxyl group of alumina nanoparticle, which more prone to improve the hydrophilicity to the membrane, and then water droplet present in the membrane surface which migrate towards the membrane and absorb all over the membrane core. So the high hydrophilicity has occurred in the alumina incorporated membrane. Then the extraction of lignin was extracted from the teak wood sawdust using the hot water rehydrolysis pre-treatment method. 30 gram of sawdust and 100 ml of DRDO water were thoroughly mixed in the mixture autoclave at 170 degrees Celsius. And then during this reaction, hydrocarbon ions was formed. This helped to clean the lignocellulose bond, that is carbohydrates and lignin bond. Then after that, separation of lignin was occurred in nanofiltration module. This is the nanofiltration setup. The filtration studies were performed in the filtration module. Flux was calculated by volume of unit by area of membrane into the time. The separation of coefficient of membrane was performed using The few water flux was significantly raised after the integration of polymer nanoparticles. And then the filtration performance was tested using the monovalent and divalent salt. The flux rate was high at the high ion solution because it can pass through the membrane pores easily at the lower concentration. The average distance of the electrostatic interaction between the ions and the membrane weaken at the higher concentration. And then the divalent ion reflection was very high because the thickness of the electrical layer of the membrane becomes thinner at the higher divalent ion concentration. And then for synthetic leading solution, the solution flux of the membrane was very high at higher pH. At the acidic pH, the membrane exhibits the higher solution flux. The pH value rises from 3 to 9. The solution flux decreases to 9 significantly. The rejections of at pH 3, the corpuscle group in the beginning interacts with the membrane surface through the hydrogen bonding, so it leads to have more absorption. At specific time, the rejection is declined due to the lacking of absorption sites. The membrane has got a negative charge at pH 9, so the degree of electrostatic repulsion force becomes very high. So the rejection of the lignin was very high at the pH 9. Then the separation efficiency was testing with the pre-hydrolysis filter. The nanoparticle embedded membrane which acts as an active phase for attractive lignins, and to separate could pass through the membrane and the lignin will retain over the membrane. So the rejection of the lignin was very high. The maximum lignin separation was at 98% in nanocomposite membrane. And coming to conclusion, lignin was effectively separate from pre-hydrolysis sawdust and synthetic lignosulfonic acid solution using nanoseparation with a clear treatment. The same analysis which confirmed the aluminum nanoparticle different shape of aluminum nanoparticles in distributed cylinder shape. The various shape of aluminum nanoparticles are investigated into the polysilicon fabrication of symmetric membranes, and the polysilicon aluminum symmetric membrane performed by lignin and monovalent and divalent salt solution. The cubic shape of aluminum nanoparticle reinforced membrane exhibit uniform alignment of membrane force has achieved higher rejection rate of 19.6 and 91.9% of lignin from dehydrolysis biomass and synthetic folic acid sodium salt. Due to the higher purity of lignin separated using polysilicon aluminum symmetric membrane can be compared to drive the phenolic compound to obtain the phenolic compound as a value-added product. I thank my research supervisor, Dr. Internation, and I especially thank Newton Baba for funding, and I wish to thank my research group. And within the session, I take this opportunity to thank Indian Engineering College and Indian Desalination Association. These are the selected reasons, and thank you.
Any questions from the audience? Since I guess there are no questions at this moment. Thank you for your presentation. So proceeding with today's event, I would like our session chair, Dr. D.K. Tripathi, to conclude this technical session. Please.
So, good evening, everybody. I hope I am audible to all of you. In this online presentation session, 9 papers were presented. All the papers, of course, as you know, this conference, this international conference is organized in association with Indian Desalination Association. Most of the papers have been on the desalination of water, treatment of water, purifying water, retrieving water, etc. So numerous technologies developed on these aspects have been presented. Some mathematical modeling also in the 9 papers. The papers presented have been highly informative to the audience, either in front or online. I wish the same motto and theme continues, and we come up with more technologies developed, themes invented, and to be presented in next such sessions to come. With this, I thank and I wish all the presenters all the very best, and I thank the organizers to give me an opportunity to chair the session. Thank you.
Thank you, sir. Thank you for being with us. So with this, I would like to announce the end of first day of this international conference on desalination and water treatment. Thank you for all the speakers who were present with us today, and thank you to all the participants who presented their research work with us. So with this, we mark the end of today's sessions. Thank you.